Hi. Fine, and you?
Excuse me.
Hey, how are you doing? Long time no see. You're presenting now or? Okay, good luck, man. When I get some water.
People told us after that, but let's from the plane, Is starting already?
Hi, welcome to the Inequality and Macro groups. We're thrilled to have you. Unfortunately, Roland could not come this year, but he sends his hi to everyone. A few announcements. One is you're supposed to respect the NBER rules of conduct. We've all signed with respect to that. In terms of the organization, the speaker gets 35 minutes, the discussant gets 15, and then open discussion for 10 minutes. I'm going to ask you, if you're doing open discussion, not to give you our own model for 10 minutes, but just to really ask questions so that we can all participate. What else did I have to say? Those of you who signed up for dinner, we could meet 15 minutes maybe before in the lobby to walk over. So dinner is at 6:30. So why don't we say we meet at 6:15 in the lobby? But otherwise, you know where it is, hopefully for Lexington. What other announcements do I need?
Maybe just I think they're gonna be on YouTube, so it's
Yes,
if you're
thank you.
speaking, like stay by the microphone.
Okay.
Yes,
And then if you're asking questions, I think we have microphones here too, so
yeah,
that's
try to
it's not
remember.
like always easy, but that's good to.
I know, what might say move up, and so you'll have to stand up and use the mics. If you want to be memorialized in YouTube, and also it's just more fun for everyone. Okay, so without further ado, we have Warren and Inequality. Seems like a great way to start.
Yeah, so thank you so much for having me. Really looking forward to the next 2 days. So this is a joint paper with Tim Meyer, who has just joined UT Austin and is here today with us, with my colleague from Tübingen, Gernot Müller, and with Moritz Schulerek, who now heads the Kiel Institute. So in this paper, we ask how war impacts inequality, and importantly, through which channels. Of course, we are not the first to ask this question. There's many econ historians who have studied lots of cases, and there's an ongoing debate whether war is the great leveler, a term coined by Walter Scheidler. What we provide here is the first macroeconomic quantification of, first, how much does war actually change income and wealth inequality, and second, through which channels. And here we aim to quantify destruction, taxation, and inflation. These are three channels that center in this debate from the econ historians and the larger econ community. We do so by collecting a comprehensive data set of all war sites for which there is data on inequality and data on these potential channels. So our main empirical setup is going to be a cross-country regression, and then on top we have collected additional data, for example, for a panel of German towns that I will show you later, that allows us to more directly understand the impact of destruction. We then turn structural to decompose and understand this transmission mechanism. So the first step here is going to be a simple income accounting exercise that will link capital income to wealth and income inequality. And then we go full quantitative with an estimated Hank model. So let me quickly give you the main result before I go through the details of all of these. So empirically, we find that war strongly reduces top income inequality, but there are much smaller effects on top wealth inequality. So this is surprising at first, since destruction, which is a salient feature of war, directly affects wealth. However, a simple income accounting exercise already delivers this qualitatively. So think about a 20% haircut to everyone's welfare. So this will make us all poorer, of course, but the relative distribution of wealth will stay the same in this room. Now, when you think about top income, that's different. If I take away 20% of capital income, the very top of households, they mostly rely on capital income. They have very little labor income. While I, for example, will rely just on labor income. Yeah? So there will be redistribution, a compression. So the same proportional haircut can leave wealth inequality untouched, but can compress income inequality. To fully quantify this in the data, we then go to the Hank model. And it can match the reduction in income inequality that we find. And key is here not just destruction per se, but the endogenous response of profits in the model. So you can think of profits as a very concentrated form of capital income. There's average capital income, and then there are profits that accrue to business owners or stock market participants. So that's a more select group of capital owners. So this kind of supercharges this mechanism and leads to an even further compression of the income distribution. We also find in the model that taxation matters, especially for wealth inequality, as households respond to higher taxes on wealth and, for example, save less. And then finally, we also do find a role for inflation, but inflation is mostly about redistribution between borrowers and savers. So it doesn't matter too much for top wealth and income inequality. So that's the paper in a nutshell. And now I will go through each of these three in more detail and show you what we do. So we collect 4 types of historical data. So in terms of income, we look at the top income shares, the top 1 income share, and wealth shares. We take this from the World Inequality Database. Destruction we measure by looking at the capital stock or country-level destruction estimates. Taxation we measure by looking at top marginal tax rates that we collect for these different countries. And inflation is just measured by the price level for these countries. So most of this data comes from established data sources. But for each of them, we went above and beyond to look at gaps in wars, to look at new data. So Tim here did a really outstanding job to collect all of this new data and fill all the gaps. So for example, we have this new country level destruction estimates. We have a new series of firm profits, as this turns to be the key margin in the model that is important to match quantitatively the data. So we collect data on this, and then we also have this new panel data on German cities. So I'd say it's a really comprehensive data set on what happened during war times. The overall sample then, our baseline sample, is these 16 war episodes. These are really all the wars where we do have inequality data and data on the channels. And we restrict the sample to look at wars that have more than 10,000 casualties on their own soil. So these are large wars that might come with large destruction. We also have a larger sample where there's another 10 observations where we also take the smaller war sites in, and then results are robust to that. And this is not to show you, it's not just about Europe, so there's lots of European countries as well, but there's also Japan, there's India, in the larger sample, there's also Israel, there's Peru. So these are basically all the wars from 1870 to 2020, where we do have this data that we need to study the underlying channels and the effect on inequality. The regression framework then is pretty straightforward. So we treat the war onset as a shock in our local projection. So the local projection, to first give you the equation, looks like this. We look at the changes of, for example, income inequality relative to the year before the war and how that changes once the war starts. So this is our dummy of interest. And then in the controls, we allow for lags of this dummy and lags of the dependent variable. So in order to take out any kind of pre-trends that are in the data. So, of course, war is not one clean structural shock. It's not like a monetary shock. So it's a combination of shocks. But that's why we try to tease out later how these different things like inflation, taxation, destruction, how they move with that shock. The other thing is, of course, war start is not completely randomized. We did look into casus belli classifications, and that supports at least exogeneity to current economic conditions. So typically wars are not started because of the business cycle or because of inequality per se, but because of nationalism or because of other kind of ideological reasons. So in that sense, there's some reason to believe that this is not directly related to the inequality that was in the country before the start of the war. So it's a very simple regression. Let me show you the results of how war changes inequality over time. This is our key empirical finding. And what you see is that on the left-hand side, the top 1% income share drops by around 25% after 10 years, 10 to 12 years. So it's a substantial fall in top 1 income inequality. The average war duration is around 5 years. So the peak is arrived at after end of the war. Then on the right-hand side, you see the top 1 wealth share. So here the drop is substantially smaller. It's just 10%, and it's not as persistent, so it reverts at the very end. So that was already surprising to us at first, because when you read about the great leveler and Walter Scheidel, it sounds it's mostly about destruction and destruction of wealth. But in the data, the response of income is double, twice as strong relative to the response of wealth. Given that we have this rather simple local projection, we do all kinds of robustness checks. We check, what if we leave out world wars or just do the small wars, include them? What if we do have a quantitative measure of war, so not just a dummy, but a measure of how many people are killed? What if we do different interpolation? I can show you one of these. So what if we do leave one out? So we leave always one war out and run this regression again and again. And what you see is that the overall estimate doesn't depend on one single war episode. So it's really a similar picture that emerges from all of these different wars that we have in the data. Good. So let's look at the most visible channel first, destruction. So on the left-hand side, you see the capital stock, and this falls around 25% and then recovers afterwards. And on the right-hand side, you see the capital to labor income share. And it's not just that the capital stock falls, it's also capital income falls. Capital income falls by up to 50% here. So this is clear evidence for large destruction in these countries where the war is taking place, in these war sites.
So these are years of war or years
This is
after the war?
after. So this is the start of the war. Then the average war takes 5 years, and then you're after the war.
So it depends on the country.
Yeah, it depends on the country, exactly. So basically, you could say this nicely aligns with the end of the war. So the median war ends with 6 years, and then capital returns. And there's also a strong response for the other 2 channels. So here on the left-hand side, you see the top marginal tax rate, and this increases, during and after wars by more than 60%. So there's a strong increase on taxation of the kind of top 10% or so of income. And on the right-hand side, you see the price level, and there's a substantial increase of around 70% in the price level. So here we provide evidence that these mechanisms that are debated lots do actually happen in the data. There's very strong destruction, increase in taxation of high earners, and increase in the price level. Now what I can do with this new data that we collected on German cities, I can link more directly destruction to inequality. So here what we did is we digitized German town level income tax tabulation from 1928 to 1954. And then what we do is we also collect the share of housing destroyed, a direct measure, a proxy for destruction in these cities, and then we correlate the 2 here. And you see this clear patterns that cities that are destroyed more, like Cologne or Hamburg, they see a larger fall in top 1 income share. So kind of the elasticity in this regression is 4. For 10% more destruction, you see 4% fall of top 1 income. Of course, destruction of cities is also not random, right? So that's why we do some extra robustness, like we do control for the sectoral decompositions of the cities where there's a large industrial base, and we also have an instrument, distance to London, because in the beginning of the war there was basically a limitation of how far these bombers could go, and you would first start more the western side of Germany before going to the east. And these results also work with this IV of distance to London. And this is evidence that there's a direct link between destruction and the change in income inequality. So it's the change from just before the war to just after. So we do like 39, right?
36 to 50.
Yeah.
Or 30.
So we
Like that, yeah.
And we take the closest dates that we have to the war. So it's basically over those, almost 10 years from before to after the war. Now, the nice thing about this is this holds constant, for example, inflation, it's within country. Yeah? So it takes out inflation differences. It takes out, for example, also taxation when the federal government increases, income taxation. This is not part of this picture. This is differenced out. Yeah, we have, time and city fixed effect. It's just about variation in destruction across these cities. So then how can we link that? Let's turn structural and go to that simple accounting exercise. So this is based on Mead's income share accounting from the 60s. So when you think about the wealth share of the top 1%, it's just capital owned by this 1% over total capital. That's the wealth share of the top 1%. Now destruction works like this. Destruction is here D, just the proportional destruction of all wealth of capital. And that's why it's in the numerator and the denominator and it canceled. So these relative shares don't change. That was the intuition I gave you at the very beginning. On the other hand, even with proportional destruction, you get an impact on income inequality. Here on the right-hand side, you see that the top one income share, you can think of this as income coming from labor and income coming from capital. And then the destruction of capital will only impact my capital income. So here I expanded this as a capital to labor income share. So now it really depends on how much of your income comes from labor and how much comes from capital. And if more of your income comes from capital, then your share in total income will fall. So when you think about this, the top 1% typically has lots of income coming from capital, but labor is not so important. I can illustrate that here with data from pre-war France. So we collected this kind of income composition for a couple of countries. I think we have 5 or so, and they all look the same. So when you look at the French data, on the left-hand side, you see the composition of portfolios between the aggregate and the top 1%. And they look pretty similar. So for example, here you see business assets making up like 50% of the top 1%, and also a large number like, around 40 or so for the aggregate portfolio. When you look at income, this looks very different. So for income, the business income is more than 50% for the top 1%, but it's around 20% for the aggregate. So when you just now destroy all of these assets, then the aggregate and the top 1%, they are similarly affected to some extent. It's almost proportional, but that's not true for income. So for income, these top 1% is more heavily affected if they lose capital income. That's exactly the intuition behind that simple Mead formula I gave you earlier. Now we can ask, can this explain what we have estimated in the data with our local projections? So here you see the decline in the capital to labor ratio, and we estimate just after war that this is on average 25%, and then we can plug it into our formula. And what you get is in our formula that overall top 1% income should fall less than 10%. While in the data, it's more than 20%. It's around 23% or so. So you can roughly just explain 1/3 with the simple formula. So the simple formula, of course, assumes proportional destruction. It assumes there's just one type of capital income, just capital and labor share. So it's a very simple formula. So now we go to the Hank model to see whether we can then fully explain for this fall and what's exactly the mechanism, what is missing in the simple accounting formula to get the full fall, and also explain the fall in wealth inequality.
You're going to get through it in the model, but if you sort of thought about carving out this technology, you would think, well, I destroy capital, but I wouldn't change the relative shares of income going into.
Yeah, exactly. Next slide. Here we go. So what's the most simple way to think about that? So that's why I would argue it's essential to have 2 parts in that model. So the one is, of course, household heterogeneity. We want to talk about changes in inequality. So households that differ in their income, their wealth, and also their portfolios. How much nominal and real assets do they hold? And then there's also a specific type of households. They are entrepreneurs. They will receive the firm profits, and they typically populate the right tail of the income distribution. So here I won't have an occupational choice model. It will be stochastic transitions. Some households become entrepreneurs, and then they become normal workers again. And now for the capital to income share, here the new Keynesian features are essential. So the new Keynesian model has monopolistic competition, and that will create pure rents, or what I call throughout the talk firm profits. And with sticky prices, changes in the real marginal costs that firms face, for example, due to destruction, will translate into firm profits because I cannot adjust prices. So here in our model, we take the most simple sticky price formulation, is just Calvo. Yeah? So I don't have a clear theory of why firms cannot adjust prices. So normally we think about, sticky information and menu costs, but here it could also be the government, saying there's price controls. Yeah? So this is just an all-in capture for why prices do not adjust during wars. And with this, you get, this break of the Cobb-Douglas production function that, total production is Cobb-Douglas, there's a capital and a labor share, but total capital income is this dividend income, the alpha share, plus these time-varying firm profits. So in the formula, it's just this mu t here, the kind of markup that firms have. And so with changes in real marginal costs that come from the shocks that I consider, like destruction or taxation, I will have a change in this capital to labor ratio. So the shocks that we then model to account for the war is exactly these three mechanisms that people have in mind. So there will be capital destruction. It's just modeled as extra depreciation, this DT. So you can think about this as raising effective depreciation and thereby directly reducing the capital stock. So this could be direct, destruction or other reasons why there is more tear and wear in war times. The other thing is a top tax surcharge, where we will tax top labor incomes, firm profits, but also wealth. So it's an overall increase in taxation of households. Both of these, they will follow AR1 processes that are estimated to match what we see in the data, because we have the direct observables for both. We have taxation and we have capital destruction. And then the third one that we allow for is an inflation target shock, this pi bar here. So this follows an AR1, and the idea is that this shifts the central bank's target. So the idea is that it's a simple form of monetary fiscal accommodation. So it's not, a full-fledged out model of, unfunded fiscal shocks. It's just that the central bank can decide to accommodate a fiscal expansion. Yeah. So the data I will estimate this on is exactly the impulse responses that I showed you. We will do impulse response matching. Yeah.
I guess, and again, it's your talk, but I'm thinking about a country like the United States where inequality was reduced dramatically during the war and after for a while, and obviously really not much capital destruction.
Yeah.
So
no, we can talk about this later.
If you're going to, you're going to use different things.
So first we will estimate this on our average war site, which does not include the US, and then we can talk about the US later, because it's a bit of an outlier relative to all the other evidence that we have. Yeah. Right, and so in terms of, how you can think about this, both of these will also create inflation. So, if you have capital destruction and real marginal costs go up, they will also create inflation. Yeah. So both of these shocks will create inflation, and then this inflation target is basically informed by the residual. How much inflation do I still have to generate with an extra shock to match the data? Yeah. So in terms of the household budget, last equation, and then I'll show you some results. This is how it enters into the household problem. So households, they choose their consumption, their nominal asset holdings, and the real asset holdings. And then destruction enters here, it changes what is the capital that's left when you enter the period. Yeah. Taxation enters as an extra tax for the high income people, a tax of your asset returns, and a tax also on profit income. And inflation enters by eroding the real value of this nominal bond. So it enters here in the return on this. So this is where households are differently exposed to these shocks, because some have nominal assets, some have real assets, and some have high income, some have low income. So these shocks will have distributional consequences. Great. So then how do we bring it to the model, to the data? So there's two steps. So the first, we calibrate the steady state distribution. So we look at the historical moments. What's the capital to output ratio? What's the average inequality? And then we estimate these shocks and kind of the Taylor rule, the kind of Phillips curve, and all of these dynamic frictions using Bayesian IRF matching. So we look exactly of how the average war site looks like. So this is how the results then look like. In blue, you see the model response. And then in this black and grayish, you see the data I showed you before. So the model can replicate the fall in income inequality and wealth inequality pretty nicely. It gets the large, more than 20% fall in income and less than or around 10% for wealth. And at the same time, it matches also the different sources like the price level, marginal tax rates, and the capital stock pretty well. So having this estimated model now, I can go on and do decomposition. So how is this actually happening? What is happening in the model? How important is each of these shocks? And that's what I have this quantitative model for.
Sort of like I mean, you emphasize quite a bit the capital labor ratio. It doesn't look like it's doing
No.
quite as good a job on that.
Exactly. So here it's already sufficient. Here, if it drops like kind of by 10% or so, you do get these results. So this is potentially the firm profits. It's a simplified way to do it. So it could be that they're more dispersed in the data, and that would kind of kill the gap here. So then here's one of the exercises I can do. So the first one we do is, okay, what shock is actually driving that? So I look at two time periods, t equal to 3, that's in the middle of the war, and t equal to 12 years, that is the maximum fall in inequality. And what shocks are driving that? And so you see on the left-hand side for income, the blue is destruction. So it's really about destruction in the beginning and also later. More than 50% comes from destruction. That's changing the income inequality, similar to the Mead framework. When you look at wealth inequality, you see it's also destruction, because here the Mead formula doesn't perfectly apply. We also have people, for example, with zero wealth, so it's not perfectly proportional, even though it's a proportional depreciation shock. It affects people differently. But taxation is the most important part. Higher taxes, for example, on wealth, they change overall wealth inequality. It explains here around 50% at 12 years. Now, this is the shocks, but then what are the underlying prices changing that? So what I can do is I can do the total differential of this response of inequality, and I can ask how important is each price in generating that. So that's something that people have done in the Henk literature to understand consumption. How important are the different prices for the consumption response? I can also do that for inequality. And what you get is, for example, here in blue, you see the top one income share. It's really profit income. So profit income contributes like minus 30% to the overall fall. So the total is the same, but here you see the decomposition in the different drivers. So asset income, so in the model we do have a higher real return at some point, because the central bank does respond to inflation at some point. So after 12 years, you can earn kind of a return on bonds. This works against it. But what's, for example, interesting is the direct tax rate effect is way smaller than what we had before. Here it's just around 2%, and here it was like around 10% or so. So why is that? Because here, this is just a direct effect of the tax rate. If you have a tax rate shock, this will also change profit income. That will also change asset returns. There's also endogenous responses of prices. And this decomposition, what it does is, it allocates these to each of the price sequences. Yeah. So, let me first show you this. You see it here. On the right-hand side, you see profit income. On the left-hand side, you see labor and rental income. So they both move the same because they are proportional to output. And so, for example, destruction, in the beginning, the destruction shock lowers output, labor income, and capital rental income by more than 10%, around 15%. That's the kind of the onset economic crisis when war happens. But then, as people start investing again, after kind of 3 years, or in total, after 6 years after the war, the economic downturn is over. But when you look at firm profits on the right-hand side, these are depressed for many years. So initially in the first year of the war, there's actually extra profits to be gained, but then they fall. And the same for taxation in blue. So it doesn't matter whether there's destruction shock or taxation shock, profits fall in both cases. So they share profit income as an endogenous kind of amplifier of the compression of income, of capital income. The other thing what I can do is all the data is about pre-tax income. But what about post-tax, right? Post-tax should look different. But we don't have data on this. In the World Inequality Database, it's about post-tax. So here in the model, I can just look at what's actually happening to my net income after taxes. And you see this drops way more, especially on impact when taxes go up. So it makes a difference whether you look at pre or post-tax, and the model can help you understand this. Okay, let's go back. So why is it that profits fall so much? So this is crazy. So I'd show you two things. So first, the mechanics in the model. Why do profits fall? And then second, I show you data. So, profits are basically a small residual from output. When you think about, profits, it's just, total output and then 1 minus the marginal cost. And this is overall 10% of output in the typical calibrations. And now when you think about the change of real marginal cost, it depends on what do you have to pay in wages, what's the productivity, and how does the cost of capital change. And here, the kind of real capital per worker falls because we destroy 25% of capital. So the real kind of cost of capital go up. And in the, wages, for example, don't fall enough, or productivity doesn't increase enough to compensate that. So you get an increase in the real marginal cost for firms. And the elasticities are such that given profits are just around 9 or 10% of steady state output, a 1% rise in real marginal cost will lower profits by around 10%. So to explain the fall in profits of 30% or so, you just need a 3% increase in real marginal cost. So we go to data. Let me show you this first. And we check this, does this actually happen? Do historical profits fall? So here we look at World War II, we normalize profits to 138, and then we look in for these countries of how profits develop relative to that. So for example, look at Germany. The profits already dropped during the war by 20%, and just after the war, they dropped by 98%. Their profits are basically gone. There are no profits in Germany. You can now look at other countries like Finland or France. Just Japan has a large increase in profits during wars, and only when destruction happens, then profits fall. But the typical fall in profits, it's around 50% or so. There's really large fall of profits in the data. And this makes the difference. Yeah? So I can go back to the meat accounting formula. So what we did before, we said there's some average capital income and labor, and then the Hank model basically says, there's labor income, but there's two types of capital income. Yeah? The kind of asset returns, where everybody kind of has some, and then firm profits, which are more concentrated. And that gives you already the extra kick. The other thing that's different in the Hank model is there's also these subscripts. People are trading. They are changing how much assets I have, how much capital. Also, the firm profit ownership is changing. So there's these movements in these shares. Yeah. So I can just use my solution from the Hank model, calculate exactly all of these things, plug them into the formula, and plot again this meat stuff. Yeah. So here's this figure. So in gray, you have the formula without the profit concentration. Yeah, so I leave out profits, changing profits for my thing. I just delete it in this equation. And then I can only explain again a fall of less than 10% in the top one income share and no action on the top wealth share. Then the blue line adds these profits. Now that's already increasing this by a factor 2. And then the last thing is I allow for moving shares. So people are trading and changing their portfolios. And then I get the last mile to the minus 20, 25, 23%. So this can fully account then for the data. When you look on the right-hand side at the top one wealth share, it's even more important there. Yeah. So the top one wealth share, it's all about moving shares. It's really like people saving less, saving differently. So when you look into the model, it's the people in the middle class, they start accumulating bonds after the war. While the top people, they still have lower real capital income and they are kind of punished for their portfolio being heavily exposed to capital. That's what the model tells you. It's a differential, also savings behavior and re-evaluation channel. And without this, you don't get the fall in the wealth share. So one last thing, and I have like a couple of minutes. What about inflation? Yeah, so I haven't talked about inflation much. So first of all, almost all of the inflation is an endogenous outcome. It happens because of an increase in real marginal cost. I estimate a pretty small inflation target shock because I don't need it to explain inflation in the data. The other two shocks already do drive inflation. I mean, what about redistribution? No matter where inflation comes from, it will do redistribution. Yeah. So here on the left-hand side, you see the percentile of net wealth, yeah, and I show you the percent change in wealth levels. Yeah. If there's large inflation, how much does it change wealth levels? And then, of course, these people in the bottom kind of 20%, they are net borrowers. So they gain from inflation. The value of the debt goes down. Yeah. And on the right-hand side, you see the change in the wealth shares. Yeah, so it's not the level, but the share. And so the interesting thing here is to see, okay, all the inflation action again is around the bottom and the middle. And at the very top, this thing which I have in the data, the top 1% income and wealth, there's nothing happening. Yeah. So inflation doesn't redistribute between the top 1 and the bottom 99%. Both of these groups are positively exposed to inflation. They are positive net nominal asset holders. So when there's inflation, it doesn't change the top 1 share. Yeah. So this is something I don't see in the data. It's all, in the model you can see it. Inflation is about redistributing between borrowers and savers around kind of the bottom 50% of the wealth distribution. Yeah. So it's really also a data issue. If we would have the full portfolio in the data, if you would see everybody, then we could more directly estimate the effect of inflation. But given that this World Inequality database is about top shares, there you wouldn't expect much. And it's again this intuition, the same as with the proportional haircut. If we all have the same kind of positive exposure to inflation, we all have bonds, then 10% inflation is exactly that haircut that leaves our relative, wealth unchanged. And destruction is the same. If we all have some capital, a 10% haircut leaves it unchanged. So this is something you cannot see in the data for the top one wealth. So let me conclude here. So we provide the first kind of comprehensive evidence. So what does the average big war actually do to inequality? Is it a great leveler? And we do find a substantial reduction in income inequality that also matters for the overall change in income inequality. So income inequality, the top one shares falls from 40 to 20 over the last 100 years. Yeah, and so that's a 50% reduction. And the war can explain around 25%. So potentially it's important for the overall development because it's also persistent. Not so for wealth. Yeah, the wealth reduction is actually larger in the data and the shock has a smaller impact here. Key for this is really to understand that destruction of wealth, destruction of capital income will mostly impact income inequality. And then our general equilibrium model helps us understand it's also the endogenous response of real marginal cost to that shock that kind of supercharges this mechanism because there's more concentrated forms of capital income like firm profits. Overall, also taxation matters for wealth in particular, but also inflation just at the bottom of the wealth distribution where we don't see it in the data. Great, I'll stop here. Thank you so much.
Jonathan Payne.
Okay, thank you very much for inviting me to discuss this paper. It's great to be here. Okay, I think as was well explained in the main talk, the central claim of this paper is that war reduces inequality and that most of the action here comes because the income of the top 1% of the distribution goes down and to some extent wealth also drops. The paper is quite ambitious in the sort of scope of approach it's going to take to try to resolve this. As was outlined, there is one part that is local projections using historical cross-country panels. There is a full structural Hank model with capital destruction, taxation, and inflation shocks they use to decompose the different effects. And there's also this validation using the German town data during World War II and these cross-country firm profits. So I think my overall take is this is very ambitious and very interesting. And I think the high-level conclusions make quite a lot of sense. My discussion is going to focus on a few areas where I think maybe some more could be done. I think some of the mechanisms are quite hardwired into the environment. We can talk about that. I'm not sure the paper is really matching portfolio data completely. And I think there's this overarching question of does this end up being a model of World War II or are we learning something more generally about wars? We can come back to that. Okay. So I'll just recap the paper a little bit and then I'll get into these main comments. So on the empirical side, so I'll just go back over this cross-country panel exercise to start. So here they have data on a lot of the wars that have happened where they have inequality data. So in the main text, they emphasize these 16 major war sites, 9 of which come from World War II. Then I think I was also quite interested in Appendix B2, which has these 10 non-war sites. These are countries that are at war, but the sites were not specifically in the conflict. And I'll go through both. The inequality data, it's the top percentile of the wealth and then the pre-tax income distributions. And then they do a fairly standard local projection where they project these different inequality measures onto the war with a collection of controls. Okay. So I think it's helpful to start just think about what wars end up in this sample. So the top is the same table that Ralph was showing. So here we have the main wars that enter. I think we can note a lot of them come in this 1939 to 1944. So it's quite heavily focused on Europe in the Second World War. Then Then I think there's this interesting second panel, which are the non-war sites, I guess going a little bit to Raquel's question. This ends up being principally Australia, United States, New Zealand, Canada, which fought in these big wars, but were not directly experiencing destruction of capital. Okay. So we can look at the local projections in the war sites and then the non-war sites. And we can see, as Ralph was talking about, this main result that the income share goes down significantly and the wealth share less so. I think interestingly, the reaction is sort of broadly similar in these war sites and non-war sites, which would not have been entirely my prior going in. We can also think about the capital stock and the capital to labor share. And so here we see there's a much greater destruction in these war sites. This is what they really want to capture in this model, this big capital destruction, and try to trace out what that's going to do. And then we have the capital to labor share. And then finally, we have the price level going up and the marginal tax rate going up. Okay, so these are the local projections. The second big exercise is to take this and try to work with a structural model. So here they choose to work with a Hank model with capital and war episodes. Okay, so it's a discrete time, infinite horizon environment. There's a standard new Keynesian production sector with monopolistically competitive firms that use the capital and labor to produce. I think a lot of the action comes in the household sector. That's what's going to generate the inequality. So here the way they do that is they have random switching between the households being workers and being entrepreneurs. The workers, they provide the labor income and they're subject to idiosyncratic stochastic labor productivity. They rank consumption using fairly standard looking preferences. They like consumption, they dislike supplying labor, and they receive wages through a union bargaining arrangement. Okay, so that's the worker side. Then on the entrepreneur side, it looks similar, but they have no labor productivity, and instead they receive all of the firm profits from the markups in this monopolistically competitive environment. In terms of the assets, all the different households here essentially make a portfolio choice between two types of assets. There are liquid savings subject to a borrowing constraint, and there's illiquid capital that can only trade at a Poisson frequency. All right. So this is the household side. The war events are going to be modeled as a big capital destruction shock that hits the capital directly, an increase in the inflation target, and a higher income tax surcharge. The model is solved, I believe, by linearization. So it's not entirely explicit, but they reference this other paper, NBER 24, which I think covers the main technique. So here they do a Reiter-style linearization. I think that's right. A Reiter-style linearization, and then this Bayesian estimation. Okay. And then we get the main result from the structural model, which Ralph discussed, which is we can think about how these different shocks end up explaining the inequality. Here we see the point they want to emphasize, that the capital destruction shock ends up particularly in the early part of the war. So this T is 3 is the first 3 years after the war starts. Here we have the change in the top 1% income share, and here we see the capital destruction shock plays a big role in that. Okay. And then they emphasize a particular mechanism. So when they dig into the model and they go through and try to trace out what's really driving the way the capital destruction particularly hits the income of the top 1%, they argue this really comes from the firm profits. So capital is destroyed, firm profits go down due to the way markups change, and then it's these entrepreneurs who end up being the wealthier agents who have all the profit, and so their income drops. Okay. So that's my summary of the model. I have a few comments I want to get into to talk about what's going on. So I think my first comment is that the main mechanism here really comes from exogenous profit assignment instead of the endogenous portfolio choice. So in this model, production is allocated in 3 different ways. Some of it goes for labor compensation through wages and union dues. Some of it goes to capital rents, and the capital is held by all the agents. And then there's the firm profit that is given specifically to the entrepreneurs. So here the model has quite a complicated portfolio choice between capital and liquid savings that drives a lot of the complexity. But the firm profit is allocated exogenously to the entrepreneurs, and the switching between entrepreneurs and workers is essentially exogenous. So I think we can think of the profit as being essentially exogenously allocated. So in that sense, I think the main mechanism comes through this hardwired firm allocation. I think it's unclear we'd get the same results if we opened up a market for firm profits. I know that some of the authors in their previous paper, they actually do have a market for firm profits. I think that would make sense to try here. I'm not very convinced we get the same mechanism. So that's the first comment. The second comment is I don't think it's entirely clear here that we're matching the portfolio choices we would see in the world. So what I'm showing here are the portfolios that come out of the model. So on the bottom, there's the percentile of the net wealth. And then here on the left-hand side, I have the bonds to income and capital to income. So we see this as a model where the debt is essentially with the very poor agents, and then the wealthy agents sort of divide between bonds and capital, and there's no housing in this model. If I understand correctly in terms of the targeting, the only portfolio target that's really being matched here is the aggregate household debt to income, which they're targeting is 9%. I think any other portfolio data is not really being targeted. If we think about what we know about portfolio data from the second half of the 20th century, there are some features here that I think are not really being captured. For example, poorer households largely hold deposits and don't have a lot of debt. Instead, it's the middle income households who purchase homes with mortgages and hold a lot of the debt. Entrepreneurs actually are often highly levered in the economy as opposed to being unlevered like they are here, generally speaking. And of course, there's a whole lot of age dynamics that are missing. So I certainly appreciate that trying to go back and match portfolio data over the past 100 years is going to be a tough ask. But I do think there could be some more robustness here to try to think about what would happen if you did calibrate the model to target what we know about the portfolios from the second half of the 20th century. In particular, I think it would make sense to try to think about a calibration where there are wealthier households that do have debt. I think a natural thing to do here would be to think about the entrepreneurs, treat the entrepreneurs separately, give them a different debt limit, so at least the entrepreneurs can heavily lever up, and then you would have some wealthier agents that hold nominal debt. So you might get a mechanism by which inflation could have redistribution effects in this economy. Okay, and I think also just from an illustration point of view, given that the entrepreneurs and workers are so separate and essentially the big distinguishing point, I think it would make sense to show the portfolio choices separately for these two types of agents rather than trying to sort of lump them together on average. Okay. Comment 3 is about which assets end up being destroyed. So I think there's a pretty long-standing debate about whether the very rich are better at protecting their assets during crises or not, right? Do they manage to get their assets out of the country before the war? Do they manage to get them into tax havens before the high taxes come in? All these different things. Long-running debate. I'd say this paper generally imposes the answer to this is no, right? The wealthy are very trapped to pay the cost of the war in many ways. In the empirical analysis, the baseline assumes that the destruction shock is sort of uniform, so all the capital is destroyed together. And then the Hank model, as we talked about, assumes that the entrepreneurs cannot sell off claims to their profit or switch out of being entrepreneurs. So again, the entrepreneurs are hardwired here to kind of take all the losses that occur when capital is destroyed. There is some robustness in the appendix, but I think a natural experiment here would be to think about a world where we destroy the housing uniformly, right? So the land values, the housing values, you can't really escape that, but we give degrees of options for the very wealthy to move their other assets out of the country and avoid some of these shocks. And I think this would have a pretty big impact on how we think about where the very, very rich end up paying costs or not paying costs of the war. Okay. Comment 4 is about the linearization. So here, the solution technique, as I understand it, is we're going to linearize in the aggregate space, like a sort of writer style. So this means that essentially we shut down the aggregate risk premium in the economy. I think this is particularly relevant for thinking about the impact of inflation and inflation risk on what's going on. So we're not really pricing inflation risk. In terms of whether this ends up looking like a reasonable assumption in terms of the asset pricing data, I think you're more generous than my clock. It's okay. It's fine. So in terms of whether this is a reasonable assumption, I think, from my work, other work on the asset pricing, I think this probably makes sense maybe before World War I. It's not obvious there's a lot of risk premium and inflation. It's not obvious people are changing their portfolios in response to inflation risk. After World War I think this becomes a bit of a stretch. That's kind of the turning point here for when the inflation risk ends up really being priced. So I want to show one plot to illustrate this. So here's a hypothesis test for whether or not we can reject essentially no inflation risk premium. So up until World War II, if we look at, say, 5-year maturity, this is US bonds, for 5-year maturity treasuries, yes, up until World War II, we can reject essentially that we need an inflation risk premium. And so the model does look a lot like this first order perturbation rider style model. But as soon as we cross World War I and inflation starts to come in, suddenly we do see a very large inflation risk premium coming into all the bond pricing, and by extension in the way that all these portfolio choices are determined. And I think from a modeling point of view, I think we do want to try to think about this change and the way inflation risk ends up being priced. So I think all of this brings me to the fifth comment, which I think is an open question here about to what extent we generalize beyond the World War II sort of episode, right? So the empirical evidence is sort of heavily skewed, I would say, towards World War II. I think the model in many senses has assumptions that are probably better tailored to World War II, right? No inflation risk premium going in, not a lot of precautionary portfolio management to try to address inflation risk going in. Wealthier holding assets that are hard to move. It's a lot easier to move wealth now, particularly at the very top end of the distribution. I think all of which raises a kind of open question, if we did the same, if we had similar wars today, would we actually see that inequality goes down in the same way, or would we see the ultra wealthy essentially moving their assets out of countries like Europe or the US and a very different experience? Okay, so I think to sum up here, the paper is trying to get at this question of how does war affect inequality. If I step back and think about what I think this really comes down to, I think it really comes down to answering 3 questions. Who bears the physical destruction costs from the war, right? Who's able to move their assets out or not? Who bears the fiscal cost of the war and the rebuilding in terms of regular taxes and inflation taxes? And who can profit from the high returns and risk premia that appeared in all these countries post-war? I think this paper is very ambitious in scope, in sort of the range of different ways it wants to tackle this question. But I'm not sure it has the richness at the moment in terms of digging in terms of what the real portfolio choices look like for the households to fully get at the answers to these questions. And I think in many cases hardwires to some extent that the wealthy are not able to escape some of these costs. Thank you very much.
So why don't we open up questions?
Right. Does this work? Okay. So I'm Paul Bella. So you interpret destruction primarily as the physical destruction of capital, but wealth could also be destroyed through declines in asset values, say capital losses. So have you considered this broader notion of value destruction? And could it help explain apparent anomalies for your hypothesis, such as US, France, or the UK to some extent, where the decline in profits were not as high after the war?
Let's gather a few
Okay.
questions and then you can choose which to answer more.
Okay, that's good.
This little kind of mechanical question was, so you had these profits that were an important thing, and there was the mu parameter that controlled how big they were. I wasn't sure whether you were calibrating mu directly from some data or whether there was sort of a more endogenous sort of determination of the profit share in the model. Thank you.
Hey, this is Fang Yang from Dallas Fed. I'm just wondering whether you're talking about another risk, which is mortality risk, and people are not surviving to the future and therefore affects the consumption saving and this also maybe differ by wealth.
So the planning horizon, you mean? So can you repeat it quickly? We didn't.
But another risk, which is mortality risk.
The mortality risk, yeah.
People may not survive to the next period. Therefore, they were maybe affecting the consumption saving decision, whether this mortality risk is different by wealth, for example, and that affects the.
Okay.
I can do that. I guess I also have the question about destruction of the labor force. I mean, millions of people who died. And then also things like, thinking more about what Jonathan was saying, not Jonathan, yes, John, okay, about, I'm very bad, I'm getting the Jonathans mixed up, about, the
whether this is World War II or other wars, I really think that if you think about a world of multinationals or people owning diamond mines or whatever, it's a very different world than when most of your capital stock is being held at home. I also think, it also matters what's happening to the other countries around you in terms of thinking about the international implications for trade, and then how does that affect income inequality within the country? And then things like, since so much of yours was European, things like the Marshall Plan, which wasn't that big necessarily in terms of its contribution directly to GDP, but they did invest in very particular sectors, in electricity and coal mines, et cetera, that were really important in terms of the economy then taking off after. I know that you're emphasizing like the first few years, but it seems to be equally important to think about how long the fall in income inequality lasted, and what are the forces that are going in that direction. I'll stop there.
Okay, so these are many different complicated questions. So let me give you trying to bring them all together. So let me start with the empirical evidence. Yeah. So for example, for labor, what we did is we also have data on total population, on total hours worked, on real wages, and we do report them in the appendix, and there we get a statistically insignificant response for total hours. Total hours don't drop. Real wages don't move statistically significant. There is a small decline in population that reverses. So for us, that meant, okay, we leave this out of the model because we don't have statistically significant evidence for a strong labor supply kind of reduction. That's why we kept it out. But of course, for many war sites that could have been important, just on average, it doesn't turn out to be statistically significant. Yeah. Also, when we compared our baseline results to non-sites, so all of the responses, they are smaller or they're statistically insignificant, like for the top one, income inequality. And interestingly, when you drop the US from the non-sites, this difference becomes larger. The US is really the outlier, where the US sees a strong reduction in wealth and income inequality that doesn't fit with the other countries. So if you do the non-sites without the US, you basically get pretty flat lines. So this seems to be like potentially not the right model for the US, even though, here we take the average response of destruction, taxation, and inflation. And for the US, taxation plays a more important role than the average. So this is more like saying broadly, when you think about wars, you should really think about that mechanism that compresses income inequality via capital incomes, in particular profits. That seems to be something that's pretty general. And then if you look at specific countries, specific wars, then each of these channels could be, differently large. We just here report the average. Then for that channel, do we have a simplified model of this? Yes, we just have the simplified entrepreneurial state. But, it's important to have one more concentrated form of capital and to have a portfolio choice model that's even larger, where you have, your housing and other kind of capitals and then firms on top. That's kind of the frontier in that literature, and that's something that we couldn't push in this paper. So in that sense, we keep that simpler here. How do we bring it to the data? The observable that we have in the estimation is the capital labor share. But we also afterwards collected all these firm profits. So we could also directly say this is changes in firm profits and do match this, and we would get pretty similar results. Yeah. So also, like the nice point that Jonathan mentioned for our earlier papers, where we do have tradable firm profits. As long as they're more concentrated than average capital income, this mechanism can work. And so even in that paper, what we do have is there is one part of profits that stay with firm owners. This is very concentrated. And then another part that is traded. And that would give you a similar mechanism, just, toned down a little bit. So overall, I'm pretty sympathetic to saying there's many different, things that are different for all of these war sites. The kind of scope and ambition of this paper is to say there's a very general, very strong force that basically applies to all of these in different strengths. And so it's something to take into account. The other question that was raised a couple of times is external validity. What about the future? What if, capital is more mobile? I mean, that's something I cannot answer with this paper. We try to look into the historical portfolio data, but this is limited. And so, for example, we don't see the mortgages in our data. I don't understand exactly how they are financed. It's just that home ownership was smaller back then. So that's why we just said we can calculate the overall fraction of households in debt. That's the number I will use. And then we have our standard portfolio choice model that has been used, in the literature for many different questions. And let's start from here. But of course, better data to see whether, entrepreneurs have been very leveraged back then or housing was more leveraged, that would change the impact of inflation. But again, I would say relative to that compression of the income distribution, who bears the cost of inflation seems to be of secondary importance. Yeah, that will change, exactly how important it is for wealth, but not the overall picture of the story. So I'm sympathetic, to many of these, and some of this could be potentially answered with more data work or a more fine-grained model, but not all of them at the same time.
Wonderful, thanks.
Okay. Thank you so much.
We have a break now. We are going to start at 10:15 sharp because we have a very long day.
Well, listen, one other, how do we think of, you can probably just sign it.
Hi, Jay. So many large. No, I. Some people watch the game, some people watch the game, but there's no things in the car and stuff. I see you, I see the light on here. Yeah. That'd be great. Let me text, find out, I think you can.
Yeah, and also the Jonathan, by discussing, he wasn't all, signing up with also like joined with Jonathan.
Two more, okay, so let me, yeah, I.
Okay, we should restart. So our next paper is by Amalia.
Yeah. Rapella, that works.
Okay. On wealth sorting and cyclical employment risk.
Okay, good morning, and thanks for having this paper on the program. It's a great pleasure for me to present it. So it has been widely documented that recessions affect workers unequally. By that, I have in mind like a different job loss probability. And for workers with small financial buffers, losing a job can lead to financial distress. And in turn, financial distress can turn job loss events into persistently worse labor market outcome, particularly in the presence of borrowing constraints, and even though the labor market is highly dynamic. One outcome that is particularly relevant for the ability of workers to kind of recover from such event is future employment risk. And so in this paper, I study how liquid wealth shapes workers' employment risk in the cross-section and over the business cycle. So I start by documenting that in the US, workers with low liquid wealth face, on average, higher job loss rates. They face higher job finding rates, but also their employment is relatively more cyclical. Now, importantly, these patterns are true even when I control for observed workers' characteristics, such as age or skills, education, but also conditional on some unobserved worker heterogeneity. Okay, so I'm going to interpret them as documenting some kind of residual inequality by liquid wealth that works within very narrowly defined worker type. Now, importantly for the informing the mechanism is that residual inequality is specific to the liquid component of previous period liquid wealth. Okay, so if I look at permanent wealth, there's no residual inequality. So now the fact that poor workers are more likely to lose their jobs, and particularly so in recessions, may sound surprising to you. If you think that these workers are risk averse, they would, dislike that particularly more and try to avoid such risk. So in the second part of the paper, I'm presenting a new theory. I'm going to call it a theory of wealth sorting into risky jobs. And that theory, I think, can quite intuitively explain why this can be the case in equilibrium. So just to frame ideas, this is going to be a directed search model with two-sided heterogeneity on the labor market. On the one side, we have workers that differ in wealth. They face borrowing constraints and they're risk averse. On the other side of the market, we have a distribution of jobs that ex ante differ in their separation risk. Now, the main insight from this model will be that wealth poor workers are going to apply to lower wage jobs with higher separation risk if they are compensated through the job finding probability. Okay, so the job finding rate here is the compensation for higher separation risk. And I'm going to show you exactly what conditions are needed in a two-period version of this model. Now, the two-period model is useful to highlight the mechanism, but it falls short in understanding quantitatively how much wealth sorting matters with realistic employment histories. It also cannot really speak to the cyclical empirical finding that I told you about. And therefore, to answer these questions, I then integrate this wealth sorting mechanism in a quantitative model with aggregate risk. Okay. I calibrate this model to the US and I use the conditional empirical evidence on the residual inequality to kind of structure the job loss and job finding rates in the cross-section and over the business cycle. So the main results from this quantitative model is that first, wealth sorting is positive given the calibration to the US. So poor workers do apply to jobs that are both more risky on average, but also in recessions. Wealth sorting is also cyclical, and in particular, it is stronger in bad aggregate states. Okay, so bad aggregate states are times where workers are close to the borrowing constraint, and this kind of increases this job finding motive, leading them to apply to even worse jobs. Okay, and that stretches the job ladder to the bottom. Job search acts as an insurance mechanism. Okay, so in bad times, workers shift their job search towards worse job to mitigate the drop in the job finding probability and in an effort to smooth their consumption. Okay? However, this doesn't come for free. It comes at the cost of future job loss risk and hence future consumption risk. Now, in this model, there's a dynamic interaction that arises. Okay, so wealth shapes job search during unemployment spells, and job search outcomes shape wealth accumulation during employment spells. Okay, and I'm going to show you that this dynamic interaction generates a lot of persistence in the state of being poor, and I'm going to quantify that later. So before I go in the heart of the paper, let me just say a word about some related literature. And in particular, I want to mention that there's a lot of nice paper that look at how wealth affects labor market outcomes. I think one thing that is new in this work is that I show that the job finding probability can act as a compensating differential for separation risk. Okay, and therefore this allows me to generate, as I see in the data, that low wealth workers target jobs with higher, not lower, separation risk. Now, relative to incomplete market models, standard incomplete market models, also those with labor market frictions, what is new and potentially opens, interesting avenues for future work is that an employment risk is now endogenous to liquid wealth. Okay, I'm going to explore this as well. Okay, so let me jump to the empirical motivation. I use the PSID since 1999. They collect information on wealth, and so that's when I start my sample. And I'm going to estimate a residual liquid wealth inequality by controlling for observable characteristics and individual fixed effects. I'm going to regress a dummy that captures either the employment status or job loss or job finding on the left-hand side, and then I'm going to regress this on a set of fixed effects, worker controls, and then the coefficients of interest, which are the ones relating to past period liquid wealth. Okay, so alpha here represents, fixed in the aggregate states, how liquid wealth affects the risk of losing or finding a job, and chi here is the elasticity of employment to output fluctuations. So, as you can see from the significantly negative coefficients in color here, low liquid wealth workers, conditional on this set of controls and fixed effects, do have a more cyclical employment. Okay, in terms of magnitude, one standard deviation decrease in GDP reduces employment of workers at the bottom of the liquid wealth distribution by 1 percentage point, and this is 5 times as much that of the median wealth workers. Now, if you separate between job loss and job finding, what you see is that, those liquid wealth poor workers have a higher job loss probability and a higher job finding probability. Okay? The magnitudes are also economically significant here. Now, as I was saying in the intro, the patterns here are specific to the liquid component of lagged wealth. And they are also robust to controlling for past labor income. So if you think that labor income somehow tells you something about unobserved and time-varying worker heterogeneity, then this control could address some of these concerns. It also holds within industries and occupations. Okay, and all of these features are going to motivate a model where I'm assigning all the remaining inequality to attributes of job types.
These are with individual fixed effects, everything that you're doing here?
Within individuals, fixed effects, yeah.
And you're not worrying about the endogeneity of
So I'm less worried about it because I use past liquid wealth on future transitions. I do my best to control for a lot of features that correlate with liquid wealth. I'm not claiming that this is causal, but I'm going to offer a theory that can rationalize this. Yeah. Okay, so let's go to that theory. For now, let's focus on a two-period model that's going to allow to explain, the cross-sectional patterns of job loss and job finding rates. So workers are risk averse, they face a borrowing constraint, and they take a consumption savings decision always. And if they're unemployed, they additionally search for one job. Now, on the other side of the market, there are firms, and I'm going to index them by type X. And by convention, I'm going to assume that a high type X, so high type jobs are those bearing lower separation risk. Okay, so high type is safer. The type affects not only the separation probability, but also the vacancy cost. Okay, so opening a vacancy entails costs that is a function of type. And in particular, I'm going to assume that it is more costly to open a safe job. Okay, you can think that safe job, it's more costly to open a job that is going to last longer in terms of planning and screening. Firms, what they do is to post wages. I'm going to assume in this two-period model that they produce the same output, irrespective of X, for simplicity. And then the labor markets are frictional. This part is very standard. So search is directed. There's market tightness that is submarket specific. Theta, I'm going to drop the arguments for the rest of the presentation, but remember that it's submarket specific. And then job finding probability will be P and job filling will be Q. I'm going to assume also that there's free entry for vacancy posting. So what are the value functions? I'm assuming for simplicity again that everyone starts unemployed. And then they have to decide how much to save and where to look for a job. Now, they get utility from consuming whatever they don't save. That's very standard. And then their continuation utility depends on whether they get employed or they stay unemployed. Okay. If they get employed, then they get utility from consuming what they saved plus the endogenous wage. Okay. The probability of getting employed is, submarket specific, and then you have to survive also, the separation risk. Okay, so you get employed if you get picked by the maximum function and not by the separation function. Now, capital delta here is what you'll see throughout, and it's 1 minus small delta, which is the retention probability. Under free entry, we can write the job creation function condition as equating the cost of opening a vacancy to the expected benefits. Okay, so let me tell you about sorting here. So sorting happens if workers with different assets apply to different types of job X. Okay? And for a worker, searching for a higher type X job entails two considerations. So on the And here, sorry, I'm conditioning on tightness. Okay, so for optimal tightness locally. So a worker that looks for a higher type X jobs increases the expected retention probability. Okay, this is by assumption that higher X jobs have higher retention probabilities. However, this higher search may reduce next period's consumption if locally the wage decreases as a function of X. Okay, if this is not the case, then you see that looking for a better job is good in both dimensions, and every worker will choose the same job, which is the highest type job. Okay, so sorting requires this wage program to be decreasing, and this is governed by the following condition here. So that condition relates the shape of the vacancy cost function and the retention probability function in a way that the semi-elasticity of the vacancy cost must be larger than that of the retention probability. Okay, I'm going to give you now a bit more intuition for what this condition means. And for this, it's useful to look at the firm's indifference curve. Start video?
Yeah.
Okay, sorry. Okay, so free entry, what it does is to pin down a relationship between tightness and wages that is consistent with optimal job creation. Okay, so like in all directed search models, posting a higher wage has to be compensated with a higher job filling probability. Okay, what's interesting for us is that the shape of these indifference curves here is a function of job type X. And in particular, the previous equation governs which indifference curve is steeper. Suppose that it holds, then you need a larger wage reduction to compensate higher type X jobs for a marginal reduction in the job filling probability. So intuitively, what this means is that the slope of the indifference curve for high X firms is steeper. And so high X firms kind of relatively prefer higher job filling probability. Okay, this is going to be important in driving also some of the results. Okay, so let me go to the main result now, which is positive sorting. So this requires workers with higher assets to apply to higher type jobs. And the conditions for positive sorting in equilibrium are the following two. The first is one of on the shape of the utility function, and it relates to risk aversion. It holds under CRA utility function. And then the second is kind of very similar to the previous one we saw, augmented with like two elasticity terms on the right-hand side. Okay. So what's happening here? Risk aversion introduces two motives for low wealth unemployed workers. On the one side, there's the job finding motive. Okay, when the equation 3 holds, poor workers particularly care about finding a job quickly. Okay, for them, the unemployment state is very costly and they want to exit as fast as possible. On the other hand, the poor, they dislike job loss risk a lot for the same reason. Okay, and so that's what I'm calling the job security motive. When in equilibrium, the jobs that are easier to find are also the ones that are easier to lose, then there's a tension that emerges in equilibrium, okay, between these two motives. And from the worker's perspective, so before accounting for equilibrium sorting, the job finding motive dominates the job security motive if the semi-elasticity of job finding is greater than that of the retention probability. Okay. This looks very similar to the previous equation, and it's for a reason. So whether this equation inequality holds in equilibrium depends on how much tightness moves with type in equilibrium. And this is governed by the second condition in the proposition. Okay, so to wrap up, sorting emerges because agents resolve the trade-off between the matching probability and the job attributes differently along the distribution and on both sides of the labor market. Okay, so on the in a positive sorting equilibrium, on the firm side, high-type jobs, they value job filling relatively more. And so they will post higher wages to attract applicants. And on the other side of the market, wealth poor workers, they value the job finding probability relatively more. So this job finding motive dominates. And so they will apply to these jobs, even though they know that these jobs offer a lower wages and are more risky. So in this model, it is really the higher job finding probability that acts as a compensating differential for higher separation risk and not the wage. And I think this is a quite neat implication because and there's a large literature on wage compensating differential for job loss risk, and it's just been impossible to find evidence of that in the data. Okay, so here we have an alternative compensating differential. Okay, so now let me move to cyclical wealth sorting. As I said, I'm going to embed this mechanism in a more realistic environment. The horizon is infinite. I'm introducing stochastic aggregate productivity. And now I'm letting the job productivity to be linearly increasing in type. I'm also assuming that wages are fixed for the duration of the match. And I introduce a government that collects taxes to finance unemployment benefits. In the paper, I show that the equilibrium is block recursive, which allows me to solve for the individual problem, policy and value functions, without having to keep track of the distribution of workers across employment and asset states. Okay? So that offers a relatively tractable solution to this big model. Okay, I calibrate the model to the US at a monthly frequency. And I target one moment of the asset distribution, which is the aggregate MPC, and then different moments on the labor market transition rates between unemployment and employment. Okay, so I use the CPS to target the average U2E and E2U rates. And then, as I was mentioning before, I use the conditional PSID evidence to discipline how these transition rates differ in the cross-section across the wealth distribution, and also how this gradient moves as a function of the aggregate state. Okay, so let me maybe skip that. Just to say, okay, say quickly that, you know, in the data, the unemployment rate of the poor is more cyclical, and this is something that I don't target directly. It's a result of equilibrium sorting, but that the model is able to qualitatively replicate. Okay, so let's now think about what are the macroeconomic implications of wealth sorting. So I'm first going to show you the equilibrium. So the left, I mean, these graphs are the policy functions of an unemployed worker in terms of wages, but you know, the productivity looks very similar, and the resulting job finding and job loss probability that this search entails. So if you focus on the solid line first, you see that sorting is indeed positive. So poor workers apply to lower wage jobs that have, you know, a higher job finding probability and a higher separation probability. Now, in recessions, everyone looks for worse jobs. So the policy function, you know, shifts down, and this, in recessions, you know, overall job finding probability still decreases, and also the separation probability increases. However, if you compare, if you look at the dotted line, which is the recession scenario, but if agents would sort according to the boom state. Okay, this tells you that if workers didn't adapt their search, their job finding rates would decrease by much more, and however, the separation probability would increase by less. Okay, so in a sense, in recessions, workers decrease their search towards worse jobs to mitigate the drop in the job finding probability at the cost of the higher separation risk. So here I'm showing you how sorting plays out in equilibrium with the distribution of workers across states. So in the middle panel, I plot the density of workers in different labor markets. Okay, and labor markets are ordered here by increasing productivity, as shown on the left panel. So in recessions, which is the red colored distribution, open labor markets shift towards the left side, and it also stretches to the bottom. Okay. Also, the density of workers becomes much more concentrated at the bottom relative to good aggregate states. And to quantify the strength of positive sorting, I compute the target gap in search. Okay, so I compare the search in terms of productivity for workers at the 90th percentile versus workers at the 10th percentile of the asset distribution. And what you see is that that's shown on the right panel, the bars. The gap between across the distribution widens in recessions. And this is one sense in which sorting is stronger. However, I told you also that the width of the ladder stretches in recessions. That's shown in the bars here. But even if you normalize, the target gap by the width of the job ladder, still you see that wealth sorting increases by a lot in recession, so 35% versus 21%. Okay, so what are the consequences of a recession in this economy? So here I simulate a 1% drop in aggregate productivity, and I show you, for a start, the labor market responses. So wages at the bottom of the distribution decrease by much more than the aggregate. Wages at the top remain basically flat throughout. Okay. So wealth poor face larger wage declines and larger separation risk increases throughout. Their unemployment rate increases on impact and also throughout the transition, and it's at the peak of the unemployment rate, it's more than twice as much as the aggregate. Okay. Now the impact heterogeneity is due to equilibrium sorting, right? In the steady state, the poor, the bottom, bears more employment risk, which is amplified in recessions, right? So the impact responses are driven by the steady state sorting. However, steady sorting throughout the unfolding of the shock amplifies this persistence, okay? Because as you remember, as the aggregate state worsens, workers start looking for riskier and riskier jobs. Now, in terms of consumption, well, because of the higher job loss risk at the bottom of the distribution, consumption initially, decreases by much more at the bottom of the distribution again. Okay. However, conditional on being unemployed, and that's the middle panel here, you see that actually the consumption of unemployed is lower than that of the employed. Okay, and this reflects the fact that these workers, they can use their labor market search to insure against the risk of staying unemployed and low consumption. However, throughout the transition, this comes at a cost of a future consumption risk, okay, through through this larger separation risk. Because of this mapping between wealth and employment risk, the recession also generates a significant increase in wealth inequality, as captured here by the Gini coefficient. Okay, and now I want to talk about what are the implications for welfare. So the first thing I do is to quantify upward wealth mobility, okay, in this model. So I simulate cohorts that start at different levels of liquid wealth, and I compute the time required for them to accumulate assets up to the median asset. Okay? And
Even in this model, they only really different. There's no fun for other kind of permanent differences across.
No. Exactly. So this is a very parsimonious model to speak to the empirical evidence that condition on worker type. And I think like some further work could think about the interaction between this and skills, for example. But that's something I abstract from here. So I simulate these paths conditional on different paths for aggregate productivity. Okay, so the solid line here is a no-shock scenario. So aggregate productivity stays the same throughout. And then the different other lines implement, a short recession, which is 6 months, long recession, 18 months, or the same, but for booms. Okay. So the first thing I want to note here is that it takes around a bit more than 7 years for the poorest worker to reach median wealth in this model. But importantly, what I want to focus on is the slope of this curve, okay, which is very flat at the bottom. Okay, and this is the sense in which the model generates a sort of poverty trap. Okay, so in this region, marginally increasing liquid wealth does not improve the convergence to median wealth. And low initial wealth generates persistent difference in asset accumulations. Now, if you look at the different aggregate states scenarios, you see that the flattening is true for all of these scenarios. Okay, so it's always the case that there's a region where increasing wealth doesn't improve upward mobility. Another thing to note is that recessions significantly increase the time required for workers to build assets towards the median wealth, and this is true at the bottom of the distribution, but not as much, or absolutely not actually at the 20th percentile. Okay, so the aggregate state really matters for the bottom of the distribution, and recession, they delay significantly the upward mobility by a factor that is larger than the time of the recession. Okay, so a 6-month recession increases time to reach median wealth by 14 months at the bottom of the distribution. Okay. In terms of welfare, I compute consumption equivalent welfare costs over a 10-year horizon. So I'm leaving the opportunity of everyone to cross this median wealth. And I compare different cohort of workers simulated initialized at different wealth levels. So here I'm plotting, the bottom 1% and the top 5% of the initial wealth distribution. And what you see is that the losses due to recessions are large economically, and they're also very unequal. Okay, so low-wealth workers would sacrifice 2.8% of consumption to avoid a long recession, 18-month recession. This is more than 3 times the cost borne by the wealthy workers. And also, you can see that shorter recessions, of course, imply lower welfare costs, but these welfare costs are more unevenly distributed. Okay, the factor here is between the top and the bottom of the distribution is sevenfold. Okay, so with this, perfect, let me conclude. I showed you that in the data, low liquid wealth workers have higher job loss rates, both in the cross-section and as a function of the aggregate state, even conditional on workers' characteristics. I built a theory of wealth sorting into risky jobs to explain this. And the intuition is very simple, is that low wealth workers search easier to find jobs because they have an urgency to exit unemployment. The quantitative model shows that sorting is cyclical. It is stronger in recessions, and that the labor market can provide insurance against imminent consumption risk, but at the cost of future consumption risk. In terms of welfare, the dynamic interaction between wealth and labor market outcomes generates a sort of poverty trap dynamic, and welfare costs of recessions are concentrated and large at the bottom of the wealth distribution. Okay.
Are you discussing now? Is Peter,
Yeah.
Great.
Thanks so much for inviting me to discuss this paper. Can I use this clicker? Great. Okay, so I'm going to start by putting the paper in context with what I think of as some of the relevant background literatures. I'm going to explain the mechanism. I understand that Amalia explained it, so it's going to be a little bit redundant, but I think that's okay. And I'm going to clarify a way that I understand, and I think this also came through in Amalia's talk, how the mechanism is counterintuitive, and then I'm going to have 3 constructive comments after that. So one piece of background which came to mind for me when reading the paper is this literature on dual labor markets. So this is an older literature which thinks about a firm as hiring in 2 different labor markets. In one labor market, they hire for positions that are stable. Those positions tend to pay high wages. In the primary labor market, the workers will either come with or develop on site specialized skills, and then there'll also be advancement up a career ladder. And then there's a secondary labor market, which has none of these properties. You can think of it as just a spot market or a commodity market, which doesn't meet any of these 4 conditions. And a big question which this labor market literature asks is, well, why do workers get assigned to the primary labor market or to the secondary labor market? And you can think broadly, or I think broadly, about 2 different types of theories. So one is that firms rank workers based on, say, their skills, their ability to learn, their reliability, how well are they going to be a fit for these properties of what they're going to do on the job. And another would be supply. So workers rank jobs. Would I rather work in the primary labor market or in the secondary labor market? And in the way that this is set up, all workers are going to prefer the primary market, but they might not all get to be in the primary market. And so these 2 different branches or theories have different testable predictions in terms of these theories of why do workers get assigned to one job or the other have testable predictions in thinking about job queues. And this is obviously relevant for Amalia's model. So if firms rank workers and they just say, look, Amalia, you get to go to the primary market, Peter, you get to go to the secondary market, the assignment's done. We'll end up with similar unemployment durations because we'll each just be searching in separate markets based on our skills. The other is if the workers are choosing where to work and supply is the primary mechanism, then you'll end up with longer queues for the primary labor market. That's that. We lost our clicker. That's background 1. Background 2 is that there is a set of correlations between liquid assets, income, and job quality. I'm going to show you one example of all those things being correlated. So this is a paper that uses Chase Bank data that my co-author Christina Patterson presented on Saturday. So you can stratify workers by their income level, and you can stratify them by their liquidity, and you can just immediately read off of this, like liquidity and income are positively correlated. And then one of the points of the paper that Christina presented is that other measures of job quality are also going to move in the same way. So basically, the workers who have low liquidity and low income are going to have the highest labor income volatility. The workers with the highest income and the highest liquidity are going to have the lowest labor income volatility. Now, nothing, that's all within jobs, so it's not the same mechanism. My point is just all of these things of job quality and income and liquidity are all moving together. And then what we want to do is sort out what's driving what. And you can think about there as being a feedback loop where on one hand we have better paying, more stable jobs, and on the other hand we have more liquid assets. And so the sort of what I would think of as the obvious arrow is the top one, which is jobs differ in pay, the consumption function's concave, so the arrow is going to go this way. And then Amalia's paper is part of this literature, which I would think of as less obvious, which is workers with more assets can afford to be choosier about what types of jobs they take. And so there's been a lot of recent work. So there are many, many different papers, which are all in what I would call the sort of less obvious bin. You can think of Amalia as fleshing out and extending that side of the feedback loop. In order to explain the mechanism in Amalia's model, I'm going to start by actually referencing a paper that she builds on by Eekhout and Seppälä-Saari. So it's also directed search. It also has heterogeneity in wages and job finding. Workers with higher assets apply to jobs that are higher productivity, higher wages, lower job finding. And these are plots that I took from the Eekhout and Seppälä-Saari paper for the quantitative model, but all of these sort of predictions hold also in the 2-period model. And so now I'm going to do a quick audience, are you awake check. So I want to introduce a modest twist on the Eekhout and Seppälä-Saari model in period 2. So submarkets are going to now differ in terms of their separation rates. They're going to continue to differ in terms of productivity. Which submarket will the rich workers choose to apply to if submarkets differ in their separation rates?
Is it compensating regression?
Yes. So where will they apply?
Oh, the high volatility.
Yeah, high separation rate. So the rich workers know that they'll get a higher wage if they're in the jobs with high separation, and they're basically willing to tolerate that risk. And so I took the old Eekhout and Seppälä-Saari plot, I crossed out the job finding rate, the separation rate is going to go in the opposite direction for the exact same logic. It's the workers can tolerate risk, and so separation rates are upward sloping in assets in equilibrium. So this is also the mechanism in other papers like Yarosh. That's also in the paper. So this paper has 2 panels that are the same as Eekhout and Seppälä-Saari, assets rising, equilibrium wages rising in assets, job finding falling in assets. This paper has separation falling in assets. And so the thing I want to emphasize is just this sign is the opposite of what we would expect in partial equilibrium. So I'm now done with the first half of my discussion. I've talked about labor markets being vertically differentiated between potentially by demand, potentially by supply. I've talked about a feedback loop between employment and assets. And I've emphasized that the feedback loop runs through low asset workers choosing jobs with higher separation rates. And that this is somewhat counterintuitive because this is the opposite of the partial equilibrium prediction that's based on worker preferences. So now we're on to comments, and I'm right on my planned time. So the paper has this regression equation, which Amalia showed, and I've re-put up here, where the regression includes individual fixed effects, some controls, lagged assets, and lagged assets interacted with the business cycle. And the paper's interpretation is basically, if I find that lagged assets, conditional on the covariates, or lagged assets interacted with the business cycle, are predicting employment or are predicting job loss, then that's going to be taken as evidence that is consistent with the paper's theory. And one fun fact is that if you just almost literally, with very little additional intervention, try to replicate this in the PSAD, it all just goes through really quickly, thanks to Claude. So every coefficient basically in the paper, I was able to replicate. And so I don't have anything else to say about it other than it replicates. Okay, so I'm going to do, this is just an abbreviated version of that equation from before. I'm going to simulate a data generating process where employment is going to increase assets. That's the top part of that, what I call the obvious channel before. every worker has a latent employability that we don't observe. And employment status is going to be persistent with parameter rho across waves. I'm going to rule out what I call the less obvious channel. I'm going to assume that assets don't have any effect on employment. And what I'm going to do is I'm going to run a simulation. There's sort of specific numerical parameters that I sent to Amalia, and we can talk about, but I don't think they're important for the economics here. And basically, in this environment that I've just described, you can generate all of the regression coefficients on simulated data, even without the less obvious channel at all. So how is that possible? So basically, if a worker has a bad draw at t-1, and by the way, I should say, Raquel, you asked about this already during the talk, so this is almost like trying to run the simulation that you might have described, you might have been thinking about. So a bad draw at t-1 is going to depress your asset holdings. That's what I call the obvious channel. And because employment is serially correlated, you're also going to be less likely to be employed in the next period. And this particular correlation structure or assumption is not addressed by fixed effects. So having individual fixed effects basically doesn't help you at all here. And the reason is that the mechanism is dynamic. The mechanism isn't a time invariant individual fixed effect. And so it can't remove this bias. So my suggestion for comment 1 is that there are classic panel data methods which can address this particular bias. But they only address the bias if my simulated DGP is actually correct. So like, buyer beware. I'm not saying that this is the best thing to do for the paper. I'm just saying it would solve the specific issue that I'm raising here, which is related to Raquel's question. Comment 2, do more liquid assets causally improve earnings? So there's this paper that I really like by David Card, Raj Chetty, Andrea Weber, where in Austria, if you've been at your prior job for at least 3 years, you get 2 months of severance pay. And if you haven't, then you don't get any severance pay. And so they look at what's your wage at your next job. And they find that getting this extra 2 months of severance, increasing liquidity, does not lead to higher wages at the subsequent job. And there are other UI papers that also try to estimate things similar to this. They're not as clean as this, so I didn't use this example. But those papers also find that more generous UI does not increase wages at the subsequent job. Now, one thing you could say is, well, I don't want to think at all about causal identification. I'm just thinking about big patterns in the cross section. And so one question I asked myself in writing this discussion is, well, what variables are correlated with assets in the cross section? One good example is education. Education is strongly correlated with assets. Do higher education workers have longer unemployment durations? The answer is they don't. And so my take, this is my read of the evidence, just to be clear, is that there's not a lot of empirical evidence for a labor supply margin when thinking about liquid assets of the unemployed, because they don't seem to have much effect on earnings at the next job. So then I thought, okay, so what can the paper do, given that there isn't a lot of evidence on this sort of job choosiness by liquid assets channel? So to do this, I think it's helpful to review how the model and data are connected at the moment. So at the moment, there's this PSID equation that we've talked about, which relates employment or job loss to liquid assets. And then there's a basically reduced form job destruction function, which I've put up here, where the job destruction function is assumed to vary with how much liquid assets the worker has, or how many, really it's not the worker, it's like how many liquid assets are in this, the average liquid assets in the submarket. Like the firm doesn't know the individual worker's liquid assets. And so this is basically like, there's a structural parameter which is chosen to target PAG2, the regression parameter. And this assumes that the supply mechanism that's proposed is the correct one. But it could be that there's just differences in demand. So the firm is choosing to lay off low asset workers first because they have lower productivity. And so I wonder whether or not it's possible to provide more direct evidence for the sort of unique and innovative mechanism in the paper beyond just sort of targeting that regression coefficient with sort of reduced form job destruction function. So I wonder if we could, on the search side, see workers targeting jobs with a higher separation rate. And the sort of way that you might be able to look at this is you could construct cells of the labor market by industry or occupation or other observables with higher and lower separation rates. And then you could ask questions like, do low asset workers tend to apply to high separation cells? Do low asset workers tend to land and find jobs in high separation cells? And then are those jobs with high separation rates cheaper to post? So I don't think there's like one obvious must test, but I think that there's an evidence gap which could potentially be addressed by future work. My third comment and my final comment is that the most basic empirical finding in this paper, higher separation rates for low asset workers, holds regardless of cyclicality. And so to me, and again, this is a subjective assessment, cyclicality becomes a needless complication, which could distract from the clearest statement of the paper's contribution. And I understand that the paper's regressions are using cyclicality for identification, but I don't think that it actually needs to be in the model to get to, for me, to what's sort of the most unique and insightful part of the paper. The final comment, which I tucked in here, is that the policy counterfactuals, I think, either need more realism or potentially could be dropped. So just to give two concrete examples of that. One is if you model unemployment benefits, then you need to incorporate moral hazard, and you need to target existing estimates of moral hazard. And then second, the counterfactuals currently assume that the US government can target transfers based on wealth, but the US government doesn't observe wealth, and so can't target transfers based on wealth. So to wrap up, this is a neat new paper on the feedback loop between assets and labor market outcomes. There are a lot of papers in this space, especially over the last few years. What distinguishes this one is a counterintuitive finding that low asset workers choose jobs with a higher separation risk. And the mechanism is exactly what Amalia said, which is it assumes correlation between jobs with a higher separation risk and having a higher job finding rate. And so my suggestions are to adopt panel data methods to avoid bias in equation 1. That I think there's not strong evidence that assets improve the earnings of unemployed workers. And so I think it would be great to find alternative data to support this unique and innovative mechanism. And then third, I would consider dropping cyclicality just because I think it actually potentially is a distraction from the sort of most insightful parts of the paper.
Perfect timing, thank you.
I had a similar concern as Raquel and the discussant, Peter, which is if something more could be done on the empirical front to support this theory versus, which is about labor market sorting versus some other theory. And the things that I was thinking about is, could it be about deterioration in mental health or physical health, which draws down your wealth and at the same time makes you less productive and lose your job, or it could be drawing a bad marriage match or something, which also makes you less productive in the labor market because of the bad marriage draw and less incentive to accumulate wealth because of how the divorce laws are set. So if you could do something more.
Kyle Herkenhoff, University of Minnesota. So really enjoyed the paper, really enjoyed the discussion. So I also wanted to reiterate one of Jonathan's questions, just this tension between, you're writing down this macro model, you're studying business cycles, you have a moment you're targeting that's conditional on a fixed effect. You say you're taking out this worker heterogeneity, but the rest of the moments in the aggregate economy, presumably much of those fluctuations are driven by worker heterogeneity, and that has a meaningful full role in those impulse responses. So I want you to comment a bit more on, whether there's a way to residualize the rest of the moments with respect to the worker skill level. On Peter's comment, actually would push back a little bit on the there's no evidence that wealth matters for the unemployed and for labor markets. I mean, so I just looked this up. So usually these European studies do find very small effects on wages. Guess what the Austrian household savings rate is? It's 14%, okay? And the US is about 3%. These people already have very large buffers of assets. If you look in the US, so like Golisov and Norvinsky's paper on lottery winnings, you see very large responses in labor markets and earnings and job switching rates. And he and NBER have a really clean study on mortgage reforms in Europe, and as well as my work on credit constraints. I have some more comments just on the business cycle.
I totally agree that labor supply matters a lot for employment. It's just specifically when unemployed.
We have a few more
Yeah,
comments.
A great presentation. So just one quick question on the macro side, given that you have all this nice macro stuff, do you also get average costs from the business cycle because you showed the one-sided cost, and here there is a mechanism where you could get this poverty trap. So do you get an average welfare loss as well that's sizable?
So I just wanted to alert you to another paper that I think could help bolster what you're arguing, even though it's not necessarily on that exact sorting. Our job market student, Diva Asanova, looked at Canadian data. She only looks at college graduates who are graduating in a recession versus not in a recession. And she controls for majors, institutions, et cetera, you name it. And what she finds is that according to your parental, and I forget if it's income or wealth, it's probably income, people with low income parents from the same institution, same majors, they're going to be sorting into low wage jobs, not because of your risk mechanism, but rather because they just can't access the credit market very well. And so they need to take more or less the first jobs that comes around. But that has permanent implications. So it shows that it takes 10 years to get back up to where other jobs are. So it's first job scarring type of literature, but it is coming from the welfare income part of the parental income distribution. We have time for one more and then.
So two very quick points. The first one is looking a little bit farther out. I was trying to think what the model would imply from a recession perspective. Like there's a long literature suggesting that at the beginning of recessions, you have a large decline in job finding rate and not a huge increase in the separation rate, take COVID away. So I don't know if the model would suggest something similar to that. The other thing is, have you considered from an empirical perspective, thinking about the effects of policies that require work in order to collect benefits, because those might be relevant in the margin that you're thinking of, in that I need any job because I actually need a certain amount of income, a certain amount of hours worked, regardless. So I really care about the job finding rate for whenever I need the job. That's it. Thank you.
You have 1 minute in which to answer.
Well, I guess I'm going to talk to most of you in the break then. No, but thank you for the great discussion. Just to emphasize this point on like an latent heterogeneity that is time varying. I think what I'm trying to do that I didn't have time to show you, but is to control for past labor income. And, like if you think that labor income is correlated with unobserved employability or ability, this should kind of control for these concerns, like this dynamic unobserved heterogeneity. About mental health, actually, I think the coefficient, the fact that poor workers are more likely to find job kind of goes against that, right? I would expect then if there were remaining such heterogeneity, that this coefficient would go in the opposite direction. About let me skip that. Okay, about residualizing the skill component. I mean, so I agree that this model is very parsimonious. It's just really on wealth heterogeneity. There's nothing that relates to skill. I think that actually studying the interaction of this mechanism with skill would be very interesting, and that's something I'm pursuing in another project. And potentially it could lead to much more persistent losses. Now, that's why I condition my moments to the residualized moments in the PSID, because I don't aim to target, realistic distribution of risk in this project. About the average welfare cost, okay, that's going to be my last answer. So in the last picture, you actually saw maybe that the big gains from symmetric booms are relatively symmetric. Okay, so on average, actually, ex ante, workers don't lose that much from stochastic aggregate productivity. It's order of magnitude of 0.20% if I remember correctly. But conditional on a recession, then they lose a lot. Okay, so let me stop here. Thank you for the comments.
Is by brother on regional occupations or the land and worker mobility.
Right, does the clicker work? Yes, perfect. Okay, I'm Johannes. I'm super glad to be here. I'm super excited. And this paper is called Regional Occupations, Local Rents and Worker Mobility. Now, I start from the fact that in all developed economies, it's really well known that there are large regional wage differences. So regions with high overall wage levels and regions with low wage levels. And one view of this could be that workers who move to the high wage regions could materialize large gains. But at the same time, worker mobility is low. I'm going to show you that in Germany, about half of the workers don't even move out of their very first commuting zone even once. But this begs the obvious questions. Well, why don't the workers move to opportunity? Why don't the workers move to the high wage regions? So there are a couple of possible explanations that include things like large moving costs. So if workers don't move, they must really hate moving, or local amenities is the opposite thing. So if workers don't move, they must like where they are. Or sorting stories, any version of the productive workers and firms meet in one place and the unproductive workers and firms meet in another, and that's an equilibrium outcome, and then nobody can move. Alternatively, it could be true that the gains are not as large as these raw wage difference that you look and suggest in the first place. For once, the places where the wages are high are also expensive to live in, for example, have very high rents. Different regions have different kinds of jobs. So what I'm on about here is different kinds of occupation. This also puts a question mark behind whether workers can easily move to another region and just like that materialize wage gains. And then there's an inherent life cycle dimension to a moving decision, because it just matters whether you're just at the beginning of your career and you could potentially realize a lot of wage gains over your life cycle, or you're already well into your career. Now, in this paper, I want to take precisely these things seriously, and I want to revisit gains from moving from a life cycle perspective. So here's what I do. First, I go to high quality German admin data that allows me to study this question. It's very hard, demanding on the data. And I have here rich data on the region that workers work and the wages that workers earn, and even occupation, which is something you cannot see in a lot of admin data sets. And I'm also able to track the entire labor market histories of workers. And with this data, I uncover three important facts. One is the difference between the high and the low wage regions is not just in the level, but in wage growth over the career. So it's not really true that workers in their 20s earn so much more in these high wage places, but they have better careers, better wage growth, and they earn much more later on. Second, occupations are regionally concentrated. And in fact, occupation structures can account for large parts of the variation of wage levels and wage growth. And this matters because people in different occupations accumulate different skills. Now, with these facts in mind, I then go on to write down a spatial life cycle model of work mobility. I'm going to use this. The model has the necessary ingredients to speak to the facts I find in the data. It's going to be a model with two regions, local labor markets and local rent markets, and region-specific skill accumulation. And I'm going to use this model to interpret the facts I see in the data, rationalize low work mobility, and then quantify different channels that keep workers from moving, and then evaluate a little bit, think a little bit about what policy can do. And what I find is that the reason why workers don't really move is really a dynamic interaction of the labor and the rent market. So young workers would, in principle, love to move to a place where they can have a great career and have great wage growth. But in equilibrium, these places have high rents and they're going to be expensive to live in. Young workers have only little wealth. They earn only entry-level wages, and for them, it's really painful to move to these expensive places. Obvious solution could be, well, you just start working where you are, and then you save until moving to these expensive places isn't really so painful anymore. But in doing so, you have to work where you are. And on average, people accumulate skills that are specific to their local labor market. And then later on, there are just no gains that you could materialize from moving, and the incentives have gone. Taking these mechanisms into account, I find that when I quantify how people who move in my model evaluate the direct moving costs as utility and resource moving costs they have to pay, this is on average around 17,000 euros, which is an order of magnitude smaller than what a lot of models have to use in order that don't take these mechanisms into account to rationalize low work mobility. And then, since the main obstacle in the way of young workers moving to the growth region, to opportunity, if you like, is the high rent price evaluate policy, where I let government increase the housing supply in the growth region, and this I find this to be welfare increasing in both regions. Okay, let me start by talking to you about the empirical part of the paper. So first, the data that I use the SIEB, which is a sample from the German Social Security records. So the way this works is that in Germany, every employer is obliged to report a lot of information about each of their employees to the government, and then I get a sample of that. And this is great high quality data that is very reliable. And I have daily information on wages, the county that workers work in, and some demographics. And in particular, I can also see occupations in my sample at the 3-digit occupations level. Now, I'm going to use a couple of sample restrictions. So I'm only going to be looking at men, and only be looking at West German men, because for the cohorts I look at and female labor supply is low. West Germany, because East Germany only is the data from the 1990s, and also it joins after some decades of socialist dictatorship. So just a difference there that I don't really want to be taking care of here. And I impose that because I'm interested in long life cycles. These workers are there for a reasonably long period of time. So I want to impose that they're already there at the least at 30, and that at least still there at 45. I look at different cohorts, but because the results are very different, very similar for all of these cohorts, I'm just going to be showing you results based on people born between 1960 and 64 today. And I aggregate my data up to the commuting zone level. So in America, where everything is bigger, I think I need to put this into context. So if the average commuting zone were a circle, the diameter of these commuting zones would be 45 kilometers. Right? So it's these are not really huge areas. And then I have some regional price data. I use a regional CPI from the Federal Office for Building and Regional Planning, and county level rent data.
So there's not been a change, you were saying, in labor mobility in West Germany then over this time period? Is that what you're saying with the three cohorts and that they're very...
Yeah, like all of the things that look pretty similar for people in West Germany. Like, I mean, I exclude everybody.
Yeah.
That's true. Yeah. Yeah. So no, exactly. So this is something you don't really see in, as far as I know, other European economies as well. So in the US, labor mobility goes down. In Europe, it's more or less stable. If anything, it goes up slightly. All right. So this is to give you an overview of the geography. So here on the left, I have a map of West Germany, and these are it's colored according to the average log wage, and the little areas of the commuting zones I just talked about. And you can see that this the sort of the support span is about 0.6 log points. So the extreme difference we have is up to over 60%. And not only that, these differences are also very persistent over time. Here on the right, I have average log wages in 1990 on the x-axis, average log wages in 2010 on the y-axis. And as you can see, and each of the little dots X represents one of the commuting zones in the map. As you can see, this is very persistent over time. But people don't move around a whole lot. Here, what I plot on the axis of age, on the y-axis, I have the share of workers that have not left the very first commuting zone that started their career in blue. And as you can see at 55, this is close to 0.5, meaning that almost half of all workers haven't even moved out of the very first commuting zone even once. And it's also not true that the remainder of the workers move around like crazy. So in the dashed line here, I show you the share of workers that hasn't moved further than to a commuting zone that's just next to the one that they started in. And as you can see, with that, you capture around 70% of people that are 55. So careers in Germany happen in a very confined local space typically. So how do we square this? The first thing you could be thinking of, well, the places that have high wages are also expensive to live in. Is that already the entire explanation? Well, to have a look at this, I take my 200 commuting zones and bin them into 3 groups using rent terciles into the high wage expensive places, the cheap low wage places, and the middle bin. And then I track workers that start their careers in these 3 bins over their entire careers and calculate log wage profiles. And I'm going to be using my regional CPI to take into account regional purchasing power differences. So on the left, you see exactly that. This is the average log wage profiles. The green line that you see on top at the end is the people that start their career in the high wage expensive places. The blue line is the people that start in the cheap low wage places. The orange line is the middle bin. And so you can see the difference is better. I subtract the national average at each age, and then we get to the plot on the right. So what we see here is that at the beginning at age 25, the people in the cheap low wage places actually earn about 6% more in real terms than their counterparts in these expensive high wage places. However, the people in the high wage places then have faster wage growth overtake in their 30s, and then they earn around 10% more in real terms when they're 50. And in particular, so the difference is really in growth, not in the level. And in particular, if I put this in a dynamic regression framework where I can take out worker fixed effects and also education by age fixed effects, I don't find any evidence that this is just a sorting outcome. So what does turn out to be really important, however, is occupations. So first up, occupations are spatially very concentrated. So when I look at the 20% of commuting zones that employ the most of each occupation, has the highest employment share of each occupation, I find that they employ between 50 to 90% of employees in that occupation. So occupations are really concentrated in commuting zones. And in particular, even if you take into account that some of these commuting zones have different sizes, this pattern doesn't go away. And now I want to show you that the wage profiles I just showed you 2 slides ago also reflect this. So to do this, I eliminate all the within occupation wage variation. So what I do is I do a counterfactual exercise where I give every worker who has the same age and the same occupation the exact same wage, which is going to be the national average. And the result must reflect only differences in the occupation composition, only quantities, if you like, not price differences. So what you see here, the solid lines are the same wage profiles I showed you two pages ago. And the dashed lines is what you get out if you do this counterfactual exercise. Now, because they reflect only differences in the occupation composition, if the occupation compositions behind these 3 bins here were to be the same, all of these dashed lines were to be exactly at 0. But instead, we get out the exact same picture that we got before, which means that behind these different wage growth profiles, we have different occupation compositions. So people in different regions must work in different occupations. Now, taking stock. I've shown that the difference, first of all, the high wage regions are expensive, but and this matters because the difference is really in the growth, not in the level. In particular, people in different regions work in different occupations, and this matters because we know from the literature that large parts of human capital are in fact occupation specific. So people in different regions must therefore also accumulate different kinds of skill. Now, with that in mind, I'm going to write down a general equilibrium model with 2 regions that's going to rationalize these facts and allow me to rationalize low worker mobility and quantify some forces. So here's what this model looks like. First, let's look at workers. So workers live for 60. It's a life cycle OLG economy. Workers live for 60 periods and they work for the first 40. They draw utility from a general consumption good and from a housing service. And the utility function takes 2 things into account. One is that there's a subsistence level in housing. This is going to capture that if you want to move somewhere, you cannot choose to live in a letterbox, but in particular, it's also going to give me that, just like in the data, poorer households, and this is going to mean by usually younger worker households have higher expenditure shares in housing. And because when I go to German survey data, I also see that for the cohorts that I'm looking at here, for families, usually 80% on average of income is male labor income. I just impose that this is actually household income, and then I use the OECD equivalent scale and estimate from survey data the household wages, and so that's taken into account here. So there are two things that evolve stochastically. One is the skill. So there are two kinds of skills. This is key. I'm going to be spending the next slide explaining what exactly they do. And then there's an idiosyncratic productivity shock that's standard AR1. Now here are the decisions that workers take. So there's a moving decisions. So there are only two regions, but workers get to choose which, if they want to move to the other region or not at the end of the period. If they choose to move, they have to pay an exogenous moving cost that has a resource component that enters the budget constraint and a utility component that enters the utility function directly. And the location choice is subject to a very standard extreme value type 1 IID taste shock. And then at the same time, workers get to choose how much they want to consume, how much housing they want to rent, and how much they want to save. So workers can save, but they cannot borrow, so there are borrowing constraints. So how do skills look? So there are two kinds of skill in the economy. You can think maybe this is working with metal, working with electronics, and they both live on a grid. So first of all, what do? Well, they help workers produce efficient units of labor supply. So an efficient unit of labor supply is going to be this Cobb-Douglas composite of these two skills, and the idiosyncratic productivity shock, and then labor earnings are this efficient units of labor supply times the price for an efficient unit of labor supply in that region. Now, the really important thing to notice here is that the Cobb-Douglas weights for these two skills depend on the region. I'm going to impose that in region A, the A skill is weighted higher, and in region B, the B skill is weighted higher. So what this means is that the A region specialize in the metal skill, and if you're good in that metal skill, this is going to be more rewarded by higher wages because you kind of produce more efficient units of labor supply. In the other region, it's the other way around. Working with electronics is rewarded more. So how is this reflected in how workers build up human capital? So this happens stochastically. So in each year that workers work, for each of the skill, there's a distinct probability that they move up the skill grid. So two things. First of all, these probabilities decay with age. So this is very standard in the human capital literature. This is going to capture that it's just getting harder to learn new stuff as you get older. In particular, it's going to give me that the log wage profiles I get out of this wage growth here are hump-shaped like in the data. And then these probabilities are weighted by how productive they are in the respective region. So what this captures is really learning by doing. If you work in the region where working with metal skill is more important, that means you get more chance to apply it. And on average, the probabilities of you learning that skill is going to be higher. And in the other region, it's going to be the other way around. Now, one of these regions in particular, that's the B region, is going to have the skill that is emphasized in the B region is going to have higher accumulation probabilities overall. What's this going to give me is that this region on average has higher wage growth. And of course, the weighting the probabilities is going to give me that if workers work in a particular labor round for a long period of time, on average, their skill sets are going to reflect what is more productive in this region.
Sorry, this is supposed to capture learning by doing, the fact that you're weighting that probability by 18?
Exactly. So if
we should think that there's more work.
No. So what I impose here is that so A is safe as a metal skill. In region A, that's more productive. And I see that this must mean that people do that more. And then in that sense, this captures learning by doing. All right. Okay, to close the model, how do regions look? So in both of these regions, there's production, and I assume that in each region, there's a different intermediate output good that is being produced using only labor supply. Now, there are a lot of spatial labor market models out there where each region produces the final output good, but because I see that different regions do different kinds of occupations, I assume that they must produce different stuff, and then that is nationally aggregated with the CES aggregator. And you could think of this as a representation of two regions producing different things, and then there's trade. And this is going to give me going to imply a price for an efficient unit of labor supply in each region. So each region has a fixed housing supply that is rented out at an equilibrium price. And equilibrium is going to be steady state. I'm clearing the labor markets and clearing the rent markets. I am taking the interest rate as given, so we're in a small open economy. Now, to calibrate the model, I'm going to use the people born between 1960 and 64, and I'm going to use ages 20 to 59 to represent my model periods. I'm going to keep prices at the 1995 level. So in the model, I only have two regions. In the data I showed you, I had 3 bins. So to get to 2, I'm going to combine the bottom 2 bins, and I'm going to keep the expensive high wage bin as it is. And this is going to roughly split the data into 2 parts of equal size. And then I jointly calibrate the parameters that govern the skill accumulation and the regional skill weights, as well as the utility moving cost and the taste chart dispersion, to jointly match the life cycle wage profiles and the share of people that haven't moved out of the first region over the life cycle. So here's how that looks like. On the left, I show you the just nominal wages. So this is the log wage profiles of workers that start in the B and the A region and in the data equivalent in the dots. So I can match this very well. And on the right side, I show you the share of workers that haven't left their first workplace yet by region. And as you can see, first of all, the shape, I can get out the shape quite well. But in particular, it's also true that at the margin, there are more people that move towards the richer region than there are people that move out of the growth regions. That's why the blue line is below the green line. This is something that the model also gets at. And this is also true in the data.
So for the left picture, is it just that there's more learning by doing in the B industry?
Yes, just that each of these skills has a different decay process of these learning probabilities that are then weighted with how important they are in each region. And for one of these skills, this probability is higher overall, and this is what drives the faster wage growth in the region that emphasizes the skill more. So what does this mean for real wage differences? So in the model, they come in because I have the consumption good, that's the numeraire, and I also have the rent price. And in equilibrium, what happens is that the old guys in the growth region are very rich on average, and they're going to rent out a lot of housing. That's going to drive up the rent price, and that's going to make life hard for younger workers who want to move there. And then I can compute my model internal regional CPI, and then I can compare the demeaned log wage profiles in the model and in the data that are region CPI adjusted. And even though prices are not specifically targeted in the model, I get out the model gets very close to the empirical real wage differences. Now, why don't workers move in this model? So the main forces that keep people from moving is, of course, there's a direct moving cost. That's the exogenous part. Then there's the higher rents in B that keeps back people who want to move to B. And there's going to be human capital mismatch. So first of all, to give you a sense of how hard it is to move people around in this model overall, I'll compute 2 things. One is just how much money do I have to pay people in order to make them move, or at least make them indifferent between staying and moving. And that number, if across all states and ages, is on average 47,200 euros. And I can also compute how important is really the exogenous part, the direct moving cost, and I can calculate the average of how people who actually move evaluate these exogenous moving costs, and there I get to these 17,000 euros I mentioned at the beginning, and this is an order of magnitude smaller than the several hundreds of thousands of models that do not take these life cycle considerations into account need to reproduce low worker mobility. Now, to show you how the different channels matter differently across time and across the life, age, and space, so what I do is I look at the transfers I need and what I need to pay people in order to make them move. by age, I look at people that are in the beginning at 20 and people that are already a little bit into their career at 45, and at region A and B. So the first thing to notice is that actually it's not really that hard to move young people. And it is a little bit harder to move people out of the growth region, that is region B, than the other region, but the difference isn't really that large. So one way of reading this is, well, that people in the growth region, they like their career prospects, they hate the rent that they're paying. In the other regions, it's the other way around, and therefore the difference isn't really that large. And then with age, these numbers get quite a bit larger. This is for two reasons. One is that people at 45 have larger families and then it's harder to move. The other reason is that they have a specialized human capital. Now, the next thing I want you to notice, if you look at people that are 20, what's most important in holding back the people that want to move towards the growth region, it's really the rents. So these numbers are negative. That means now if I fix the rent price in the growth region and I impose that it's actually the same price as in the cheap region, then I need to pay people not to move, right? So I get negative 8,000. So just shutting down the exogenous part of the moving cost will also will also induce that I have to pay people not to move, but the effect of the rents is larger. So the rents are really the main problem for the young workers. Now, for people at 45, if I shut down all the things that kept the young workers, that's the exogenous moving cost, and I also fix the rent price at the cheaper level, I still have to pay people in order to move. And that means that there are now no more incentives to move. People have just now a specialized human capital and the incentives are gone. Now, since the main obstacle in the way of moving to the growth region in the way of young workers in the poorer region is the high rent price, I then evaluate the policy counterfactual where I let government increase the housing supply in the growth region by 3%. This is not a number that I pull out of thin air because there are construction projects that are going on now in some cities in Germany that are of roughly this magnitude. And I take a construction cost from the German Federal Office for Statistics. And if I let a government do this, it had the immediate effect that rents fall in the B region, and this increases mobility from A to B because the young workers can now move more easily. And it turns out that workers in both regions like this. So people in the growth regions mainly like that this lowers their rents. What they don't like so much is because I have this CES aggregator between the two intermediate output goods. Actually, as I reallocate labor supply from one region to the other, general equilibrium effects are relatively high, much larger than in models where every region just produces the final output good. So wages in B are going to fall as well, but the rent effect dominates. Young workers in A, they're going to like that they have an easier time moving towards the growth region. And because some more people move towards the growth region, there's going to be higher wages in the A region, and there's also going to be lower rents in the A region. So this is where the welfare gains come from in the A region. And I find that in both regions, you find consumption current variation of order of magnitude of 0.8%. All right, wrapping up. I showed you in the data that the difference between the high and the low wage regions is really in the wage growth, not in the wage level. And these wage differences, wage growth differences reflect different occupation compositions. Then I proposed a new spatial general equilibrium model with specialized human capital accumulation that can allow us to square the two things that I see that there's differences in wage growth, but also low work mobility. And I don't need the extremely high movement costs that some other models that do not take my mechanisms into account have to assume. And the key mechanism was that young workers are locked out of the growth region by high rents, and older workers are locked into the region by specialized human capital. And so one way of reading my paper here, the bottom line is, if you believe my model here, at every stage of the life cycle, there's just economic reasons that lead to gains from moving being low, not as high as you would think just looking at the raw wage differences. Thank you very much.
President Macroeconomics.
Thank you very much for inviting me to discuss this paper. This is a very interesting work that revisits a sort of classic question in the regional mobility literature, that it is, why is it the case that regional mobility is so low, despite there are large and persistent differences in wages across regions that should incentivize workers to move? And one answer that often comes back in this literature is that perhaps it must be the case that there are very large moving costs that are preventing these workers from moving. But this paper is revisiting the answer to this question, and it does this by proposing this two-region general equilibrium life cycle model combined with data from Germany. And these are the two sets of ingredients in the model that deliver the answer to the question. So first, on the one hand, the individuals are facing borrowing constraints that mapped with rents that are endogenous in general equilibrium, and the subsistence level of housing, which is particularly binding for young and low-income households that are find it very hard to go to high-rent regions where housing is expensive. Well, that means that the young workers cannot borrow against future wages in this expensive region. Then we have a second set of ingredients, which is a regional-specific human capital accumulation process, which means that the skills are accumulated by workers working locally, and they are less valuable in other regions. And putting this together, the main answer that the paper gives to the question is that the combination of general equilibrium rents and borrowing constraints are locking the young workers out of the high opportunity area, where rents are just too high. And then the second set of ingredients, so the region-specific human capital accumulation process, is then locking in the older workers, that once they have started working in this lower wage region, after a while they have saved enough assets, so they might consider moving now. But at that point, they have accumulated a skill that is specific to the region and less valuable in the other place. So at that point, it's not as appealing to move anymore. And as a result of this, the paper can explain the mobility rates with much lower moving costs. We've seen now some summary statistics. The one I picked here is what is the compensating differential here calculated that we should give these workers to move on average in a partial equilibrium exercise. It's around 47,000 euros. Now, starting from the empirical side of the paper, so this Johannes discussed in detail, so I will be brief here. I just want to mention, so the data comes from Germany, so you might be wondering, are these facts that motivate the model specific to Germany? And in fact, as I put some hints here on the paper, these facts are applied to many countries, and they are consistent with empirical evidence that we have in the literature from different locations. And the mobility rates in Germany are broadly consistent with mobility rates in the rest of Europe, where in general, geographic mobility is lower than in the United States. And then secondly, the fact that these high opportunity regions that also have high rents, what they really offer is, importantly, a steep wage growth profile rather than initially high wages in levels, and that the high wage profile comes from a different combination of occupations. This is also consistent with evidence we have from other countries, from Spain, France, Denmark, the US, etc. But let me also highlight here two very nice features of this very rich administrative German data. One is that this allows to sort of follow workers throughout their career and compute the sort of completed mobility. So not just the mobility rates in any given year, but by the end of the career, what is the probability the worker has moved? So that's a nice additional statistic. And second, it also allows, when looking at these high wage growth regions, to understand what share of this high wage growth can be attributed to the local occupation mix, which is an important ingredient of the model. And the paper finds that it is roughly 50% of the variation in the data is explained by these different mix of occupations. Now, let me then move on to the model, where I think here is really the key contribution of the paper. And what I want to highlight here is, first of all, what are the novel parts in this model and how does that contribute to the existing literature? And this is a paper, so in this table, what I'm showing here are some recent papers that are closely related to Johannes' work. And this is a model that essentially belongs to the part of the literature that is studying the life cycle mobility rates of workers. Now, what is really unique about this paper is the combination of the life cycle with the 4 following ingredients that you see in the table that appear in some of these other papers, but never all of them together. So let me walk through this. As we have already talked about, one important additional ingredient is the presence of these borrowing constraints that is limiting the mobility, especially of young workers. And this is an idea that appears, for example, in the work of Bilal and Rossi Ansberg that are introducing this idea that the location choice is really an asset for the agents. And then comes back again in some others of this paper in the literatures, for example, the work of Janon and co-authors. This contains many similar elements to this paper. It's a life cycle model with borrowing constraints. There are equilibrium rents and general equilibrium wages, but notice that in the second column, that paper is not thinking about region-specific human capital accumulation. And this is what is really unique to this paper. And let me highlight here that there are 2 parts to this second ingredient. One is the idea that there are different skills in different regions, and those skills have different prices, or they are valued in a different ways in the different regions. This idea is out there in some of these papers in the literature, but there is a second component to this that is, how are those skills accumulated over time? Now, some of these other recent papers in the literature, the ones that in the second column have the hollow circle, including some recent work of Diaz and co-authors, Luli Aguilar, they have in their model this idea that the high opportunity regions are regions where wages are growing faster. But in their setting, these skills that are accumulated over time faster are then portable, and the workers can take them with them in other locations. And so finally, in this paper, what is really unique is the combination that there is skills accumulation, but it is specific to the regions, and these skills that are being accumulated cannot be as easily brought with the worker to other places. And so all of this together is delivering the 2 mechanisms of the young workers being locked out from the high opportunity region by the borrowing constraints and the rents, and the olds being locked in the low wage region by the region-specific human capital accumulation process. And as Jonas highlighted in the end, the nice feature is that these 2 mechanisms together are covering the entire worker life cycle, so they can explain low mobility rates throughout the life cycle without the need for large moving costs. Now, moving on to some of the comments, I also wanted to then highlight at the end of the table, there is 1 column instead of mentioning some ingredients that have been shown to be important in other papers that this model is missing. And the first one that I want to mention is the endogenous agglomeration. Why talking about this? Well, my first observation is that, so this model is parsimonious, and I think this is great, it's very valuable. It is a model of 2 regions, unlike many of the spatial papers that have a lot of regions. But what this allows Jonas to do is to have rich dynamics. So agents are making forward-looking dynamic decisions. They are making decisions about asset accumulations over time. There are general equilibrium wages and rents, and there are these skills that evolve over time. And also the fact that the model is so tractable makes the intuition of the mechanism very clear. What I want to highlight here is that this comes with some very strong assumptions and potentially missing elements that I think may be important not for the main story of the paper per se, but especially when it comes to the quantification of these moving costs and the policy counterfactuals. One is this idea of endogenous agglomeration that is very important in this literature, and it comes in different ways. One way of thinking about it, as it comes in Lulia's paper, as well as some of my own work on neighborhood mobility, is that the reason why the high opportunity region has high opportunity is endogenous, and it depends precisely on what kind of agents are sorting to that location. Whereas in this paper, the region B is better, but it's better for exogenous reasons. Its use is more a skill that is exogenously accumulated faster. So my question here, what if in this model the appeal of region B were to depend on the agents that actually sort to that location? This might be an important factor, especially when it comes to the policy counterfactuals, because that means that trying to change who is sorting to what region might change what are the wages and the appeal of the region itself. And in fact, both Lilia's work as well as our own work has shown that once we take this into account, some policies that try to move people around might become self-defeating, because as they try to move people to high opportunity regions, they're going to endogenously change how valuable the region is, and so they are decreasing the gain for moving, and they might also induce some people to move out. And next interesting elements that and let me also just mention here, both this element, the endogenous agglomeration, and the next two that are coming, I also think precisely because your model starts from being so parsimonious in tractables, I think it should be relatively easy to incorporate and see to what extent they're changing the results. The second one is the assumption that in this model there are two skills, skill A and B. The assumption is that at birth, agents start with the same endowment of the two skills, regardless of what they're born. And this to me made me think about two possible mechanisms that might work in opposite directions, in the sense that the first one might increase mobility, the second one might lower mobility. One is that in practice, ex-ante agents might want to invest in education to increase the skill that could be particularly useful for them. For example, the portable skills, if these are agents that are more likely to move. On the opposite side, one might also think that instead agents might be born with a location-specific skill endowment. That is, why would that be the case? For example, the local schools are providing training in the skill that is more valuable in the local labor market. And this second factor might actually lower mobility even more. And this might seem far-fetched. So here I just wanted to actually mention some evidence on number two that comes from some work I did with Josh Morris Levinson. This is a different context, because here we were looking at historical census data on the US, and this was intergenerational mobility between father and son and interstate mobility. But the key fact that came out of that is that we observed that the probability for individuals to switch across sectors, because we don't have occupation in this historical data, but switching sector is more likely to happen for individuals that are also moving across states than for individuals that stay within the same state. And then in that paper, we do some work to essentially point to the fact that the reason is that people are born with a certain endowment of skills that is tailored to their origin location. And giving up those skills might be costly, but once these individuals are moving, then those skills are not as useful anymore, and so they might as well switch to a different industry. And this is another point where this rich administrative data actually could be very useful to separate this initial endowment effect from the subsequent learning, because you can observe post-wage growth profiles for these workers that, for example, are not available in this historical data. Okay, and one more element that I wanted to highlight in the current structure of the model that is somewhat of a very stark assumption is that here essentially in this model, occupational choice and location choice are 1-for-1. And the reason is that the workers have these two skills. This equation we've seen in the presentation before are the efficiency units that the workers apply. And the two skills are they're using different intensity in the two regions. So this essentially means there is an occupation A in region A and there is an occupation B in region B. And so if agents move, they're also going to use that different skill mix. Now, I think for quantitatively, especially for measuring these moving costs, it might be useful to relax this a little bit and potentially allow multiple occupations in each region. And that is because in this case, the workers that think they might want to move, they have the opportunity to choose already the occupation that has the skill mix that is more portable. And I think this might be interesting for two reasons. One is because it could provide interesting additional testable implications of which individuals in which occupations are more likely to move, depending exactly on the skill mix of their occupation. And second, it could also refine this measurement of the moving cost without this stark assumption on the two regions, two occupations. And to conclude, let me mention one final point, which regards the policy counterfactual. And the paper concludes with this exercise of relaxing the housing supply or building more housing supply in this more high opportunity region. And I think even before talking about these policies, there would be many interesting things to discuss that come out of your model that could also highlight the main mechanisms, such as what are the inefficiencies in the baseline model? So what allocation would the planner choose? And there are many interesting channels here. One is that movers have an effect on rents, and these rents here are paid to an absentee landlord. So these increasing rents are really sort of a resource cost to the economy unless you bring the landlords back. And there is also an interesting feedback channel on wages in the sense that as workers get reallocated, they have general equilibrium feedback on wages in the two regions, and that is going to interact tightening or relaxing the borrowing constraints for workers that have different marginal utilities. So I think that would be very interesting to understand better, potentially also breaking down some of your results, not just by age, but also by the asset class, by the ability class. And that is ultimately because this is a location choice, not this location choice is an investment under risk. So here is a suggestion to me of an alternative counterfactual that I think would highlight really the key mechanism in your model on top of this other policy. But what if we simply allow individuals to borrow in this model? What would happen then? And let me conclude, since I'm out of time. This is a very interesting paper revisiting this classic question in the literature and explaining that mobility can be low without large moving costs because of a combination of region-specific skill accumulation and borrowing constraints and equilibrium rents. Thank you.
Yeah.
Sorry, do you want to set the mic or?
Yeah.
Oh. Peter Ganong, Chicago. The most novel part, I think, as Marta said, I think is that human capital locks in the old. I think the rents in the young are better understood from prior work. And there's a nice testable prediction that I think you have in the current IAB data that you're using, which is basically you can look at place effects by age for movers. And basically your model predicts that the biggest wage declines should be when people move from region A to B or B to A when they're old. And that's like an age specific prediction. So I think that's like a neat prediction in your model that you could test.
Thanks for a great paper and a great discussion as well. I have kind of a layman's question, which is, given the importance of rents for the mechanism, especially for the young not being able to move to cities, so I'm wondering if there's some cross-regional variation you could exploit. Thinking of the U.S. context, if the closest city to me is Chicago, perhaps the rents there are less prohibitive for me moving compared to if the closest city to me is Boston. Maybe there's already some evidence in the literature that you could point me toward, if not in your own work.
Brenda Mittal, UNC Chapel Hill. So I was wondering about the skill accumulation in different regions. How do you think about, say, international moves, like people from outside the country coming in, settling up, driving up the rents, driving up the wages? Maybe it's part of your internal labor, like the story of the internal market moves, but still I think it's a different channel than internal moves.
One comment, which is maybe I missed something, but if you start having N regions, et cetera, do you need these N specific human capital skills then, regional specific skills? Now you have two. Two, we don't feel so bad about. We're happy setting people to have two human capital characteristics. Once you start having, 55, how happy would you be? And then maybe, I don't remember if you mentioned this, but for the rent part, I think a large part of it is probably living with your parents when you're born in the region, as opposed to not. I'm saying this from the point of view of somebody who has a college daughter who will be living rent-free next year.
Yeah.
Hi, Fabian Kindermann. I wondered a bit about, so you're only using West German citizens, but reunification, when people are born in this, West German workers, right? So reunification was a big shock. And you had all those people migrating to Western German cities. And I wondered a bit, so when you're taking prices in the 90s, especially in the rental market, there was a lot of stuff going on. To which degree this actually influences what you see in terms of sort of real wages?
All right, so let's go pace by pace, question by question. So first of all, thanks for the great questions, also the great discussion. Thank you very much. So the first one was the effect by of move. Should I see more effects depending on where people move? So I mean, what my model would say is that the people that move are precisely the ones that are the closest to the threshold by and large. So the one that, even though on average people accumulate the skills that are needed in their local labor market, that is not the same with everybody. And the people that move disproportionately have the wrong skills, if you like. Oh, so it's from a GE's perspective not entirely clear whether I should see that, but this is something we can explore more for sure. And then yeah, so exploiting cross-region variation, the range, this is a great idea. I haven't really done that yet, but I think about it. This is a great idea. International moves, yes, I'm looking at this as a closed economy, and you're right. This could very much have an effect. I just don't have it at the moment, and yeah, this could be important, especially if we think about, well, we just heard that there was influx from East Germany. Also, if we think about Germany today, if you're going to rewrite this paper in 30 years, there's been some recent influx of international workforce, so that would definitely have a bearing on results. But at the moment, I don't have them. So, do I need as many skills as I need regions? I don't think I do, because at the end of the day, it just matters that I cannot fully take all of my skills with me. So I think it depends on, I could think of different ways of aggregating a limited number of skills in such a way that it still locks people in, even without having as many skills as regions, I think. But I have to think about this more. And of course, it's having 50 regions in this kind of model will be a computational challenge. But yes, it's always good to think about this. Oh yeah, the rent-free college. Like I say, yeah, this is actually true. So especially for my policy counterfactual, also the compensate differentials, what that I'm calculating there, really. So currently, I'm telling you, okay, it's actually in a way the people in the rich areas are also are not as well off as you might think, because they have to pay the higher rents. Of course, this story changes immediately if you think maybe there are parents who can give people somewhere to live, or even people where people might have better connections that allow them to rent houses out more cheaply where they're born. In that case, of course, you have you could even think of the higher rents as sort of the city wall around the city that keep out the peasants from the poor area, if you like. And then you have scope for all kinds of public economy questions that could also be really interesting. But at the moment, this is something I completely abstract from. But yeah, definitely very interesting. And reunification, yeah, I think so. You're right. So I'm basically comparing some of the prices that I have in the model, or calibrating things so I can get the prices right. Of course, you're right that in that particular era, it's true that there was this influx from East Germany, that this might even have changed prices. The thing is, it's just really, really hard to get regional data from before 1995. I could use later regional data, but then I'm sort of at the end of the life cycle and have a steady state model, so I have to make a choice somewhere. But you're right that this influx of East German workers in West Germany definitely can have a bearing on the prices. So yeah, this is true. Thank you very much.
We're going to meet back at 1:15 sharp, and Jonathan is going to tell you where lunch is.
I think it's good. I think I read and
Try to put on my slide. Yeah, it's okay. Just to make sure it works.
See you again.
Good to see you. Or not. It happens.
Hey, your last run.
I stopped like a week and a half ago. Okay.
You want to take a look at the slides or?
Trust
Have a question.
this morning.
Okay.
Can I send you the slides too? Can I send you the slides?
Do you have your computer? I think that'd be much easier, but you can definitely do that now.
I think I don't have, I have a computer, yeah, but.
A dongle, right? You want the USB?
Yeah, bro, can you email it?
Yeah, you can email it to me.
Do you have like a icon in the air syllab or?
Oh no, you can just email it to me. Yeah.
What drives some using in a sense. So you don't just have to be kind of close for them to be reason probability for things to be larger, for sure. I suspect I haven't actually looked at it.
Yeah. Thank you. No problem.
Yeah. I mean, I do need to calibrate this scale, so I need this scale to get the level of probability. Was there always a turn response where you can increase?
Mhm.
This.
Yeah.
So this is the way I calibrate this at the moment, but yeah, I think this is one thing that we wanted to somehow, it's hard to get some availability checks on things like this is right, because I think this is what you essentially why.
Thank you so much.
Hi.
We already really tall, that's good. I'm done to you. I'm staying up and reach his eyes. Really good. Gotta say, us, yeah. Top right hand side.
This is the last picture.
People go to this.
It wasn't, no, I just, I think I was there.
But even some shadows. This is fair. That's not a post. I wish you couldn't have.
Yeah, and, you know, yeah. It's like
Absolutely.
Alright, guys, let's go.
Okay, just one little announcement. We do have room for 3 more people at dinner. And I know that some of you had just talked to me about it. And of course, I promptly forgot who you were. So, if you can just remind me, that would be great. Just come up to me in the break and then I'll send you up, okay? In that order, hopefully.
Right. Okay, so now we're gonna have Alessandra, who's gonna talk about inequality.
Okay, great. Thanks a lot, Raquel and Jonathan, for putting this paper on the program. Just joint work with Gideon, who's sitting over there. So any complaints to him. So what we're after in this paper is whether there are distributional consequences of product market power. So we know from a by now very large and successful literature that if firms have market power, then that may have negative consequences for aggregate output, for efficiency, and so on and so forth. And in this paper, we want to think about whether product market power may affect high income versus low income people differentially. And as the title kind of hints at with the capital Q, in particular, we're going to be focusing on quality here. Why is that sort of ex ante something interesting to look at? Well, if you think about the budget, about the consumption portfolio of richer versus poorer households, then yes, rich people consume more stuff, but that's predominantly driven by higher quality of the goods and services they consume. And that's true pretty much for all components of consumptions. For sure, that's true for durables. Yes, you may have kind of more cars, but also you're going to switch from driving the kind of Toyota Camry in grad school to a Lexus when you're an assistant professor. That's true for a lot of non-durables. Maybe we drink more wine as we get richer, but for sure we're going to drink better wine. And that's true in services, which is sort of the classic example that's often offered in IO. I may come to Boston on like a first class ticket rather than flying economy. So what we're going to do in this paper is think about how firms choose their portfolio of products. So how does Toyota choose kind of how to design the Camry versus the Lexus in the presence of product market power and income inequality? And then we're going to ask whether competition across firms, so do kind of Delta and United both fly from New York to Boston, affect the low and the high income segment differentially? What we're going to do is mainly theoretical. So we're going to write down a macro model of imperfect competition, where the key new element is that we're going to have endogenous product designs. So the model will feature a finite number of heterogeneous firms. That's where the imperfect competition comes from. Households differ exogenously in their income. Now, firms, instead of just choosing the price of the widget they produce, they're going to choose an entire portfolio of products, which means a set of quality price pair for each of however many goods they choose to offer. And then, so this model is going to give rise to 2 sources of competition, your classic sort of what we're going to call external competition, where I'm going to use kind of Apple versus Samsung in a lot of the talk. So Apple, competes with the iPhone against Samsung, but there is also potentially going to be what we call internal competition. So Apple has to worry about us paying for the newest Pro Max 17.5 rather than kind of going for the entry-level iPhone. Our headline result is that low external competition across firms disproportionately hurts low-income consumers. And I'll get into the details of why. But in a nutshell, what happens is that it's particularly the firms with high market power that are going to distort their low-end products, make them artificially, unappealing, and predominantly cater to high-income households. Now, this kind of mechanism is there sort of in a lot of IO kind of micro theory. And so we're going to take this to GE and show you that in general equilibrium, through the adjustment of sort of aggregate prices, high-income consumers may actually, on net, benefit from lower external competition. So they may be better off if firms don't face as much external competition. And then we're not going to kind of leave it to just a theory. We'll have a little bit of an empirical validation that I'll talk about through in the talk. And then we go to the full quantitative model. And our two headline findings there, we're going to quantify the economy to the US today or in 2022. And I'll show you that the presence of market power reduces welfare of low-income consumers by more than 7%, whereas it actually increases the welfare of high-income consumers by 2%. So we find kind of a strong role for this GE channel. And then we're going to do an exercise looking back in time. So since the 1990s, the rise in market power that we've seen has disproportionately hurt low-income consumers. Maybe everyone's better off, maybe not. We're not going to take a stand on that. But relatively speaking, low-income households are 2% worse off. Okay. Since this is a short talk, I'm going to jump straight into the model and kind of show you our setup and where the results are coming from. Okay, so we're going to work with a continuum of households indexed by I. And here for simplicity, labor supply is purely inelastic. We all have kind of one unit of labor. And households can be of two types, high income or low income. For the rest of the talk, we're going to have two types. Nothing that I really do kind of depends on that. You could have a distribution. So the I from 0 to 1/2 is going to be the low income types. What does it mean in this model? You have low labor endowment, 1 minus alpha. And you also receive a share 1 minus alpha of aggregate profits. The remainder, the 1 plus alpha share, is going to go to high income households. So alpha here really measures the degree of inequality in the economy. We deliberately make it symmetric in terms of labor and capital income. There's some interesting work thinking about markups in the presence of a more realistic firm ownership. But we specifically want to focus just on the product market. And so we make them equally indebted. I would like to focus on consumption inequality. So we're going to have a continuum of sector, and each sector, consumption is discrete choice. So basically in each sector, say phones, I'm going to choose a single good from a single firm. So I can buy either from Apple or I can buy from Samsung, and then within Apple or Samsung, there may be different models. So here's kind of preferences, or what I'm also going to refer to as aggregate consumption of each type. So households are just going to maximize utility, which is just Cobb-Douglas across all the sectors. And then in each sector, what's my consumption or utility augmented consumption, if you will? Households get utility from 3 sources. First, they like the quality of the phone. So the number of cameras and so on and so forth. This here is going to be something that is chosen by firms. How good is the phone? Then there is here a brand value shifter, which notice does not depend kind of on the specific product K I chose. So this captures the fact that if I buy any iPhone, I get access to the iOS operating system, I can use iMessage and so on and so forth, and that may come at a particular preference shifter. And then we may have idiosyncratic tastes towards a specific good. So some people just really don't want an iPhone, really don't want to buy Apple, and so they may have a particular high epsilon for Samsung. Now we're going to make all these choices of goods and firms subject to a standard budget constraint that just says total expenditure equals total income, which is labor plus profit. The only reason I even put it up there is to clarify notation. So we're going to use P as the price of the iPhone Max Pro rather than the price of a unit of iPhone, which I don't even really know then how to compare. So that's the total payment of the phone.
So the brand value doesn't have an I. It's just it's true for all individuals.
Exactly. So we kind of separate the preferences. Exactly. Exactly. Yeah. Absolutely. Yeah. Now, at its core, this is sort of a infinite dimensional collection of all these single choice of all these discrete choice problems. But because we have a continuum and we assume that these epsilons are IID, we can nicely kind of summarize everything that's going on in the rest of the economy through one aggregate state variable per household. So basically, you can show that what happens in each sector is the household buys the product firm combination that maximizes its consumer surplus. What's consumer surplus? Well, there's sort of a common component and then the idiosyncratic taste. The common component, we're sometimes going to refer to as V. That depends on kind of three things. It depends on how good is the phone I'm considering. We all value that using log quality. That depends on this common brand shifter, hence it's the common part of this. And then I don't like paying a lot for this phone, so it depends negatively on prices. How do I trade off prices versus quality? Well, that's going to depend on the Lagrange multiplier, my budget constraint, which here we're just going to call P, which is the sort of aggregate or the marginal price index for consumer I. It measures in equilibrium, how much does it cost me to get one more unit of utility. Okay. So that's also how endogenously high and low income consumers may make different choices because their Lagrange multipliers may be different in equilibrium. Okay. And
Sigma is what?
Sigma is there you go, the Gumbel, it's going to be the parameter of the epsilon of the taste chocks. So the higher is sigma, the more kind of dispersed these taste chocks are, and vice versa. We're going to make the standard assumption that these epsilon ij's follow a Gumbel distribution. So that gives rise to nice, clean, closed form expression that just says the probability that a household I buys from firm J is given by this expression here, which is just saying, which just depends on its common surplus relative to everybody else's common surplus in that industry. Given the IID assumptions here, this isn't just the probability that the household buys from firm J, but it also becomes the firm's market share in that consumer segment. So the way to influence or increase your market share is through offering kind of a higher surplus, and then, excuse me, we have the epsilon ij's in there. Okay, so that's the household block. Now, what do the firms do? We're going to work with a finite number of firms, a la Atkinson-Bernstein, and these firms are differ in their brand value eta. So Apple has a very good operating system, Samsung less so, and this is exogenous. And on how is quality actually produced? How do we make phone? Here we're going to assume the simplest possible thing, which is an identical linear cost of producing quality, denoted kappa. If you're used to thinking about differences are in costs and you don't like this quality thing, this is isomorphic to a setup in which firms have different marginal costs. We just thought the quality setup was a little bit more straightforward or intuitive, but you can switch that one for one. So what does a firm do? It's going to choose a portfolio of products, meaning types of phones with different levels of Q, and prices to maximize profit. Given the way we set up the problem, it's optimal to only offer two goods. These taste shocks are additive. So I'm going to offer as many goods as there are types of income in the population. So here in the two type example, a good offered for the high types and one for the low type. And I'm going to do this to maximize profit. What are profits? So profits are just revenues minus costs. So I have a market share among the low income people times how much the entry-level phone costs minus its production costs, plus a market share among rich people times production price of the high-level iPhone minus the production cost. Subject to two constraints. The first one is the standard one in these discrete choice setups, where I know that my market share, so how many high low income types buy from me, depends on the common surplus, which I can influence in two ways. I can influence it by offering a higher quality of the good or a lower price. Notice the A to J is the firm heterogeneity here just acts as a shifter. So for the same price and like physical quality, more people will buy from Apple than from Samsung. Okay. And that's true for both. And then secondly, what we assume throughout is that you cannot observe a customer's type when they come into your shop. So if you have 2 iPhones on offer, everybody is allowed to buy these 2 iPhones. So what that means for the firm problem is you have an incentive compatibility constraint where you also need to make sure that the, say, high income type prefers the high-end iPhone at that cost rather than buying the entry level and potentially paying a lower price. Notice here that the firm specific taste shifters, they cancel out because they're the same across the 2 phones. Okay. Great. So that's the firm. I told you the household problem and the firm problem. We're going to think about a standard equilibrium. The only thing I want to flag on this slide is that we're going to think about, for the theory, a symmetric equilibrium, meaning all sectors are the same. Excuse me, that's not important for anything we do. And obviously in the quantitative section, we'll relapse that. It just helps not carry around like sector notation. Otherwise, everything is standard. We're solving for firm level prices, qualities, and market shares, as well as these 2 kind of marginal price indices, which are our aggregate prices that are going to clear the labor market so that everybody optimizes. Okay. Now, before I go into analyzing this full economy, I want to talk briefly about what the perfectly competitive allocation would be in this environment, since that's going to be our benchmark relative to which we're going to analyze the non-perfectly competitive allocation. How can we do that in this setting? Well, remember, we have this finite set of firms N, but now suppose for each possible firm or variety J, there is many potential producers. So everybody can come in and produce an iPhone if they want to, and there's completely free entry at 0 cost. So that would mimic perfect competition in this particular setup. Now, once we do that, the solution is very straightforward and sort of micro one-on-one. The equilibrium quality is just going to equate marginal utility and marginal cost. We have perfect competition. With our simple formulation of log utility, that just means the quality of each good is just going to use a constant proportion of the resources scaled by kappa, the marginal cost. But of course, importantly, there's this I subscript here. So in this perfectly competitive environment, low-income households do consume lower quality goods across the board because they just have less resources to spend. Okay? So we produce a high quality and a low quality iPhone endogenously because of budget constraints. Then how big is Apple relative to Samsung? Well, given now that everybody produces the same quality, the market shares are going to depend only on brand value. So Apple in this perfectly competitive allocation, or whoever of the many potential producers makes the iPhone, is going to have a market share proportional to its quality shifter relative to everybody else's. And notice that these are identical across the 2 consumer segments. Okay. In this environment, consumption inequality is equal to income inequality. And that's why we thought the kind of perfectly competitive allocation is a clean benchmark. What do we define as consumption inequality? Simply the difference of this aggregate consumption thing that I described in the beginning, which has all the tastes and everything else floating in it as well. Of course, you can also think of this as the solution to the social planner's problem for a particular set of Pareto weights. Those 2 are identical, but since we don't want to have to necessarily take a stand on these weights, this is the way we're going to do this. Okay, so now the name of the game is, let's think about what consumption inequality is and the level of consumption relative to this perfectly competitive allocation. And I'm going to do that in 2 steps. I'm going to start with an island economy in which the rich and the poor literally live on different islands, think Manhattan and Brooklyn, and cannot buy anything from the other island. And that's going to help me isolate just this sort of maybe slightly strange seeming demand or utility functions that I've set up, so we can isolate the role of this. What does imperfect competition do there versus then opening up to kind of potential cannibalization. Okay. So now we have high-income people living on one island, low-income people living on a different island. And because production costs are linear, the profit maximization problems are literally separable. So it's as if you're solving 2 completely separate economies. What does the allocation look like? First of all, despite the fact that now we are back in a world where a firm is, a variety is owned by one particular firm that has a monopoly on it, product design is actually identical to the first best. So just as was the case in the perfectly competitive allocation, I'm going to choose a quality level that is just proportional to the endowment. And completely notice there's no J subscript here anymore. Why is that? If you don't have to worry about cannibalization within the firm, you may as well maximize consumer surplus by picking the best possible iPhone from the perspective of the consumer, and then try to use prices to extract as much of that as possible. This isn't quite perfect price discrimination, even with the separable types, because we have the unobserved idiosyncratic taste shocks, but these are going to matter only for the prices. Okay? So product design is identical to first best, and there is a type-specific markup. So what do prices look like here? Firms are going to charge marginal cost, kappa QIJ, that's how much it costs to make the product, times a markup. And the markup has two components. The first is the usual sigma over sigma minus 1 that depends on the dispersion of the shocks. And then the second one is a term that depends on the market share of the firm. Now, of course, this is not fully solved out because the market shares depend on prices, but what you can easily show is that high brand value firms, the Apples here, are the ones that charge a higher markup. That's basically the exact same economics and intuition as Atkins and Bernstein. Okay? What do the prices do? It's in a discrete setup here, but it's relatively similar intuition. So if you choose a price, you trade off the number of customers that come and buy for you against profits per sale. If I charge more, everybody who buys from me pays more for the phone, but I lose market share. Now, the bigger I am, the less of an upside there is to lowering my price. Already most people buy from me, so the marginal number of customers I get from lowering my price doesn't go up by that much. So that's why then, as a response, these higher quality firms will be charging higher markups. Okay, so far this is basically replicating, well, in terms of the pricing formulas, this is replicating Atkins and Bernstein, but notice that despite the fact that we have these like kind of markups floating around, quality is the same as in the first best because these goods are not divisible. Okay, so what happens to aggregates here? So remember, the qualities offered by the firm are completely undistorted, yet across firms, yet larger firms charge higher prices. That directly implies that there's too few consumers at these high quality firms, right? So Apple in this model, just like would be kind of the case in some other models that have been proposed in this literature, have too few consumers. This gives rise to misallocation across firms. Apple is too small, Samsung is too big, and the level of consumption is lower than I should read competitive allocation, sorry, lower than in the competitive allocation. However, that source of misallocation is identical in the two consumer segments. And this is sort of the key takeaway of the island economy, which is that even though consumption is lower across the board because we're misallocating across consumers, consumption inequality is identical to the perfectly competitive allocation. And just equal to income inequality. What that also trivially means is that consumption inequality is completely orthogonal to market power, right? I can play around with the ADAs and hence the market shares as much as I want. Consumption inequality is not going to budge. So before I move to the full allocation where everybody gets to move around islands, to kind of preview a little bit where the results are coming from, let me think about starting from this allocation. I now build a bridge between the two islands. Would anybody want to go buy on the other island and who? Okay. And here we can show that basically starting from the island economy, the low-income households want to stay on their island. They never want to go shop where the rich people shop. High-income households may want to go to the low-income households, but only for sufficiently high market power firms. Okay? So typically we're used to, in these models, the downward localized C's always binding. Here that's not the case because you may get enough consumer surplus from your current allocation to not want to move. So what's the intuition here? There's positive markups. So if I was allowed to buy 70% of an iPhone at the same unit price, at 70% of the cost, I would love to do that. But you can't do that. You can't buy 70% of an iPhone. So the only thing you can do is switch to the other model. But that means low-income people definitely don't want more. So they're never going to want to upgrade. When do high-income people want to move down? What do they save? They basically save the markup. Now, suppose for a second, like, why was this not an issue in a perfectly competitive allocation? Because I'm just being priced, given a price equal to marginal cost. So then for sure, I want the good that maximizes my consumer surplus, which is by definition the one that was given to me. But now if they charge me a 50% markup, by downgrading, I actually save a lot of money. And so I may want to kind of purchase the lower quality version, still get access to the operating system without sort of paying this astronomous markup. As a brief aside, one thing that I think is very nice about this model is that it's one in which the level of the markup matters even without labor supply considerations. Typically in these models, whether all firms charge 10 or 100% is completely irrelevant. It's just about the relatives. Here, if we are in a world where markups are low and competition is high, then I could end my presentation here because the island allocation is the market allocation and we're done. Yet, the higher are the markups, the more likely we are going to be in a case where that's binding. Okay. All right. So let me show you kind of what happens now as we integrate the market. So in terms of notation, I'm going to use mu as the markup that would have prevailed in the island economy and psi as the Lagrange multiplier on the high income IC, which is the one that is typically going to find. So the firm has in principle 4 margins it can play with, the 2 qualities and the 2 prices. It's going to do 2 things. It's going to do 3 things actually. So it's not going to play around at all with the quality offered to the high type, which is kind of reminiscent of the no distortion at the top result, even though in general equilibrium, there's still going to be an effect through the aggregate pricing. In order to make the good more attractive to high types, it's going to reduce the price. You can see that here. This was the markup charged in the island economy, and we're going to charge something lower than that. How much lower? That depends on the Lagrange model. On the low income side, it's going to do 2 things. It's going to offer a worse quality at a higher price. The worst quality is, again, kind of typical in these models. In equilibrium, high income households value quality relative to money more, so that gives you separation. Why also increase the price? Well, previously, you were setting the price to exactly just trade off customers versus revenues. Now you have an additional margin or an additional reason for a high price, which is it helps with the IC. Now, the rich get the same thing at a lower price. So there's going to be a higher market share for Apple. The poor get something worse at a higher price. There's going to be a lower market share for Apple. And that's going to be driving sort of the consumption inequality in these models. So high market power firms offer lower quality for the poor. And then in general equilibrium, they have to offer higher quality for the rich because workers have to go somewhere. So those PHs and PLs are going to just declare the labor market. And in fact, the iPhone will be even better at the top than it was before this market integration. Market share for the poor among the Apples of the world is going to be lower. Now, remember, we're starting from an Atkinson-Bernstein equilibrium where the market share was already too low. So that's more misallocation. Increase for the rich, less misallocation. So what we show in the paper is that low competition increases consumption inequality through both of these channels. And we do this kind of in 2 ways of playing around with like, what does competition even mean? In particular, we show if there's fewer numbers of firms in the market, consumption inequality goes up. And if there's more dispersion in brand value, so you get some superstar firms, inequality also goes up. So that's the kind of two things we can show in the paper. How am I doing on time? But like 8 minutes. 8 minutes. Okay. So the paper has 2 key predictions, which is first that the high market power firms artificially downward distort the quality of low-end products. That's extremely hard to kind of show in a very broad sense, like who are we to say that the iPhone should be better versus not? So what we do in the paper is go through sort of a range of historical and contemporary case studies and show that these kinds of things that have been documented by, say, IO people tend to happen in very concentrated industries. One thing that we can directly test is that more concentrated markets also have a higher distortion in market shares. Remember, in the island economy, Apple's market share among the rich and the poor is identical. In the full model, we know that in more concentrated markets, the top firms are going to concentrate on the rich, sell more to rich versus the poor. We're going to look at this in the Nielsen data, not because I wanted to write a paper about diapers, but because this is the only data source that allows us to see by income who buys from which firm. Okay, so just as in the model, we'll cut median households by median income, and we'll look at kind of product categories within Nielsen as a market, and we're going to ask, is the relative market share, so how important am I for the rich versus the poor, of a market's top firm higher in more concentrated markets? Okay, it's a lot to swallow, but that's the testable prediction, and we do find that it is indeed true in the data. So in industries that have a higher HHI, the top firm concentrates more on the rich relative to the poor. That's true no matter whether you run it kind of on its own market share, on the HHI, or whether or not the firm has an HHI above the median. Okay, so it does seem to be true in the data that in more concentrated industries, we get this tilt in market shares where the poor consumers are kind of being kind of sold less or lower quality. So now what I want to do in my last kind of 6 minutes is think about quantitatively, does this mechanism matter or not? And in order to do that, we're going to calibrate the model to the US in 2022. Now, we had homogeneous sectors in the theory. Of course, we don't want that for the quantification. In particular, we're going to allow for heterogeneous sectors that each are weighted so that the consumption basket is representative of the US. And we're going to calibrate them to 6-digit NAICS industries. So to give you a sense, that gives us about 900 industries. There's 2 aggregate parameters that we're going to pick. One of them, sigma equals 3 from the literature. So that's the dispersion of the Gumbel shock. And then we're going to pick income inequality to match the expenditure inequality observed in the PSID. And then for each industry, we got to calibrate the number of firms, and we're going to allow for a different Pareto shape for these brand values to match for each industry the number of firms as well as the share of sales accounted for by the top 4 firms. These moments we're getting from the census in 2022. We do top 4 and not HHI because that data is just available for much more industries and much more kind of time periods, but we redid it for the HHI in the appendix, and things look kind of broadly similar. Okay. Now, that's the headline numbers that come out of this calibration. So relative to the perfectly competitive allocation under this parameterization, we find that high-income households gain about 2% from the lack of competition, whereas low-income households lose about 7%. So consumption inequality is amplified by about 9 log points here relative to pure income inequality you would read off. Now, in principle, this could be coming from the 2 margins. This could be coming from the pure quality distortion that low-income people get worse stuff, high-income people get better stuff, or from the misallocation margin. It turns out quantitatively, most of it is coming from the quality margin. If it was only the quality distortion, but market shares stayed kind of at their perfectly competitive levels, high-income people would be even better off. So you get none of this misallocation. Low-income people will be worse off, but not as much. Okay. So as a reminder, here's basically how the model works. I'm plotting here in the calibration the quality relative to the perfectly competitive allocation for the island economy where everything was first best, the high-income consumers and the low-income. So the quality distortion is constant for the high-income. We never do sort of any mechanism design fidgeting there. Whereas for the low income, the bigger or the bigger the firm, the less external competition it has, the more it's going to distort relative to the first best. The kind of most of the mass sits kind of here, which is how we get to the 2.5%. The remainder is the misallocation margin, where I kind of want to just make 2 points. First, the misallocation margin on its own is bad for everyone. Everybody has, everybody buys now from the wrong firms. Quantitatively, it's not huge, but it is also bigger for the low-income households. And this is kind of illustrated here. So What I'm showing you here is the distortion in market share relative to the first best. So upwards means too big, downwards means too small relative to a normalized market share. The island economy has your standard Atkinson Bernstein. These firms are too small, these firms are too big. Other way around, too big, too small. And in the market allocation now, things worsen for the high income customers and get better for the worsen for the low income, get better for the high income. And so that's how you get this distortion there. All right, so the last thing now I want to do is think about recalibrating those, the Pareto shape of the quality distribution to match the top 4 shares back in 1992. To give you a sense of magnitudes, in 2022, we calibrated a top 4 share of about median top 4 share of about 31%. That was only 25% back in the 1990s. What I want to do here is focus on misallocation / quality distortion relative to the perfectly competitive allocation. So we're not going to take a stand on whether technology improved and everybody's better off. Like that is orthogonal to our mechanism. That could just be going on as well. It's just relative to the plan. So if you'd taken a standard model without this internal competition effect, which is kind of like what our island economy does, you would have concluded that consumers throughout the board are 1% worse off in 2022 than they were in 1992, right? So we lost kind of 4% relative to 0.4%. Now we're losing 1.4% relative to the plan. But that masks like a lot of heterogeneity. In the full-blown allocation, the rich are actually only 0.3% worse off if you compare kind of the 1.6 here and the 1.9, whereas the low-income people, the poor, lose 2.4%. And that's sort of the similar mechanism as before. Firms become more concentrated. That disproportionately hurts the poor. All right, so what does this paper do? We develop a macro model where firms endogenously choose product portfolios. We find a rich impact on consumption through both product design and prices. And this tells us that product market power has distributional consequences in which, in fact, low-income consumers are hurt a lot. High-income consumers may be hurt, but in fact, in a quantitative, end up benefiting from low competition across. As well.
Karina is gonna discuss.
Okay, so thank you for giving me an opportunity to discuss this paper. I enjoyed reading it and learned the reading. Okay, so the contribution of the paper is very clear. Much of the literature that studies market power thinks about how firms use market power in order to affect prices, and then these prices impact how many goods consumers choose to buy or what basket of goods consumers choose to buy. And through this channel, previous studies have highlighted how market power affects welfare and potentially amplifies the extent of inequality. Okay, so what this paper does is it brings an additional novel channel into this story. The authors point out that in addition to setting prices, firms also can design the menu of products. And if the firms are faced with heterogeneous consumers, they may want to design different products for different types of consumers. And if they have market power, they may want to distort the quality of the product for different consumers differently. And this creates potential an additional channel through which market power may have an effect on welfare and quality adjusted consumption or inequality measured in terms of utility. So the contribution of this paper is to formalize this channel and think about the quantitative implications. Okay, so Alessandra did a wonderful job summing up all the details, so I'm not even gonna put the formulas in the summary. I'll just do a very simple bullet point summary of the paper. Right, so there are 3 components to it. There is a theoretical, quantitative, and empirical analysis. Right, so on the theory side, the paper develops a tractable general equilibrium model with oligopolistic firms who face heterogeneous consumers, and they think about how to design the menu of products differing by their quality. Okay, so they want to design
different products for different consumers, so they have to satisfy incentive compatibility. And one of the key predictions that comes out from this model is that the firms that have larger market power, they choose to distort the quality of the good that they sell to low-income consumer in order to prevent the high-income consumer from buying the quality goods, so they can get a high markup on this high-income consumer. Okay, so that is the mechanism how the income inequality translates into an even bigger consumption inequality with capital Q that is highlighted. Okay, so what gains attractability in this model is a number of rather standard simplifying assumptions. So consumers make discrete choice, goods are indivisible, and taste shocks are drawn from the Gamble distribution, which allows to characterize the model in terms of the logic demand system and provide some analytical characterization. Okay, so then through the prism of the model of this theory, they take it to the data, calibrate it, and do quantitative analysis, analyzing what is the extent of this amplification of the channel that they describe on consumption inequality among consumers, and how the consumption inequality changes if the market power gets more or less concentrated. Okay, and finally, there is a last piece of empirical data, which is a little bit separately standing, that documents that the model has some predictions that are consistent with the data. Okay, so I will try to make comments about each of them. Time for me. So when you think about the theory, and I'm going to twist it a little bit differently from how Alessandra presented it, to me, it was very convenient to think about it as an extension, very clever extension of Musa-Rosen paper, and the extension is endogenizing the customer base. Okay, so the left column shows the classic formulation of a Musa-Rosen, I think it is 1978 JET paper, which highlights this screening mechanism. Right, so the firm is a monopolist. There are no competitors. And this monopolistic firm chooses prices and quantities to maximize the profit that it extracts from the two groups of consumers. It needs to satisfy the incentive compatibility constraint because it cannot force consumers to buy certain type of goods. Right? What comes out from this, the key feature here is that the total customer base is fixed. It's a monopolist, consumers have nowhere to go. The key feature that comes out of this analysis that is very well known is that the firm has incentives to distort the quality of the good that it sells to low-income consumers in order to prevent the high-income consumers from deviating and buying this good. Right? So this is what we know. Now, what this paper brings into this environment is it puts it into a general equilibrium environment by allowing firms to compete as other firms. So rather than keeping the customer base fixed, it allows the customer base to vary, not only on the quality of the good and the price of the good, but also on what the other firms are doing. And that is where the true innovation is. And if you think about it, it creates a trade-off that is not a very obvious trade. Right? So in Musa-Rosen environment, the firm wants to degrade the quality of the good that it sells to the low-income consumers. If you allow low-income consumers to potentially go somewhere else, then there appears an opposing force. Now, when the firm is thinking to degrade the quality of the good, it is concerned that the consumers will go away and it actually may lose the profits. Right? So where I think the paper could benefit, maybe expositionally primarily, is to highlight this trade-off a little bit more, think more about, and maybe discuss more about how different features of the environment impact the different sides of this trade-off, and in particular, how both sides of this trade-off are impacted by the size of the firm or market share of the firm. Because ultimately, your key results are about this comparative study, but firms with bigger market shares tend to screen more and downgrade the quality more. And it's not obvious how different sides of this trade-off are impacted by the firm market size, and let me kind of very briefly highlight why that is not clear upfront. Right, so if you're thinking about the decision of the firm to reduce the quality of the good that it sells to low-income consumers, it takes three things into account. Two of them are the standard Musa-Rosen logic, and the third one is the novel feature of this paper. So first, it benefits by extracting more profit from the low-income consumers because the quality of their goods is low. Second, it benefits by steering more high-income consumers away from the low-quality good because the high-income consumers are the ones where they get high. Third, lower income lowering the quality of the good that is sold to low-income consumers can reduce the customer base among that type of consumers. And that is where this creates a potential negative effect for the firm and something that creates a force acting in the opposite direction. Okay, now let's think about how the size of the firm affects the size of this trading. The higher is the firm, the bigger is this. The bigger is the firm, the bigger is the markup, the bigger is this term. So the higher is the market power of the firm, the more it has incentives to do the screening that is highlighted in the letter of the game. This last term is actually not very obvious. Right? So given the Gumbel distribution and the implied logic demand system, you actually can find the derivative of this term, and it's going to look something like this. Right? So it is increasing in sigma, and remember, sigma is how widely dispersed those state shocks are, and the higher is the sigma, the more competition is there in the market. And that makes perfect sense that as the higher is the sigma, the more I'm concerned about this external competition. But at the same time, this additional term is not monotone in the firm size. Right? Perhaps empirically relevant region is the one where B is less than 1/2. And in that region, because market share is usually less than 50%, and in that region, this term is actually increasing in market power, in the market size of the firm. So what it suggests is that the bigger is the size of the firm, on the one hand, the higher incentives for screening, but also in this particular environment with logic system, the higher are concerns about this external competition. So I understand that somewhere in the background, all these things are intertwined, and the first effect appears to be dominant, and the model predicts that the higher is the size of the firm, the more downgrading it was to do for low-income consumers. But I'm also wondering whether that particular prediction is built into this assumption of the logic demand. And maybe if you were to try to disentangle some of these forces, maybe the prediction could be different. So that's one direction I think would be useful to think about. And perhaps one way to try to disentangle those forces could be to think about the partially captive demand. So imagine that a part of the customer base is fixed with the firm, and only a fraction theta, or theta is fixed, and 1 minus theta can leave. Right? And then by varying this theta, you could potentially encompass everything from Rosen model to a model with a lot of competition. And this potentially could help you disentangle those forces and think about what role does the size of the firm play in the trade-off that is appearing due to the external competition. Okay, so then, how am I doing this time? Excellent. I want to shift gears a little bit and direct attention to another feature of the model, which I think at the moment is a little bit of a missed opportunity. So the inequality between the consumers is critical for everything that is happening in the model. Right? So it is because consumers are different, they have different valuations or different willingness to pay for quality, and that is what incentivizes the firm to do the screening and to downgrade the quality for the low-income consumers. Intuitively, the higher is the income inequality, the bigger is the screening motive, the bigger is the amplification for quality-adjusted consumption inequality that is driven due to the presence that appears due to the presence of firms' market power. So I think it would be very useful in your model, given that the model is tractable, to do comparative statics with respect to alpha, the extent of inequality among consumers, and think about how does the market power interacts with the inequality among consumers. Okay, and I think it's actually quite possible to derive some theoretical results in there. I'm suspecting that those two forces are going to be complementary, and that is going to be a very interesting point to make, that the market, additional inequality effects arising due to the market power are getting stronger as the underlying inequality in the economy is high. Right, and then all these points I think would be very interesting to explore within the quantitative analysis that you're currently doing. Perhaps currently we're just calibrating the model and comparing market allocation with efficient allocation, study the effect of concentration. But I think it would be very useful if within this quantitative experiment, you also thought about comparative study with respect to sigma, which is the extent of the competition. Think about the partial of the consumer attachment so that you could disentangle the market power from the screening mechanism. Think about the effects of income changes in income inequality, and I always think about what are the useful policy implications. And in that context, the effect of a distributional policy would be very interesting to study. Okay. So if I have 1 more minute, I could make a last comment about the empirical analysis. I mentioned earlier, it's a little bit separate understanding, right? So, and it does find that there is some support for models predictions in the data, but perhaps due to limitations of the data, it doesn't really go to the very heart of the mechanism that is described in the data, right? So the theory tells that market power has an impact on the dispersion of the product menu, and therefore has an impact on the customer composition or expenditure shares across different groups of consumers. The evidence that's presented in the paper currently misses this middle part and jumps to the expenditure share differences right away. But of course, there could be lots of other forces that could explain why in more concentrated markets, high-income consumers spend a bigger share of goods on a particular type of product, right? And that could be because of brand value, demographics, location of farms in particular areas, and so on and so forth. I have not worked with Nielsen data, but based on what I read about Nielsen data, you might try to construct some kind of a measure of a quality gap between the goods offered by a particular farm, right? And that could be either using the price ladder or the quality ladder. They have nutritional scores or price per ounce, right? And essentially the evidence that you would try to look for if you wanted to fill this middle gap is to show that as the market is becoming more concentrated, the quality gap between the products offered by the firm is increasing, right? So I don't know whether it's possible, but it's kind of worth looking into. Okay, so to sum up, I think the paper makes a very interesting contribution and fills the gap in the literature that is very important. What makes it attractive is that the framework is super tractable, and that makes it also very suitable for quantitative analysis. And there are several directions where I think the paper could be strengthened, clarify the trade-off that I was talking about, think more deep about the role of the firm size in shaping the different forces of this trade-off, think about the partial customer attachment, income inequality, redistributionary policy, and maybe some additional work on the empirical side. Thank you.
All right, let's yeah, if anyone has a question, can come up. Just remember to say who you are. I think that's nice to know. Go ahead.
Hi, Jeremy Pierce, New York Fed. So very cool paper and very clearly presented. I just wanted to also echo something Galina said about the inequality, is that I guess there are two dimensions. One is how far away the gaps are, but the other is I think you had half low income, half high income. I'm just thinking maybe that's like different in different markets, or maybe that's changed over time. I'm just curious how that might affect like what you're thinking about in terms of kind of the counterfactual you had was market power increasing, but I think a very natural counterfactual is also income inequality, both in terms of the shares and in terms of the, as Galina said, the gap.
Well, that was great. I think when you're doing your aggregate kind of welfare stuff, I guess were you thinking there that all farms are supplying kind of products at different levels? Because it seems like, I mean, Apple clearly does and airlines do, but there's maybe a bunch of firms that don't. And I guess the example you started with, and maybe this is coming back to one of Galina's points, was the Toyota Lexus thing. I mean, that one doesn't kind of ring true as sort of having Toyota having degraded the quality of the Toyota. It's, if anything, it sort of feels like the Toyota buyers are kind of getting a good deal, and the Lexus is just kind of the same car with a different badge and a higher price. But maybe you think that is not a natural
class in planes, and it's gotten much worse.
But I think I want to echo this. So depending on what you're looking at, I think one of the things firms also do is create exclusivity, in the sense that they actually purposefully do not serve the market for lower end products. And I think the assumption that's doing the job here for you is the Gumbel distribution stuff. So in the sense that there's always, whatever you do, there's always going to be one infinitely small group of consumers that will buy your product whatsoever, right? So the extensive margin choice of the firm is essentially ruled out through that assumption. But it would be interesting to, I think, to see what would happen if you as a firm could purposefully take out this market, because that would make your IC constraint not bind, no?
Igor Lifshitz, Philly Fed. Cool paper. I'll go crazy and ask an empirical question. When you plot concentration on the x-axis and relative share of, I understand the slope is right. I thought your intercept was wrong. Aren't you finding that the market share is actually smaller in the in the premium market than the economy market?
Larry Schmidt, UCSD. Fascinating paper. I can't help but think about how the forcing process that you're kind of throwing in is counterfactual, brand value, number of firms, things like that seem like those are endogenous choices that firms make. And I'm sure you've thought about kind of whether allowing firms to pick those kinds of things and almost invest in that technology, which way that goes. Does that make things worse, or is that something that would kind of converge?
Great presentations from both you and the discussant. My question is really, I think you were asking a little bit of this, Jonathan. You know, isn't there really an incentive for a firm to come in and just provide one? And another way of saying that, you keep on needing and think about many types of consumers or many income distributions. You really need them to be providing all the quality of the goods for each firm for this to work. And that worries me, because if one of them is providing 2 types and the other one's providing 3, I don't think that you're going to have an equilibrium of the sort that you're getting, but I could be wrong.
Okay. All right. Thank you, Galina. This was a fantastic discussion. I'll start with that. So there were a couple questions about this like extensive margin and everybody offers to everyone. So it's true, the reason everybody wants to serve everyone is because we have these demand shocks. And you just endogenously, you never get kind of full separation. The way to get it in the model, excuse me, is to introduce a fixed cost. Like the moment you have a fixed cost, you can do that. We played around a little bit with that in kind of a previous paper that we had, and it doesn't materially change the conclusions. It adds sort of an extra sort of channel potentially in there. And in terms of like, then the IC is not so problematic. Yes, but if I choose to stop serving the low types, they go from like, maybe not a great product to entirely losing access to that brand, which actually would make things worse. Then the question is, what would the planner do? But that sort of, I don't think would substantially make that made that change. And so in some sense, the fact that like Lexus tries to pretend that it's a different engine than Toyota, and to me is like evidence for this. They're like really trying not to enter this IC, but we can maybe talk about that over beer. Sorry, then the exclusivity thing. Yeah, I think I answered that already. Larry, your question on the number of firms and the brand value. So I completely agree, sort of thinking about investment in his brand value would be super interesting because it's not obvious which way it was go. There's a force, and that's present kind of conceptually in Ezra Oberfield's recent paper, where basically maybe the low-income people benefit because we do R&D and sort of that stuff. At the same time, you know, they get the worst product. So that could be sort of down the line an interesting extension. The number of firms, so here we do it through profit rebating. You could instead kind of have an endogenous entry of firms. Again, that particular thing we haven't sort of thought about yet. Of course, there exists a set of costs that rationalize this number of firms, but there's a way to do this. What am I missing? I'm not sure I followed the intercept question. Yeah.
Is the model says dominant firm has larger market share in the premium market than in economy market. The graph you showed seems to indicate that.
The graph, right? So the graph kind of goes.
But it's all negative.
No, it goes positive at some point. But it is. That is true. That is true. So there are, of course, so we're testing it kind of relative to the flat hypothesis. There are other forces in the model that give you this. But you're right. In the lower end, it's kind of negative. On the upper end, it's positive. And then I think the last question, unless I forgot something, was about the income inequality. So we were kind of hoping this would be like a separate paper because it's extremely subtle and I think very cool in a sense that like in the model with the 2 types, and that's not yet fixing Jeremy's points of the 1/2, but if you just stick to that, it's non-monotonic in a sense that if if consumers are almost identical, like who cares? We're not going to do much distortion. If there's only me and Elon Musk, then also the IC is never going to bind because Elon does not care about what I do. So it's the sort of in-between values that matter, which tells you this is kind of also a feature of the two types. So you'd want to extend it to a continuum. And then we have to think very carefully about which measure of inequality do we even want to think about? Is it like about the Gini? Is it about the top 10 share? Is it about this, about that? Which I think is super fascinating. But we were kind of, we thought this is kind of rich enough for a separate thing. And then you do get these kind of effects of like, maybe there's an extra reason to do redistributive taxation, because then it will help kind of through the work. So that experiment for sure we can do in the model as is. The full-blown kind of income, yeah, I agree, it's super interesting. I don't know if it's gonna fit into this paper. I don't know if there's something you wanted to add.
No, perfect.
Okay. Good.
So we have I think we have a break and we'll meet at 2:30.
Great job, Professor.
Thank you.
I tell you.
Yeah, you're right. I think that in the data there could be like, let's call it niche consumption or something. So you may
Yeah.
Yeah, but now Monday.
I just want to say
Yeah, no, so
yeah, you can get some guys, that's fair.
All right, everybody, we're gonna carry on. So one small thing, we noticed on the program that we got like 3 papers set in a row with no break. So I think what we're gonna do is we'll do 2 and then we'll take a short break and then we'll do the last paper. So that's just the same thing. And now we're gonna have Ariel's gonna talk about misallocation due to clinical practice.
Okay, thanks a lot, Raquel and Jonathan, for including the paper in the program. This is joined with David Bakai, who couldn't come here this week. All right, so it is well established that households do not perfectly share risk. So they do not fully insure each other across different states of nature, or they do not fully smooth their consumption over time. So we see that in the domestic data, for example, by the failure of permanent income hypothesis. We see that also in the international data, for example, violations of the Backus-Smith condition. Now, this inability to transfer resources efficiently across states and over time is a form of misallocation. Okay, so the question we want to ask in this paper is, what is the dead weight loss from this misallocation? Or put differently, how much economic waste is there because of the lack of complete financial markets? Okay. Now, as the way I stated the question, it's a little bit loose. It's a bit vague. different households are differentially affected by market incompleteness. They consume different goods. They are subject to different shocks. They have different availability of financial assets to smooth the consumption. Okay, so the question is, how can we aggregate all these distortions across heterogeneous households in a meaningful way? Now, one common approach to quantify the losses from incomplete markets is to consider a social welfare function. Okay, now it's well known that social welfare functions mix efficiency and equity regardless of Pareto weight. So in some sense, they don't do a job of measuring misallocation. For example, the behind the bill utilitarian welfare function treats inequality symmetrically with risk. However, these two have very different implications for misallocation. If I cannot smooth consumption in response to a shock, that's a form of misallocation. The fact that Elon Musk is much wealthier than I am, it's not misallocation, right? So to answer the question, to quantify the losses from incomplete markets, we're going to use a measure of distance to frontier, okay? And in particular, we're going to ask the following question. Suppose that financial markets were completed, starting with some initial equilibrium with incomplete markets, and suppose that every household could be compensated so they are as well off as in the initial equilibrium, then how much resources would be left over? And the amount of leftover resources is going to be our measure of deadweight loss or misallocation. Okay, and kind of this measure, kind of almost by construction, is going to quantify efficiency losses separately from inequality concerns. I'm going to define it carefully in a couple of minutes. So what we do in this paper is we're going to study this question both in closed economies and open economies with incomplete financial markets. We provide exact formulas and the second order approximations using sufficient statistics that are kind of useful to take to the data because you don't need to fully specify a model, like in terms of what the shocks are, what the nature of incomplete markets are, etc. Let me kind of give you a summary of the headline numbers of our quantitative findings. So across US households, we find that incomplete resharing destroys the equivalent of 20% of US consumption every date and every state. So basically, if you move to complete markets, you can make everything different with 20% less output in every period and state. When we do this, we then do this across countries, abstracting from incomplete insurance within countries. And there we find like smaller gains from completing markets. So completing markets or incomplete markets, the cost of incomplete markets is about 5% of world consumption over that period. Okay, so you can attain the same with 5% less of output every period, every year. And this is mostly driven by fast-growing countries like China and Korea. If we drop those countries, then the gains are going to be like smaller, more like 1%, right? I don't have much time to talk about the literature. This is part of a broader research agenda with David and also with João Guerreiro. I'm very happy to talk about some of this work or the literature at the end of the talk. So what I'm going to do in the rest is basically to define this measure of misallocation that we're going to use. Then I'm going to focus on the closed economy model with idiosyncratic risk and the empirical application, the open economy model with country level risk and the application, and then I'm going to conclude. All right. So let me kind of tell you how we measure misallocation from incomplete markets. All right. So this is kind of going to be a bit of an abstract definition that can be applied to basically any environment, and then I'm going to apply it to two environments, closed economy and open economy. Okay, so we're going to have households denoted by H that have some preferences that can vary across households, and the preferences are state contingent streams of consumption bundles, and CH is like a bundle of, it's like a stream of consumption of different goods, maybe including leisure across states and different periods. Okay. Yeah. So C0 is going to be the equilibrium consumption location in your model of incomplete markets, in the model of incomplete markets that you write in the initial equilibrium. Okay. And this is basically a collection of consumption streams for every age, for every household. All right. So think of this as a big matrix. Every column is a different household. Okay. Now, MathCal C is going to be the Pareto frontier. Okay, under complete markets. Okay, given some TFP scalar Z. Okay, so that's Z is going to be what we're going to shift to when we measure misallocation. I'm going to show you that in a second. Okay, so think of CZ as like every consumption allocation that can be attained given technologies, basically. So Pareto frontier, right? So the question the way we're measuring this allocation is the following: is how much we can contract TFP, the scalar Z, such that it's possible to keep everybody indifferent to the way they are in the initial equilibrium. All right. So if we can reduce Z a lot, then to attain the same, then the gains are going to be larger. Okay. So mathematically, it's this. We're going to try to find the maximum scalar Z positive, such that it's possible to find a feasible point, okay, in the contracted Pareto set, which is the set C, given TFP 1 over Z. We're going to maximize that Z. So we're going to shrink the set as much as we can, such that it's possible for everybody to be at least as well off as they are in the initial equilibrium with incomplete markets. If A is equal to 1, once you construct it, once you solve for this maxi, if you find that A is equal to 1, okay, then that means that the initial equilibrium was already Pareto efficient. Okay, so you cannot contract it and make it very indifferent. Okay, now in general, it's going to be a number bigger than 1, right? For example, what do the units mean? So if after solving this problem, you find A equal to say 1.1, that means that you can get the same. You can make everybody at least indifferent with 10% less of every factor in every state of the world and period. So it's like there's like 10% wasted in the sense with incomplete markets, because you can attain the same with 10% less under complete markets. All right, and another kind of property of this measure misallocation is that we do not need to take a stance on who gets the surplus. If there's surplus, if we can attain the same with less, we don't need to take a stance on who gets it. Okay, so in some sense, this measure is kind of silent on, or doesn't need to take a stance on redistributive concerns.
Need not to take a stance because it might destroy things if you transferred it back to the wrong union.
Yeah. The society can pick crazy points. Yeah. I mean, C is the Pareto frontier, so we're not like you will never go inside. But which point the Pareto frontier the society picks, in the hypothetical where markets were completed, we don't need to take a stance on that. In that sense, it's a measure of distance to a frontier. And the other nice property is that in contrast to say social welfare functions, to construct A, you don't need to take a stance on how you cardinalize utility, which is especially an issue if different people have different preferences, like in the international economy where different countries consume different goods. This measure only depends on the ordinal preferences of people, nothing about utility functions, how you cardinalize the preferences. All right, so now I'm going to kind of illustrate this measure in the closed economy, and then I'm going to give you some kind of sufficient statistics, and we're going to take it to the PSI data. Okay, so let's make it like very concrete now. So we're going to have CRA preferences over consumption streams. All right, with EIS of eta, the elasticity of the double substitution. Okay, and that's kind of, again, this is like overstates. The expectation is overstates, and we're summing over t, and beta is a discount factor. Some of the results we have don't depend, it's just use homotheticity of preferences, but I'm going to make it more concrete here. In a closed economy, we're going to assume that everybody has, to start, the same preferences, okay? And there's over a single aggregate consumption good, okay? So there's a single resource constraint. The sum of consumption at each point in time and state across households has to be equal to total output in that period and state, okay? Now, that output in this economy, we're going to assume that it's produced by perfectly competitive firms, okay? So there's no markups, okay? So the only distortion we're going to have is in complete markets, okay? And the model is kind of, we don't need to take a stance on like the network or it's like very, very general. There could be aggregate shocks, etc. We don't need to take a stance on that given the assumptions we made. So there's a production economy underlying that, okay? The production of this YTS. Okay, so then write your favorite model of say financial constraint, borrowing constraints, incomplete markets. That's going to give you some consumption process in the equilibrium. CH0. Again, C is not like in the first period. It's like the whole sequence at every point in time and state. That's what this vector time. So that's what you get from the initial equilibrium. Okay. Now, what's the C set? The math cal C set, the Pareto frontier, given TFPZ. Okay. It's basically, we know that in the Pareto frontier, in this model, every agent gets a fixed share of aggregate output in every date and state. Okay. That's kind of what you get with complete markets. Okay, everybody has the same preferences, even though there's aggregate shocks. Everybody needs in the efficient locations will have a constant share. Okay, and aggregate output is YTS, and we're gonna times TFPZ. That's the thing we're going to be varying. Okay, so what is A in this case? Misallocation. We're going to ask a question: by how much can we reduce Z? Okay, such that there's a point in the Pareto frontier that makes everyone indifferent to their allocation in the initial equilibrium.
Sorry, I thought you had said you didn't need anything but preference ordering, and so this seems to require homotheticity that you just mentioned.
Okay,
In
so
passing?
I'm going to use homothetic preferences, but the measure can be allows for it. Doesn't need that.
See, that's not really true. If you have,
Sure.
C
Sure.
minus
So
C
yeah,
C bar.
yeah. So for we have another paper where we dealt a lot with non-homotheticity. For this paper, I think most of the incomplete market papers, I would think have like homotheticity. We're gonna have for different preferences. We're gonna have for leisure too. But yeah, sure. We're gonna for this talk. I'm gonna assume that. Totally right. Okay. So how do we construct A? First, exactly, and then I'm going to show you this second order approximation that we're going to take to the data. Okay, I'm going to do it in 2 steps. Okay, so let's construct the allocation that solves this problem. Okay, again, I'm reducing Z as much as I can to obtain indifference for every agent under complete markets. All right, so how do we solve for A? How do we solve for that allocation? Okay, so as I said before, every point in the Pareto frontier, agents get a fixed share, omega H star, of total output contracted, right? Because we're kind of remember, we're reducing Z by 1/8. Okay, so the allocation is going to satisfy that. Every household gets a fixed share. Okay, now what's the share? We know that the share for the household H has to be such that the guy is indifferent to how he felt in the initial equilibrium. Okay, so omega H star has to satisfy this condition. It has to be indifferent. Okay, that's what omega H star has to satisfy. We still have to solve, but we still need to know what A is. This gives us omega H star given A. Okay, now this problem is equivalent, the utility function, we can write it as, we know that the sorted equivalent of the path is a representation of the same preferences, right? So this problem is equivalent to replacing the utility function with a sorted equivalent defined in the standard way of the consumption process. Okay, so now we have this, the same condition. Now we know that the sorted equivalent is homogeneous of dv1 in the consumption process, so we can pull out the omega, okay? And what do we know? That the omega sum up to 1. The shares up to 1, and that gives us the equation for A. So what is A? The exact solution for A is the Shannon equivalent of average output, that's the denominator, divided by the sum of Shannon equivalents across households. Okay? Now, this formula is very similar for those of you that know the Benabou's 2002 econometric paper. Okay? Now, this follows as a result where she defines efficiency in this way. Okay, what's intuition for this? Basically, suppose there's no average shock, so average output is fixed. Okay, then we know that, but there's idiosyncratic shocks. Then you can make everything different with a constant stream of output. Okay, so we're going to need less output than in the initial equilibrium. Okay. So that's why this ratio is 1, because we can attempt to make everything different with constant stream of consumption. Okay, and so we can get less output and make everything different. Right? Now, if I have time, I'm going to mention that I'm going to show you that adding capital and or leisure and different preferences, then this measure is going to be different to Benabou's definition. Okay, yeah.
So I followed this, but you said at the start that, I mean, maybe you're saying it loosely, that you could think of this as like at some point you kind of complete markets, and from that point on, people.
Yeah, the thought experiment is.
But here you're picking up one point in the frontier. This omega stars and one.
Yeah.
Are they the same? Is that the same?
No, the question we answer is by how much. What's a maximum contraction in the frontier such that it's possible to make everything different? Right. Okay, so for that we're solving for a point. Okay, that answers that question. Okay, that doesn't mean that if the world features complete markets, we will move there. That depends on how distributive tools, depends on a lot of other things. But to answer this question, we don't need to. This point is not. It's not the socially optimal point. It's the point that you need to solve. To compute, to answer this question.
It's not necessary. If you suddenly said,
no,
we're going to open a complete set of state continuing tomorrow, and you have the wealth you came in with that you can trade in this market.
Yeah, no, that's not necessarily where the economy would go. Yeah. It's a point, but yeah. All right. So now the next thing I'm going to do is I'm going to build a second order approximation of this expression in terms of sufficient statistics that make it kind of more easily to take this measure to quantify it in data without having to fully specify a model of shocks and constraints, etc. Okay, so how are we going to do that? And here we're going to kind of bring tools from like the misallocation literature from the production side, like that Kunal and David and Emmanuel, for example, are working on that. Okay, so how are we going to do this? So we're going to replicate the incomplete. We can always replicate. So take your favorite model of incomplete markets, solve it. You have the allocations, and then we can always replicate those allocations in an equilibrium, in an Arrow equilibrium with consumption taxes that vary by household, time, and state. Okay. Once you have the allocations, you can construct what those taxes are, and what are they, given some allocations. So let me define omega HTS to be the share of consumption in day T and S that household H gets certification. Okay. Then the taxes that replicate this incomplete market equilibrium under our rule are going to be given by this, where this remember the IS. So what's intuition for this? So if I see at some point, so remember with complete markets and no distortions, everybody gets a constant share of consumption across states and time. So any deviation from constant shares, we're going to replicate it using some taxes. So for example, if I see that Mr. H at TNS gets a higher share compared to what he gets in the first period, let's say, then that's going to say that at that state, H pays a lower tax. Okay, so that's kind of mechanically how if in the data the shares are constant, then the taxes or the subsidies are going to be zero.
So what you're doing here also includes leisure or not?
Not here, but we're going to be able to do it. Yes. All right. So okay, so now we have these wedges, and then we can apply we can solve for A using kind of a deadweight loss triangle formula that David and I derived for very general environments with the reduced agents in another paper. Okay, so what is this Harvard triangle formula? Okay, so this is kind of general, and then we'll substitute these terms. So the misallocation, okay, to a second order in wedges is going to be a weighted average, expenditure share weighted average of deadweight loss triangles on a Harvard. What are these deadweight loss triangles? So it's going to be the base of the triangle is the wedge. The height is going to be the change in consumption due to when you remove the wedges. Okay, that's what this is. Okay, 1/2 is to make it into an area of the triangle. Okay, so basically you take the wedge, you compute the change in the quantity, and you multiply 1/2. That's by household, state, and time. And then you add those triangles, weighing these by net present value expenditure shares. Okay, so and that's what these are. Okay, so this is the expenditure share of household age on average, standard approximation, and these are like we need to discount them. Okay, so and of course, like richer people get a higher weight because kind of a distortion to a richer person means that this person can compensate others. So that's why this triangle gets a higher weight. Now, so far how to use this. Now substituting this in here, that's where we bring the structure that we did before. We can simplify. We get this formula. Okay, so misallocation depends on the variance. So again, substituting the wedges depends on the variance of expenditure shares conditional for one person over time. Okay, so you take one by one, you compute the variance weighted by discounted by the interest rate and it's a net present value terms variance. Okay, household by household. Okay, that's this variance, the conditional variance, and then you add them up, weighted by expenditure share of each household, and then you multiply by 1/2 the same representation. Okay, a couple of things. Notice that there's nothing here about inequality across people. This is only about conditional variance, how my share moves over time and stays. There's nothing about how rich I am or how much I consume relative to the credit. Okay, and the other thing that is kind of nice about this formula is that to implement it, it only requires moments of expenditures. Okay, there's no model that is needed of portfolio choice, or you don't even need to specify the income loss if you don't durables. While for durables, the way we're going to take it to the data is kind of using the annual, like the renter equivalent for how we do it for housing. In the data, we don't have durables, we only have housing. That's our only durable. So it's like the flow value. That's how we take it to the data. Yeah. So okay. So that's how that's kind of how we're going to implement this. Before taking to the data, let me tell you how it works. How this second approximation works in a specified beauty model. Okay, we take a completely off-the-shelf model and calibrate it, and we compute the formula exactly and using the second approximation. The first thing and this is like as we vary the idiosyncratic income shocks in the beauty model. The formula works like perfectly analytical as you make the idiosyncratic shocks very small. But you can see here that you cannot tell the two lines apart. The approximation is very good. And in the calibrated model, the gains are for our baseline joint calculation of income processes, the misallocation is about 20% above. So if you write us an off-the-shelf beauty model and you complete markets, you can attain the same. Everybody can be made different with 20% less factors in every period. Okay. Now, if you apply before it goes to the data, if you apply the more traditional veil of ignorance social worker function in this model, then you get gains that are almost more than twice as large. Why? Because for that you can show that you're using unconditional variance of expenditure shares. So you're kind of mixing together inequality and risk. Okay, whereas our measure is only using the risk for 1% of that. Okay. All right. So now let's apply this.
Like 9 minutes.
Okay. So in the paper we show how to extend this formula, the measure and the formula, to allowing both for labor leisure choice and endogenous capital accumulation. I don't have time to get into it, but I'm happy to talk about it later. The quantitative results, if you apply a formula, are very similar. Okay, but I'm going to have to split it because I don't have much time. And for these cases, the measure is different to the Benahou measure. Okay, and yeah, anyway, this is like with leisure, but I don't have time to talk. This is capital, so I'm going to split. So now let's apply the triangle formula in the PSID data for the United States for the period 1999-2020. So we need, what do we need? We need a discount factor, an interest rate, under complete markets. It doesn't matter what because it's a single approximation. We're going to use an EIS of 0.5. The interest rate we use is 5%, like in the other one. So the only thing to know is to compute this conditional variance. So we're going to estimate expectations of expenditures by household by running a regression like this. Both including a bunch of controls. There's a lot of details that I don't have time to talk about. To compute the variance, we need both the first moment and the second moment. Okay. When we estimate in the PSID data, again, for durables, we only have housing, we compute the renter equivalent. We get the gains from competing markets using this formula is about 20% of output in every beginning state. It's very similar to the one you get in the model, even though we're not imposing any model here, except for the references. Okay. These are pretty large gains, especially on, like, for example, the cost of business cycles, of removing business cycles by that, which is a much smaller number. And this is like sensitivity to say back in the interest rate. We have a lot of sensitivity in the paper. They are not that for these discount factors, the numbers, the more discounting there is, the smaller the gains, but they're not that sensitive to that. Okay, so in the remaining minutes, I want to talk about the gains from completing markets internationally. So we're going to ask a very similar question. How much you can save if you were to complete markets internationally. Okay, the main complication is that different countries consume different goods. Okay, so there's kind of two challenges to answering the question. One question is like, what is the question we're asked? What does it mean to quantify how much are we losing from incoming markets when different agents value different things? Okay, they're like rate of ignorance is not even well defined because different people have different brain. Okay, we're going to use the same measure as before. Okay, the second challenge is how do you separate efficient volatility due to productivity shocks from inefficient volatility due to frictions? When in a closed economy with a single good, in the Pareto efficient allocations, everybody has like constant consumption share. But if different people consume different goods, then even in the efficient allocation, consumption shares will be moving because of same non-traded goods. We're going to use the second order approximation, sufficient statistics that do not require to separate it. Yeah. So I'm going to go quickly. So we have again CRA preferences. Now they vary across households, say because of non-tradables. So we're going to have a very general CS structure, international, with intermediates, many factors, arbitrary isolate costs, import-output linkages. I'm not going to describe everything. There's a bunch of resource constraints. Now again, there's like household by household, they consume different goods, so the resource constraint holds H by H, not across households. Okay, and again, we're going to define this allocation by the maximum contraction of TFP in every country, such that it's possible to keep every country, every household different to the initial equilibrium. And I'm going to show you directly the second order approximation. We do exactly the same. We replicate the initial equilibrium with the complete markets using a narrow derivative economy with consumption taxes that vary by household. Okay, and these are the taxes that you need to decentralize to implement the complete market allocation. So if everybody consumes the same good, then the price of consumption, this term is zero, so we get the same expression as before. Okay. Otherwise, the wedges that you need to replicate the initial minimum depend on the real exchange rate. If the wedges are zero, then consumption growth is perfectly linearly correlated with real exchange rate, as in Backus-Smith. So basically, the wedges are going to capture any deviations from Backus-Smith condition. And then we're going to ask the question, how costly are these deviations from Backus-Smith? All right. The second order formula is still, approximation is still valid. So we're going to start from the same expression that we had before. And we're going to plug in these wedges here. And we're going to solve for the change in consumption to that solve parade. And we get this formula, okay, which is very similar to the one before. Now it's a covariance of wedges cross households, okay? And there's this was the one over here before. Now it's a matrix that we have to solve for, but it only depends on static input output, like the network at a point in time, and a distribution. Okay, so you don't need to measure the shocks. You don't need to take a stance on what the constraints are, etc. So, all right, we have a simple case for intuition, where you can see this is like two symmetric regions, to get a sense of what matters. Okay, so for example, the more substitutable are the goods, the higher is the Armington trade elasticity, then there's more gains from competing markets because we can there's more opportunities to share risk. If we produce very different goods, if we consume the very different goods, then there's not much of a gain from sharing risk across countries. Okay, and the general case kind of generalizes this formula, but we have it in the paper, like how to compute it. So the final thing is we're going to apply the triangle formula to measure misallocation from international equity markets. We're going to abstract from within country heterogeneity. Okay, so we're going to do like the two things separately. We're going to use the world input-output database, 32 countries, 54 industries, which makes some kind of standard parameter choices. We get the wedges from deviation from bucket fields using some data, international data that exists for that period. Again, no info is needed on portfolio problems or any ownership of assets. And we don't need to measure cycle-level productivity or trade costs. It's another formula, second order. The formula works pretty well, and we have some examples, but let me finish with this, then I conclude. So we take this, we kind of calibrate the model to the data that I told you, we apply the formula. What are the gains from competing markets is about 5% of world consumption in every period state. So you can get the same, you can make every household in every country different to the world we live in, with 5% less factors in every period and every state. Input-output linkages are important. If you don't have, if you assume that there's no factors, so there's no intermediate inputs, the gains are smaller, about half. Now, these gains are mostly driven by differential growth between, say, China or India and Germany. How do we see that? Suppose that we set the wedges for the high growth countries like China, India, Korea, Indonesia to 0. This is a counterfactual. And then we compute this again, we get a misallocation of 1%. Okay? So at least among developed countries, in spite of the very large deviation from the risk sharing condition, the gains from international business cycle insurance are not that large compared to the idiosyncratic gains.
Just because they're growing a lot, they're doing even less sharing.
They're more correlated. Yeah. So let me conclude. So we quantify this allocation between ability to share resources across states and time. We are doing everything related to the Pareto frontier, but the measure can be extended, applied to basically allowing for other distortions. So to look at constrained efficient frontier and accounting for other policy imperfections. And as I said before, this is part of a broader research agenda where we study this kind of measure, applying it to different contexts with heterogeneous agents and thinking about optimal policy to maximize a measure like that in work with stronger. That's not clear.
Andreas is gonna discuss. Thank you.
Thank you.
All right. Thank you so much for having me today to discuss this paper. So the question is, how costly are incomplete markets and sort of limited risk sharing? When you have a single agent, this is sort of very easy to do, right? Going back to Lucas, because you have a single number, consumption equivalent, very easy to do. When you have a bunch of agents, what you can do is you can compute each of their willingness to pay or consumption equivalent gains, losses, and you can report them in a distribution or however you want. But then going from that distribution to a single number, that's really hard, and that's where welfare economics sort of, struggled for a while. So standard routes for doing this is either reporting the distribution at the micro level, summing utilities using social welfare functions. The big issue you run into here is that social utility or utility is sort of not invariant to preference preserving transformations. You can relabel things. You can sum compensating variations, but then there's a question, do you implement them or not? And so this is where David and Ariel make really, really useful progress. This is a new conceptual approach that tries to measure aggregate productivity gains or the flip side, misallocation losses. So how do we do this? We're going to define aggregate productivity or misallocation as, suppose we go from one allocation to another, right? Something changes in the world. In that new state of the world, how many resources are left over, or by how much can we shrink the economy if we can freely reshuffle so that we can hold everyone weakly indifferent to the status quo? And I'll walk you through this in great detail. So notice that this very neatly gets around this challenge of interpersonal welfare comparisons because it doesn't use utilities and it has a comparable unit, namely consumption equivalent rates. And then, given the audience today, I'll sort of focus on the consumption application. The main applied result is a second order approximation of this welfare misallocation gain from completing markets, and then we're going to take this to US PSID data. Great. So for today, I'll spend a lot of time trying to walk you through the intuition and how to actually compute this in like the simplest possible vanilla example. And then, again, given sort of the interest in the room today, I'll focus mostly on taking this to the US consumption data and what might, what we may or may not capture when we do this. Okay. The simplest example, apologies in advance. There are two people and there are two periods, Alice and Bob. There's one good per date. Both of them have log utility, no discounting. Let's say that the aggregate endowment in this economy is 5 units per period, okay? 5 in the first period, 5 in the second period. And let's say that the status quo under incomplete markets due to some unspecified frictions is Alice consumes 4 in the first period, 1 in the second period, Bob consumes 1 in the first period, 4 in the second. What are the gains from completing markets here? So let's do this graphically. Everything inside the box is a feasible allocation given the aggregate endowment or output that we have in this economy. The black dot is where we are right now. So what do? Notice that these are the indifference curves. So every point on this curve here, Alice would be indifferent relative to the status quo. The region between them obviously are sort of potential gains. Now, if we move all the way to complete markets, right, we must be on this orange diagonal line, because we need to have MRS being equalized. So we want to be somewhere over here. But then, of course, there's a whole bunch of points where we could possibly move to, right? And that's the green line. So the sort of interest for today is this green line. This is where we would move to if we complete markets. And at either one of these endpoints, Alice and Bob would be just indifferent relative to the status quo. So how do David and Ariel propose that we do this? And notice that there are two sort of big questions. One, well, which point on this curve is sort of interest? And then two, how do we aggregate across Alice and Bob? How do we get to that one number as opposed to just reporting individual gains? So here's how Ariel defined aggregate productivity gains. Suppose we go to complete markets. How far can we shrink the aggregate endowment, keeping everyone indifferent to the status quo? What does that look like? Simplest possible example. Notice that we have log utility, no discounting. Well, Alice had 4 and 1. Notice that that's equal to 4, and you can split this up into a flat stream of 2 and 2. we know that without discounting in incomplete markets, they both want a smooth, they both want flat profiles, and so we're gonna have 2 and 2, right? So for Alice, she is indifferent between 4-1 and 2-2. Notice that this means that we can sort of make both of them indifferent using an aggregate endowment of 4. The economy ex ante had an aggregate endowment of 5, so we can discard one and still make everyone indifferent. So that's how we get to this productivity number of 5/4. I'm going to introduce one thing which I'm sure all of you have seen infinitely many times, which is sort of the consumption equivalent, let's say in the Lucas notation. Let lambda be how much better off you are relative to the status quo. So using the indifference notation, in the new allocation, you are indifferent to lambda times the old allocation. And the C here is sort of your consumption stream. Great, so if lambda is 1.1, it means I'm 10% better off in consumption equivalent units. No utils, no interpersonal comparisons. Great. Now, in our example, notice that you can compute this really easily. I tried to pick numbers that are sort of as few decimals as possible. So when Alice has 2, right, this is 1. Because why? At 2, she's exactly indifferent to her status quo allocation. Notice that this lambda also has a slack interpretation. You can divide consumption by this thing here, and then it tells you basically by how much can you shrink consumption to still make that person equally well off. And so nobody worse off ends up being a restriction on these lambdas. Let's again make this sort of graphic. Suppose we start here, and suppose, just for illustration, I'll walk you through, that we have some transfers or something happens such that we end up at this point. And now I'm going to show you how David and Ariel are going to compute their measure. So at this point, notice that Bob is exactly indifferent because Bob is consuming 2, indifferent to the status quo. Notice that Alice really likes this point. She has a consumption equivalent gain of 50%. So can we go here? No, because that makes Bob worse off, right? So we have to go inward and we have to go inward along this diagonal. So these points. So let's move here. What happens here? Well, both of them are now better off. Notice that the thing that really matters is the indifference curve of Bob, because on that indifference curve, he's indifferent. And the requirement is everyone at least indifferent, weakly indifferent. So what can we do now? We can shrink the Bobs. We can shrink the aggregate endowment, which moves Bob's indifference curve inwards proportionally until we hit exactly this point with Bob's indifference curve. And now we can go no further because of your requirement that says Bob has to be weakly indifferent, right? Great, so we've done this. But notice that Alice still has gains left over that we can reshuffle to Bob. And so we can keep going until we shrink the economy by exactly 1 unit. And notice that at that point, we get exact equalization of the consumption equivalent gains. That's sort of in the definition. So this is the simplest possible version that I could come up with for how to do this mechanically. And it again gets you exactly this number of productivity. Slightly different perspective, which is just the math of doing this, is you get a max min representation. Nobody worse off means there has to be a min, right? Because the least well off, the least sort of better off, is the one that's going to be the binding in that constraint. And there's going to be max because we also get to reshuffle the allocation. We get to pick our favorite allocation subject to this everyone better off. And so you can also write this as a max over reshuffling or transfers, min over households, and then consumption equivalent gains, which gets you 5/4. Amazing. 2 very quick examples just to drive home this point. And you mentioned both of those already, but just to get the point. Does this pick up inequality? Well, no. Here's the inequality example. Suppose that Alice has 4 and Bob has 1 in the original status quo allocation. That's exactly this point here. Notice that this point sits on the diagonal because for both of them, their consumption profiles are already flat and smooth, right? So this is in fact a Pareto efficient point, and we would not move away from this point if we went to complete markets. Different way of saying this is that going to complete markets implies both their consumption equivalent gains are 1, and therefore A is 1, and the measure does not pick up inequality or sort of redistribution on permanent differences. What about aggregate risk? Well, in this super simple world, aggregate risk is a rectangle rather than a square box, right? Because we have more resources in date 0 than we have in date 1. But notice again that if we have both of them starting with an endowment or consumption allocation of 4 and then going to 1, right? Aggregate risk is encoded here as the aggregate share, the aggregate pie going from 8 to 2. Then the point is again on the diagonal to begin with, we cannot move and therefore they're not going to pick up undiversifiable risks that everyone is exposed to. Great. So that's sort of the simplest possible way of seeing mechanically what's going on. And I'm going to now have a couple of comments, one very quick one, and then a bunch of them on the empirical application. So there is a question which I think Jonathan already raised, which is are we going to an allocation? Does that matter in some sense? Well, the reference allocation that is in the measure is the one where we're sort of equalizing, compensating, consumption equivalent gains. And you can think of that as some notion of compensating transfers going on in the background. Now, gladly, the companion paper that I think led this paper already tells us exactly how to do this if we don't want this assumption. But let me just show you why this might be really relevant here. And I think that was exactly your question, which is, this is super heuristic, okay? This is not formal by any means. But suppose that this box is some kind of Bewley Huggett economy, where Bob is holding all of the assets and Alice is actually in debt. And now, the perturbation that we have in mind to go to complete markets, let's say for argument's sake, is relaxing the borrowing constraint. Now we know that that kind of puts upward pressure on the interest rate, and as the interest rate goes up, because Bob holds a bunch of assets, there might be a positive valuation. So if we actually do that perturbation in the structural model, you might go to point C as opposed to point B, because Bob is picking up valuation gains and gets to eat more at the end of this, right? That's sort of, not everyone is equally exposed to the perturbation itself. And so then there is a question of, well, are we interested in point C or point B, and what exactly does it mean to sort of compute the misallocation gain relative to point BB for Buckeye University, relative to point C. But gladly, you guys already figured out how to do this, and I just want to say that I think in this context it would be very useful to do that. Okay, now let's talk about data. So I'll do this very quickly. This is the result. So Ariel sort of very carefully derive this result, which is a second order approximation sufficient statistic for misallocation if we go to complete markets. Notice that we're summing over households and then we have a variance over the date space distribution. This is sufficient because if you look at it, all you need is the data, you need an interest rate, and then you need sort of expenditure shifts. We're going to go to PSIP data. 6 consumption categories. The objects we're going to work with is consumption shares, the initial expenditure share, this variance, which I'll tell you in a second, and then the parameters. And we're going to find sort of 23 log points or 20% misallocation due to incomplete markets. Okay. What is the identifying assumption in this exercise? What we're going to need is that if I observe a panel of households, right, along realized paths, that's kind of the same as having the full date space joint distribution for each household ex ante. They run a regression of expenditure shares and the square on initial conditions, both initial expenditure shares and covariates, these covariates. And then we're going to construct the variance, estimate of the variance like this. So here's the, this is how you just compute the variance. And then since we're going to pick eta 0.5, misallocation is literally this variance. And the identifying assumption is that given 99 observables, all residual cross-sectional dispersion and shares must be uninsured risk, must be misallocation. So this connects to a vast literature, like truly vast literature, right? So I think when I look at the paper, it's like a really useful and elegant new aggregation theory. It does want to speak to a very old and broad literature on empirical consumption identification and measurement. Right? It started with full insurance tests, partial insurance tests. Lots of people in this room have worked on this. Sort of I'll do this very quickly, right? Mechanisms, then sort of welfare estimates. And the paper takes this very elegant sufficient statistics result, which teaches us a lot about the channels, directly to the data and ties welfare gains to the variance of log consumption shifts. So the main lesson I've learned from this literature is that not all consumption variation in the data is necessarily inefficient. right? Why might that be? There might be preference heterogeneity, which leads to efficient shares trending or loading on aggregate risk. Demographics mean that efficient consumption tracks family size, right? So we don't necessarily want births, divorces, empty nesters leading to wedges. State-dependent needs like healthcare, moving marginal utility, non-separable leisure home production when you retire, etc., durables, which was brought up, right? All of these are reasons for the variance observed in the data possibly being positive and not telling us about misallocation. There's some things that are fully addressed, but these are not. There's one question I have for you guys on the regression maybe missing 1 point relative or 1 term relative to the proposition, but we can talk about that. And then there's a 30 seconds question on measurement error, right? Huge question on measurement error. This literature has thought very carefully about measurement error. Notice that the statistic Aria presented was a variance, and so measurement error and noise feeds 1-to-1 into variances, right? And it's not attenuated, and noise in the initial conditions regressor further inflates this. So I put together a bunch of estimates of how large this could plausibly be in the PSID. Jonathan has worked on this, although not in the PSID, I guess, putting this sort of 4 log points. The closest paper for you guys, I think, is this, because it has exactly your sample on the PSID. They have sort of between 3 and 4 log points. Lambda Pisaferi for extent. And then if you put this together and make educated guesses, what do you get? Well, you might lose 3 to 6 log points due to this direct pass-through, another 2 to 5, maybe due to the noisy initial condition, and that might account up to 25 to 50% of the total measurement. And sort of the standard approach in this literature, I think, is to just use a structural model that accounts for some of these things, including measurement. So to conclude, super valuable progress on the aggregation question, conceptually, very elegant sufficient statistics result. And maybe this is, a call for us to do a lot of future work on this. If we do want to take it to the data and get sort of a number, I think there are a lot of things that we want to think about, that there is a vast literature that's already thought about this quite a bit. Thanks, guys.
Thank you, Andreas.
Any questions? All right. Yeah, I thought the theory was very neat, and I think it's very applicable to any model to sort of report that number. My question relates to sort of Andreas's thoughts about how we take this to the data and how we interpret. It's all about this within individual variation in expenditure shares over time, but much of those could be efficient. Health expenditure shocks, you have kids, and there's kind of the question, even once we put the observables like family size, you can imagine one family has their grandparents around, so they don't need to pay for childcare, the others do not. Yeah, so how do we think about that?
Thanks. Obviously important work. I want to follow up on something you flagged, but I don't think flagged enough. People are not created equal. People are not created equal. So Elon Musk versus me, I don't matter. What matters is how well is Elon Musk insured. Because for your aggregation, for your measurement, rich people are overweighted. And Elon Musk is not in PSID, by the way. PSID overweighs the poor. And in order for me to buy the 20%, I really have to think that Elon Musk is very poorly insured. And his fluctuations in his consumption are very inefficient. So I think emphasis on I would emphasize that for your measurement, wealthy people really matter though.
I know maybe this is kind of not where you want to go in the paper, but like looking at the plot where you showed like the difference between what your measure would be versus what I would get if I used like behind the veil thing, could I interpret that as a decomposition between, okay, this is how much is due to like efficiency considerations versus, redistribution? Yeah.
All right. Thanks a lot, Andreas. That was an amazing discussion and very useful. We'll try to use some of your explanations for the paper. Okay, so let me answer some of the comments. So for this paper, as you said, we're focusing on distance to frontier. Okay, so kind of we're not doing like what if you added some markets. So in that sense, we're going straight to the part of the frontier, and that's why we're basically allowing for we're picking any point in the Pareto frontier when we're constructing the maximum contraction. But I mean, there's another question, which is what are the gains from adding some markets, like a more finite version, okay? But that's kind of what I think it's kind of the starting point that I think is natural. And as you said, the theory of how to deal like with constraint efficient, we have a paper where we dealt with that. In terms of some kind of also related to Gideon's question, yeah, so there's a questions of how to apply the formula in data. We applied it like through the lens of like the benchmarks, very simple, maybe like at this point, like behind the frontier, inside the frontier, like Bewley, Ayagari type models where there's no life cycle, it's very, very simple, but the theory can be applied, and kind of course you need to compute those statistics through allowing for, yeah, so that's more, it's a bit like the proof of concept given those models. Okay, measure and error, we're estimating the first moment and the second moment. So I think that maybe I'm wrong, but if it's like classical measure and error, I think these are unbiased. Okay, so they would have to be correlated in a certain way to get like a bias in the misallocation, but we should definitely think about that. So that the two last questions. So we're interested directly on the average efficiency gains. There's a lot of good work, including Andrea's work with Eduardo, where they're after like this decomposition of redistribution versus efficiency, even applying to incomplete resharing. So I think they have very good methods of how to do the decomposition. We're after misallocation directly. And finally, Igor, where are you? There. So Igor must in the data, I agree. Rich, wealthy people get a bigger weight, but that's not because we pick Pareto weights in some sense. Yeah. The intuition why they get bigger weight is because if there's a rich guy that has a very distorted path, then if we remove the wedge to that guy, he's so rich that he can compensate everybody. That's why we want to put a lot of. No. I was just giving the intuition of why we get bigger weights. But yeah, we're doing it for the sample of people in the PSA, and that's how we're applying it. And I'll stop here.
Great. Let's thanks a lot, and let's go again. Okay, we're gonna go straight to the next paper, and then we'll have a little break after this. So Carter is gonna present rising income.
Yeah, I'll just pull out yours real quick.
All right, so thanks so much to the organizers for putting this all together. It's been great to see what everyone's working on, and looking forward to hearing everyone's comments. So this is joint work with Kyle Hergenhoff, Cheng-Dai Huang, Michael Nattinger, John Rothbaum, and Leonard Schmidt. I want to take a moment to emphasize that Cheng-Dai is a grad student at NYU. He's going to be in the market this fall, and he's spectacular, so be on the lookout for him. Also emphasize that Michael just graduated from Wisconsin, is going to be a new assistant professor at Carnegie Mellon, so be on the lookout for him as well over the next couple of years. And the usual disclaimer applies. So in this paper, we're going to ask two questions. First, how has income risk changed across the income distribution over the past 50 years in the US? And then second, what are the macroeconomic implications of these changes in income risk across the distribution? Now, in answering these questions, we're going to try to do four things in this paper. First, we're going to measure income risk both over time as well as across the income distribution using newly available 1040 tax returns that have been made available to us starting in 1969. Once we've estimated the evolution of income risk across the distribution as well as time, they're going to try to validate that households at the top of the income distribution do in fact face risk. The way we're going to do this is we're going to observe large declines in income for these households and then see how they respond doing things like pulling money out of their 401k early, as well as moving to lower income neighborhoods. Once we've validated that households at the top of the distribution do in fact face risk, they're going to estimate a savings response to risk by leveraging capitalized interest and dividend income that we're able to observe in our 1040 tax returns. And then finally, to quantify the macro effects, we're going to embed our income process into a quantitative Bewley model. We're going to show that our calibrated model is going to be consistent with these savings responses. We're going to change risk like we see in the data and then measure the effects. So that's the plan for today. Just to preview what we're going to find, that permanent income risk, and by that I mean the variance of shocks to permanent income, that it has increased substantially amongst high-income households. To put some numbers behind this, since the 1970s, for households that are in the top 5% of the income distribution, we're going to find that it has gone up by 70%. And for households at the very top of the income distribution, we are going to find that it has effectively doubled. So high-income households are facing substantially more permanent income risk today than they did in the 1970s. We're then going to argue that this risk is real. We're going to show that in response to large declines in permanent income, households are going to respond by pulling money out of their 401k early. They're also going to move to lower income neighborhoods. And we're going to show that these relationships hold even within the top 1% of the income distribution. So again, we're going to argue that this risk is real. We're then going to examine the savings response. And we're going to show that in response to increases in permanent income risk, households are going to respond by saving more. When we examine the heterogeneity in these results, we're going to find that these savings responses are pronounced amongst high income as well as younger households. So in sum, empirically, what we're finding is that high income households, they are facing more risk and they are saving more in response to it. They're going to examine the macro effects of these phenomenon. And again, to do that, we're going to embed our income process into a quantitative Bewley model. We will show that the model is consistent with these savings responses. We're going to change risk like we see in the data. We're going to measure the effects. So to preview what we're going to find that the increases in permanent income risk that we've documented, they've led households to increase their desired savings. That is putting downward pressure on interest rates. And through the lens of our model, that's going to lower their risk-free rate by about 0.7 percentage points. So what's happening here is that, in response to risk, households want to save more, but the decline in interest rates is going to push against that desire to save more. What we're going to find in our new equilibrium is that high-income households, they're going to increase their savings. Their increase in risk more than offsets the decline in rates. Conversely, for lower-income households, the decline in interest rates dominates, and they're going to cut their savings. So our model is going to generate a savings glut of the rich, where high-income households are increasing their savings, low-income households are cutting it. That is going to amplify wealth inequality. One measure of this is the top 1% wealth share. We're going to find in our model that's gone up by about 5 percentage points. So to summarize the paper, permanent income risk has gone up at the top. These high-income households, they are saving more in response to it. That puts downward pressure on interest rates. That's expanded wealth inequality. So that's the paper. Okay. So what I'm going to do first is I'm going to show you how we're going to estimate the evolution of income risk both over time as well as across the distribution. Just to fix ideas, I'm going to start by writing down a really standard income process that I'll tell you about the 2 tweaks we're going to make in this paper. So YIT is the residual log income. We'll be very precise about our definition of income on the next slide. Just to fix ideas, we're thinking wage and salary income as well as business income. When I say residual income, we're removing the predictable components of income due to things like age and time. So we're going to say that your residual log income is going to be a function of your permanent income ZIT, as well as a transitory shock omega IT. And these transitory shocks are going to have some variance R, which we're going to allow to vary over time. Now your permanent income is going to follow a law of motion, where your permanent income today is a function of your permanent income from the prior period plus a permanent shock new. And we're going to allow the variance of those permanent shocks it's going to be governed by this parameter Q, which we're allowed to vary over time as well. And then your initial draw of permanent income, it's going to come from a normal distribution with some variance Q0 that will also allow to vary over time. So far, really standard labor income process. Again, we're going to make 2 tweaks in this paper. The first is that we're going to allow your income risk to vary with where you are in the income distribution. To do that, we are going to rank individuals based off of their lagged residual income. We're going to note these ranks by R. We're going to make the variance of shocks to transitory and permanent income functions of these ranks in addition to time. So that's going to be the main innovation of the paper. The second is a little bit more technical. And so what we're going to do is we're going to incorporate information about income risk from periods of non-employment or non-filing. The idea here is, we like to work with the log of income in this literature. Then you immediately get into this issue of what do you do with the log of 0, the log of a small number, or the case of a business owner, income can even be negative. What a lot of previous papers do is they just drop these observations. Our method is going to allow us to incorporate those observations and incorporate those in our measures of risk. I'm going to largely ignore this for today because for the macro stuff I'm going to show at the end of the talk, this turns out to not really matter. I'm happy to chat more about it afterwards. So this is going to be our income process. The way we're going to estimate this is through a combination of the Kalman filter, as well as an expectation maximization or an EM algorithm. This is going to build on some of our earlier work. So to give you just an overview of this, what Kalman is going to do is it's going to allow us to recover a time series of permanent and transitory income for every person in our sample. So you can think about this method as adding 2 new columns to your data set where you have income, but then from using Kalman, you're going to get a time series of permanent transitory income every person, every period. What EM is going to do, it's going to give us a very tractable way to estimate the parameters or income process. What we showed in our earlier paper is that what EM does is it gives you a way to estimate the parameters as a rich function of observables, which for today's talk are going to be lagged income rank and time. So this is our income process. This is how we're going to estimate it. Let me tell you about our data. So our data is going to be the universe of 1040 tax returns. We're going to have these from 1969 to 2019. But the caveat to this data is we're only going to be able to observe them every 5 years. So we're going to have the years that end in 9 and 4. So we have access to the universe of these tax returns. But in the paper, we're going to work with 2 samples. The first is going to be a 2% random sample of these 1040 tax returns just for tractability. But the main sample we're going to focus on today is going to be the history of these 1040 tax returns for anyone who was ever in the March supplement to the CPS. What's going to be nice about this sample is from the CPS, we're going to get a little bit of extra information about these individuals that is not available on a tax form, such as what is your occupation? Are you self-employed? What is your education? Things like that. Okay. Now, I put a few restrictions on the sample. So to be in our estimation sample, you have to be between the ages of 25 and 60. You have to meet a series of minimum labor force attachments, which for today, are going to be that your income has to be over $10,000 at least twice. And it also has to be over $10,000 at least half of the years between when you first and last satisfied the cutoff. I'll go ahead and flag that this dollar amount here for the minimum cutoff and the share of years you're over it, it's not really going to matter for anything I show you today. Now, tell you about our measure of income. Our baseline measure of income for today, it's going to be wage and salary income plus business income plus capital gains. We include capital gains because the way the data is given to us, we cannot separately pull it out until 1994. I'll go ahead and tell you that we can pull it out in 1994 and we have, and it doesn't change anything. So I don't think that's driving the results here. Also go ahead and say, if you prefer wage and salary income, we show that in the paper. Everything I will show you today will go through. The magnitudes will just be a little bit small. Now we want to remove the predictable components of age. We're going to do that by removing age, year, and number of adult fixed effects. You can interact year and number of adults in the household, and everything we would show you today would also go through. So the profiles of risk that we're going to recover, they're going to be a function of your lagged income rank. You're going to allow these to vary by decade. You will also allow these to vary by age. Okay? So we talked about the method, we talked about the data, so let me show you what we get from this. So what I'm going to show you first is the profile of permanent income risk. And again, by that, I mean the variance of shocks to permanent income as a function of where you are in the income distribution, and this is for the 1970s. So what I want you to observe here is the shape, and see that we get this asymmetrical U-shaped pattern, where permanent income risk, it decreases as we move up in the income distribution to about the 80th percentile, then it starts to increase, and it increases quite sharply as we go out into the far right tail. So the thing that we want to highlight is that permanent risk is convex at the top. It increases quite sharply as we go out into the far right tail. So this is the full profile for 1 decade. What we're going to show next is the evolution of permanent income risk over our whole time series for selected percentiles of the income distribution. So that's what I'm showing you here. I've just normalized the y-axis so that it's equal to 1 in 1970. So the first line that I want you to observe is this black dash line with the triangles. So showing the evolution of permanent income risk for households at the 95th percentile of the distribution. So what we see is that there's this pretty steady increase in the variance of shocks in these households from the 1970s to the 2000s. Goes up by about 70% over this time period. Comes down a little bit in the 2010s, but it's going to end the sample about 55% higher than where it started. Look at the blue line. This is plotting the evolution for the 90th percentile. Pretty similar time series where there's a steady increase in the 70s and the 2000s. Comes back a little bit in the 2010s. It's going to end the sample about 50% higher than where it started. Now, these red and orange lines, these are showing you the profile or the evolution of shocks at the bottom of the distribution. We can see a distinctly different time series. With the 10th and the 25th percentiles, it's pretty flat over the first 20 years of our sample. It's increased over the last 20 years. They're going to end the sample about 20 to 30% higher than when they started. So this is going to give us our first indication that permanent income risk, it is increased across the distribution, but the increase is largest for high income households. So this is selected percentiles over the whole time series. What I'm going to show you next is the full profile of shocks across the income distribution from the 1970s in black and the 2010s in red. So what we see is that this profile of shocks, it has shifted up across the distribution, but the largest increases are as we go out to the far right tail. And if we go all the way to the very top of the distribution, we're going to find that the variance of shocks to permanent income, it is effectively doubled. So high income households are facing substantially more permanent income risk today or in the 2010s than they were in the 1970s. Okay. So everything I've shown you so far is permanent risk. Let me now show you transitory risk. So this is transitory risk for the 1970s in black and the 2010s in red. First thing I'll emphasize again is the shape. You get this pretty flat profile of transitory risk from the bottom of the distribution to about the 80 or 85th percentile. Then it increases pretty sharply as you go in the far right. So just convex it. Yeah.
When are you ranking them? Like to say somebody is in the 80th percentile?
We're going to rank. So for today, we're using my rank from 5 years ago because we observe the data every 5 years.
So the same individual could be up.
Yes. So the ranks dynamically evolve. Yes. So transitory risk is also going to feature this convexity. And then as we move forward in time, what we're finding is there's really not been much of a change in transitory risk for most of the distribution until we get to about the top 5%. And if you go to the very top of the distribution, transitory risk has gone up by a little bit more than 60%. So high income households are facing greater permanent risk as well as greater transitory risk. Okay. Now, in the paper, we show a series of additional results that I'm just going to briefly summarize. So I commented earlier that our method allows us to incorporate risk from periods of non-employment or non-filing. We do that by estimating a separate, process for those individuals so they have there's a variance of shocks that's specific to them. We allow that to vary over time, and we're going to find that permanent income risk during these periods of non-employment and non-filing, it is also increased. Our method also produces an estimate of the variance of the initial dispersion in permanent income. That has also gone up over time. So households are showing up in the data more unequal today than they were in the 1970s. We also show in the paper these results are robust to a series of alternatives. We can use different measures of income. We can use adjusted gross income. We can use wage and salary. We can remove capital gains. Everything's going to go through. There's also nothing specific about the CPS sample. You would find similar results in a random sample of 1040s. And you can change the conditions for being in the sample and everything's going to go through. Since this is a short talk, I'm just going to briefly highlight 2 other results we show in the paper, and I'm happy to talk about this afterwards. You like this split of the permanent and transitory risk. I'm going to show you what that matters for as we go. But if you just wanted to use simple moments, such as the variance of a 5 or 10-year change over time across the distribution, you would have also found that risk has gone up the most at the top of the distribution. You can also split the sample by the CPS's question on are you self-employed or non-self-employed? We're going to find amongst self-employed individuals that they have higher levels of risk. Risk has also gone up more for the self-employed, but you would have also found these patterns among the non-self-employed as well. Okay. So everything I've shown you so far, it's kind of been based on income changes, which we're interpreting as risk, but you could worry, especially for these high income households, is this reflective of choices? So that's what we want to examine next. We want to try to get at, is this actually risk? And to do this, we're going to ask, do households with large declines in their permanent income, are they acting as if something bad has occurred to them? Now, to do this, we're going to leverage the fact that our filter is producing 2 extra columns in our tax data. Remember, because we're using Coleman, we're going to get a time series of permanent and transitory income for every person in our sample in every period. So we're going to identify instances where the household has a 1 standard deviation or larger decline in their permanent income. We're then going to see 2 different indicators of economic distress occur in response to these large declines in permanent income. And is this true even at the very top of the distribution? So for today, we're going to consider 2 different measures of economic distress. The first is going to be making an early 401k withdrawal. We're able to observe these by seeing Form 1099-R in the 1040 data. The second measure of distress we're going to look at is moving to a lower income zip code, which we're going to define as moving to a zip code where the median income is 30% lower this year than where you were in the past. And formally, we're going to see how these measures of economic distress relate to having a large decline in permanent income while controlling for where you are in the income distribution and a bunch of other observables. So when we do this, we're going to find first that in response to a 1 standard deviation or larger decline in permanent income, households are more likely to pull money out of their 401k. This blue bar is showing our estimate across the full sample. We find that in response to a 1 standard deviation decline in your permanent income, your probability of making an early 401k withdrawal goes up by about 6.5 percentage points. These orange bars are showing the results when we estimate this regression across the income distribution. The bar I want to highlight is this one all the way to your right. This is showing the effect of when we run this regression within the top 1% of the income distribution. And even within the sample, we're going to continue to find that large declines in permanent income, they are associated with pulling money out of your 401k early, which is penalized, which again leads us to think that these changes in income are reflective of risk. We're next going to do the same exercise, but examine moving to lower income zip codes. Again, the blue bar is going to show this result across the full population. We're going to find that in response to large declines in permanent income, you become more likely to move to a lower income zip code. Orange bars are again across the income distribution. The one at the far right is within the top 1%. And even within the top 1%, having a large decline in income is associated with moving to a lower income zip code. Okay. So again, we're going to take this as evidence. These changes in income, which are underlying our estimates, are reflecting risk. Okay. So what I want to do next is then try to examine how does savings going to respond to these changes in income risk. What we want to do here is we want to try to discipline this linkage between income risk and savings using what is referred to as an identified elasticity, borrowing the language from Emmy and John. The idea here is that we want an elasticity that we can compute in the data as well as in our quantitative model, and then show that our quantitative model is consistent with our data estimates. So we're really tying our hands on the strength of this mechanism. The way we're going to do this is we're going to compare the savings behavior of households with similar levels of income and expected income growth rates, but different risk profiles. And the way we're going to do this is we're going to exploit within income rank, but across occupation variation and risk. And this is where our ability to link with the CPS is going to be really key for us, because that's going to allow us to observe an individual's occupation. We wouldn't just get that from the tax forms. Okay. So the way we're going to do this, so we're going to start by capitalizing dividend and interest income following the method of Smith, Zwick, and Tadar, their recent QJE paper. That's going to give us an estimate of wealth for every household in our sample. We're then going to compute changes in wealth to income. That's going to be our proxy for savings. Okay. We're then going to estimate our income process by detailed occupation. We're going to be using a Tor and Dorn occupation code, so we're going to have about 300 different occupations in our sample. Now, since not all occupations are going to span the income distribution, we're not going to be able to make these profiles a function of risk. What we're going to recover is the variance of shocks to permanent income in a given occupation O at a given moment in time T. And we're then going to examine how does savings respond to permanent income risk by running a regression. We're going to have our proxy for savings, the measure of risk we recover at the occupation level. And we're going to do this while including lagged ranked fixed effects, two-digit occupation fixed effects, lagged wealth centile by time fixed effects, as well as a bunch of other controls. And the thought experiment here, so we're going to be comparing two individuals at the same spot of the income distribution, but they are in different occupations. And we're going to see, does the person that is in the riskier occupation save more? That's the thought experiment here. And when we do that, we're going to find that indeed they do. So this coefficient on Q, what this is showing is that there are people that are in riskier occupations that have more permanent risk, they save more. In terms of magnitudes, we're going to find that if the variance of shocks to permanent income goes up by 0.1, savings is going to go up by 4.7% of your prior income. We're going to do the same experiment looking at transitory risk. We're going to find that there is a savings response to transitory risk, but it's going to be smaller. It's not 40% of the effect we find for permanent risk. Okay. We're next going to examine the heterogeneity in these savings responses. We're first going to do that across the income distribution. That's what I'm showing you here in these orange bars. The blue bars are their baseline estimate. What we're finding is that as we move up in the income distribution, the savings response to permanent income risk increases. So high income households increase their savings more in response to an increase in permanent risk relative to low income households. We're also going to look across the age distribution, and we're going to find that young households have a larger savings response to increases in permanent income risk relative to older households. So to summarize what we've seen in the empirics, we saw that permanent income risk is convex at the top. It increases quite sharply as we go out on the far right tail. We also showed that permanent income risk has increased substantially since the 1970s. We argued that this risk is real. We showed that in response to large declines in permanent income, households respond by doing things like pulling money out of their 401k early, moving to lower income neighborhoods, even within the top 1%. We then just saw that savings increases when permanent income risk increases, and this is especially pronounced amongst high income and younger households. We show in the paper that when we examine the heterogeneity and transitory risk, the transitory response is really dominated by lower income households as well as the young. So there's a meaningful difference between permanent risk and transitory risk. So what I want to do in the time I have left is we're going to examine what are the quantitative implications of these empirical findings. So we're going to do two experiments. The first is going to be a cross-sectional experiment, where we're going to examine how does the convexity of permanent income risk, how does that affect savings, especially at the top. And the second is going to be a time series experiment, where we're going to examine what are the macro effects of these increases in permanent income risk at the top. And to answer these questions, we're going to use a Bewley-Huggett-Igar style model where we've embedded our income process into it. So just to give an overview of the model, in the model, agents are going to be heterogeneous, risk-averse, and finite-lived. Agents are going to work between the ages of 25 and 60. They're going to retire at age 65, and then they're going to exit the model at age 95. And each model period is going to be 5 years to line up with our empirics. Agents will be able to save and borrow in a risk-free asset at the risk-free rate RF. Agents are going to get utility from consumption, and they're going to have CRA utility. There's also going to be a warm glow bequest motive at the end of retirement. And so households, they're going to maximize their lifetime discounted utility from consumption as well as the bequest motive. When they're in their working life, they're going to face income shocks that are going to follow from our income process. And there's going to be rank-dependent income shocks in the model. Agents are going to face the national borrowing limit. And they're going to face a budget constraint where they consume, they save for tomorrow. That's some prior savings and debt. There's interest on that prior savings and debt. And then income is going to follow from our income process. So everything we did in the tax data is on pre-tax income. In the model, we're going to have progressive income taxation following Jonathan and co-authors' work. And then in retirement, there's no more income risk. Agents are just going to receive their Social Security income, and they're going to make a series of consumption savings decisions. Then they're going to exit the model. Okay. So let me tell you how we're going to take the model to the data. So we're going to calibrate an initial steady state that's going to be consistent with the 1970s labor and asset markets. To do that, we're going to feed in the labor income shocks that we estimated from the 1970s. So those black lines that I showed you earlier. We're going to set the risk-free rate to 3.5% annually following from the work of Walbach and Williams. We're then going to calibrate the preference parameters, as well as the parameters that are going to govern the initial asset distribution to match the following blocks of moments. So the model is going to be calibrated to match the evolution of assets to income over the life cycle. It's going to be calibrated to match the distribution of assets to income among 25-year-olds, as well as moments on bequests. So in general, the model is going to match its targets quite well. So what I want to do next is show you the results of a model validation exercise, so a series of non-targeted moments. So what we want to do in this non-targeted exercise is we're going to estimate the savings response to permanent income risk in the model and then compare it to those empirical estimates I showed you a few minutes ago. So the way we're going to do this is we're going to solve a series of alternative economies where we're going to perturb the profiles of income risk. We're going to do that many times. We're going to simulate data from those. And we're going to stack them all up. Then we're going to run the same regression where we're going to look at the relationship between permanent income risk and savings and how it evolves across the distribution. That's what we're going to do. So when we do this in the full sample of data we simulate, we're going to find that increasing the variance of shocks of permanent income by 0.1, that's going to increase savings by 5.2% of your prior income. So quite similar to our empirical estimate of 4.7%. We're next going to run this regression across the income distribution. When we do that, we're going to get the following result, where these blue bars are our data estimates that I showed you a few minutes ago, and the orange bars are the ones that are produced by our model. So the model is going to be able to capture the fact that high-income households have a larger savings response to permanent income risk than lower-income households. So with the model calibrated and validated, we're going to do our two main experiments. The first experiment is going to be a cross-sectional experiment where we're going to examine how does the convexity of income risk impact savings at the top. So just to set the stage for this, here in this graph on your left, I'm again showing you the full profile of permanent income risk across the income distribution. And the thing that I want to highlight is that it's quite convex as we go on the right tail. The graph on your right is showing the savings rate produced by the model. So the model generates this increasing savings rate as a function of income, as has been shown in many empirical papers. What we want to do is we want to examine how does this convexity impact the shape of the savings function. The way we're going to do this is we're going to remove convexity from this profile of permanent income risk. The way we're going to remove it is we're just going to flatten out permanent income risk at the 95th percentile. So from the 95th percentile at the top, there's this flat profile. Then you're going to resolve the model and see how the savings rates differ across the distribution. When we do that, we get the following result. These are the bars here. So first, for the bottom 90% of the distribution, flattening out the top makes no effect, makes no difference, which makes sense. Then as we go to the top of the income distribution, we're going to find that savings rates go lower. We zoom in on the top 1%, we're going to find in our baseline model, the savings rate is about 22.5%. And this alternative model where we flatten out income risk at the top, the saving rate is decreased substantially, a little bit less than 15%. So our takeaway from this is that the convexity of permanent income risk is one factor that contributes to the increasing profile of savings that we see in policies. So this was in the cross section. What I want to do in the time I have left is we're going to examine the time series effects of shifting this profile of income risk. So again, what we're going to do is we're going to change the profile of risk from their 1970s values to their 2010s values. In this experiment, we're going to hold average earnings fixed, and we're working with the log of income. So if you change variances of shocks, that's going to increase the mean earnings through Jensen's inequality. We're going to turn that off in the model. The way we're going to close the asset market is we're going to hold asset supply fixed at its 1970s level, and we're going to adjust the risk-free rate to clear the asset market. So when we do this, what we're going to find is that the increase, shifting up that profile of risk, that's going to increase the desire to save across the distribution. So households are going to want to save more, but in general equilibrium, that's going to put downward pressure on interest rates. So the risk-free rate is going to clear, it's going to decrease to clear the market. And I'll show you the number in a moment that does it. What that's going to do to savings, though, is it's going to differ across the distribution, where for households below the top 10%, this decrease in interest rates is actually going to lower their desire to save, and it's going to outweigh the increase in risk that they see. So low-income households are going to cut their savings, but for households in the top 10% of the income distribution, the increase in risk more than offsets the decline in interest rates, and these households are going to save more. So our model is going to generate a savings load of the rich, where high-income households are saving more and low-income households have cut their savings. So that's the economics of what's going on here.
Question, steady state.
It's a steady state. Yeah, thanks. Show you the magnitudes that are behind this. When we shift the full profile of risk, we're going to find that to clear the asset market, the risk-free rate has to decline by about 0.7 percentage points. Again, what we just saw was that in this new equilibrium, high-income households are saving more, low-income households cut their savings. That's going to amplify wealth inequality. One measure of that is the top 1% wealth share, and we're going to find that the top 1% wealth share has gone up by a little bit more than 5%. So wealth inequality. Now, these results are from shifting the whole profile of shocks. Something I've really been emphasizing today is what happens when we change risk at the top. So the last experiment I'm going to do is I'm just going to change the profile of risk for households in the top 5% of the income distribution. When we do that, we're going to find that this still has macro effects. Just changing the profile of risk for the top 5% of households, the increase in the desire to save from those households, that's still going to put downward pressure on interest rates. It's going to lower it by about 2 percentage points. And by increasing the savings of those households, that's also going to amplify wealth inequality. Just changing the risk of the top 5% phase, that's going to increase the top 1% wealth share by a little bit more than 4%. So to wrap up the paper, what we've seen is that permanent income risk has increased substantially amongst high-income households. High-income households have increased their savings in response to this, and then this has put downward pressure on interest rates, and it's amplified wealth inequality.
Thanks, Ross. Now Brenda is going to discuss.
Thank you for giving me the opportunity to discuss this paper. I'm an assistant professor in UNC Chapel Hill. I think this is a great paper, just to start with a great team of co-authors sitting right there. So let me jump right in. What is the question which this paper is trying to address? The paper is basically asking what are the aggregate consequences of rising income risk at the top. And what they do is they use IRS tax data, especially the 1040s, which are the household tax forms, and a finite life cycle quantitative model And I can think of the paper kind of summarizing in three main results. The first is that there is an increase of income risk over decades. So they compare 1970s and the 2010s. And Carter did a great job summarizing. What they find is that permanent income risk has increased across the entire distribution, especially for the top 5%. It's gone up by about 70%, which is a huge number. Second, they look more into this to evaluate whether it's really income risk. And to do this, what they do is they try to correlate the negative permanent income shocks, which they recover from the model, with financial distress indicators. And the third is that after establishing this in the empirical data, they try to look at the aggregate consequences of that. What happens to savings? They show that savings increases amongst the rich relative to the poor, risk-free rate decreases, and wealth concentration increases. So that's kind of the summary of the paper in a nutshell. I do want to mention that the model is very robust. In fact, the question which Raquel was asking, like, why is the lagged income distribution, lagged income risk really important? That actually ends up being really important in their paper. And they discuss that in the appendix, that it's required actually in the model to produce the bottom half of the distribution. Okay, so if I have to kind of connect certain like the full channel to the relative literature, what's already there. So first step is thinking about the measurement, right? So the risk rises at the top. So some of that has already been documented in the prior work. The second is the channel that think about permanent income risk affecting savings, right? I think that's the meat of the paper in my understanding. And the third is aggregation. Like, so once we've established that permanent income risk affects savings, how does this aggregate up across households and to the entire wealth distribution? And here they speak to the work by Arthur Farmer and Ludwig about savings cloud of the rich and indebted demand, and that's how they kind of connect the whole literature. So in my opinion, the contribution of this paper is kind of linking all these channels together with some of the things already established in the literature. And so what I'm going to do is I'm going to highlight the facts and sharpen the links. That's what I'm going to talk about today. The estimation procedure is already in their AER paper, so that's pretty robust. So in my opinion, again, if they can sharpen kind of the links here, I think that will help them. Okay, so what are the main comments? I think it's an extremely important paper at the intersection of inequality and financial assets. Second, I think it's an important channel which they're highlighting, which is rise of permanent income risk at the top and how that's contributing to rising wealth inequality. And so my comments are going to be along three dimensions. The first is interpreting the wealth changes. And specifically, I'll also talk about, say, asset substitution, portfolio reallocation, how that can also impact their wealth estimates. The second is sharpening the evidence on permanent and temporary income risk, which Carter talked about, the early 401k withdrawals and moving to lower income zip codes. And the third is if they can kind of conduct some more decomposition of the wealth changes to ultimately understand the drivers of this permanent income risk. Okay, so let's get into this. So let's talk about the first one. Now, the connection between the permanent income risk, savings, and wealth is driven by their capitalization factors, right? So they borrow the methodology from Eggs and co-authors' papers, where capitalization factors on taxable interest income and dividend income are computed using net returns on fixed income and C corporation wealth. And so basically, if they are given the income, if they calculated the kappa, which is the capitalization factor, they ultimately retrieve the wealth. So while they do a lot of different tests to understand the permanent income part, robust to different measures of income like wages and salaries, business income, and so on, I think the question which I was wondering when I was reading the paper is that how do you account for capital gains, partnership income, C corporation income, housing, pension, et cetera, which combined together constitute a substantial portion of the RIT's asset allocation. So here I'm talking about the wealth estimation, the wealth measures which they have, like how do these different assets play a role? And the reason why I think is important is like when I go to the SCF and I look at the data of the SCF from 2022, here on the x-axis I have different percentiles of income distribution, and on the y-axis I have percentage of total personal assets, where different colors represent different types of assets. what I see is that if I can map capitalized fixed income wealth measures into, say, deposits and bonds, which is this yellow bar, maybe also potentially this other non-financial income, most of the public companies are actually C corporations, they're not S corporations, right? So the capitalized S corporation income is, say, mapped to public equity. So this is just my guess. I'm being a little conservative here, right? I recover about 40% by just eyeballing this to the top 1%. So about 40% of the assets, total assets of the top 1% are, say, in fixed income and C corporation. The rest of them are actually in private business, housing, pension insurance, private business being one of the major ones, and they're about 60% of the assets. So this is established in Eric and co-authors' works and some of my work, and also by Fagering and co-authors for Norway, that capital income on the wealth side is an important portion for the rich. Moreover, if the paper is about changes in permanent income risk over time, these partnerships, which are different than, again, like the C corporation wealth, that has also been increasing over time. So, right, so you see these two different phenomena where permanent income risk has increased, but so has the wealth part in these non-private, non-public assets. Okay, so what does this mean for the analysis here? First, how do we think about changing financial asset composition? So what I was wondering is, oftentimes households, rich households especially, substitute away from fixed income to private assets. And especially with the growth of private assets, with low interest rates, right? This has been happening a lot. So let's think of a portfolio rebalancing channel of how this can ultimately affect the risk-free rate. Right? Think about demand for fixed income assets going down, then the remaining price-sensitive borrowers employers, have to be compensated for that extra risk which they have. So what happens is that prices go down, yields go up, right? There's an upward pressure on a term premium. So this might ultimately impact the short-term rate depending on demand and supply factors or growth or inflation. So basically, due to portfolio reallocation, the short-term rate can ultimately be affected. Yeah, I just wanted to kind of also highlight that the authors do look at capital income for the permanent income side, but here kind of we are trying to understand the wealth part. Okay, so let's look at non-private assets. So let's look at the publicly traded assets or even housing, which is not publicly traded, but like still a more normal asset for a US household compared to private assets. What we also see is that there is evidence in prior work which has documented a shift to safer assets to buffer the transitory and permanent shocks. And housing is actually one of them because it's a longer term maturity relative to the transitory and permanent shock. So again, this is speaking to the financial substitution channel, which might be going on. Aside from this, even within fixed income and public equity, there is a lot of a substitution happening, and I would encourage them to look at this paper by Xavier Gebex and co-authors. So again, so I have some suggestions here, and I think this is implementable, just to kind of at least document within asset changes. So what they can do is they can measure wealth concentration, which they already do, but have a decomposition for fixed income versus C corporation wealth. So at least this will tell me that what's driving this increase in wealth concentration. The second is try to decompose these changes, which I think are which Carter was highlighting, between within asset changes and portfolio reallocation. Again, the goal here is to understand the margin through which permanent income risk is ultimately affecting wealth shares. Now let's go to the second point within this, that even with a stable financial asset composition, right, the changes in wealth share can reflect changes in asset prices, yields, valuations. And there's substantial work in this by Matthew Gomez Emelion, and Fagering and co-authors, where they actually document the importance of asset pricing and wealth. So again, like I just kind of want to understand how this is reflected in the changes in wealth shares which they're actually capturing here. Lastly, I would be a little more conservative in interpreting the wealth shares because this is based on fixed income and C corporation capitalization factors. This is, to me, at least the wealth in liquid and tradable assets, which was also earlier discussed. It's basically a measure of liquid wealth. And I think this is also consistent with this flow interpretation of savings. So that's what I would like encourage you guys to maybe push more earlier on in the paper, that this is about liquid wealth, which is totally okay. And I think this ties well with the other savings result. Okay, so let's go to the second comment, which is about evidence for permanent and transitory income risk. So I think this is a very clever exercise which they have in the paper, in my opinion, where they correlate the recovered permanent income shocks with economic outcomes. I think the early 401k withdrawals is very clever. One thing which I would like to know here is that whether it's precautionary savings or liquidity constraints. So it can be both. I'm not sure which interpretation they want to push. I think for the paper, they want to push the precautionary savings one, but just clarifying that a little bit more. The second one, which I was a little iffy about, is move to lower income zip codes. Now, I haven't put all the papers here, but there's a substantial amount of real estate literature which talks about drivers of move to other income zip codes, like mortgages, neighborhood amenities, school districts, right, like work from home. And so what about the supply side of housing? Like now the Southeast is developing more than, is developing at a faster rate in the US. So how do we think about that? So I would be a little cautious before to use this one, or maybe have caveats around that. But this one seems pretty solid to me. I would do the same exercise for probably temporary income shocks as well with economic outcomes. So just to kind of have both in place, like temporary income risk can be health shocks, for example, or are you temporarily out of the labor force, which they can identify in the tax forms, right? So because of interruption in tax filing followed by resumption, they can kind of figure out whether it's temporary income risk or not, but they currently don't do that in the paper. They only do it for permanent income risk. Alternatively, you may also define temporary and permanent income variance from a response of income changes driven by these shocks. So you can kind of cross-check or validate your risk measure, seeing whether these changes are in response to these permanent and temporary shocks or not. Okay, how much time do I have left?
3 minutes.
Okay, perfect. Okay, lastly, I want to talk about my last comment, which is about understanding the drivers of permanent income risk. Now, what I see in the paper is that there is substantial heterogeneity in the middle to the top income distribution, right? So here I'm talking about, say, 60th percentile onwards in the changes in permanent income risk based on whether you're employed or unemployed. Now, the authors do have that as part of their model as a state variable, but probably they could use this more rigorously for the counterfactual exercises, which Carter did briefly touch upon. But also within the non-employed, now whether you're self-employed or non-self-employed, that also matters. So, right, so these are the differences in permanent income risk. These look very different to me, at least in the top half of the distribution, which is also where most of the results are coming from. And I think this is important because the economics are different, right? So if I am employed, my instability might be in labor or business income. But if I'm not employed, it might be because of work transition. It might be because I'm temporarily or maybe permanently out of the labor force, or I'm exiting a business. So I think it's important economically to also distinguish whether you're employed or unemployed, and also for the savings and wealth implications, because you might rebalance financial and business assets if you're employed, but if you're unemployed, you might just increase your precautionary savings across asset classes. So I think it's important to dig into this more. I was wondering why the coefficient on permanent income risk when you're not employed was not that significant when the changes in risk are similar, but that's something which I would ask the authors to look into. Finally, they can also link the sources of risk to within employment categories and decompose the permanent and temporary income risk changes by employment status, and most importantly, the self-employment status. That is whether you're self-non-employed or non-self non-employed, which one is driving it. Okay, so my final main comment here is I would encourage the authors to actually try to look at the interaction of the convex distribution and the permanent income changes. So currently what they have in the paper is they have a separate interaction between the permanent income risk coming from the employed, which is this one, and then they have a separate counterfactual with relaxing the convex distribution of the top of the distribution. So actually, if it's about the permanent income risk driven from the top, what you ideally want is an interaction between, say, the convex distribution, say the top 5% and the employed, and kind of show that most of the changes are coming from that. And I think this will kind of help us piece the entire mechanism of the paper together. Okay, I'll leave the other comments because I'm out of time, but I think overall this is a very, very important and interesting paper. They just need to sharpen the interpretation, talk about some other channels, unpack the counterfactuals, and I think it's a great read. Thank you so much.
All right, question?
I was wondering if you thought about the implications of your finding for the wealth distribution. So the Bueller-Garry-Haggett model are notorious for, without any additional features, not being able to replicate the heavy tail of the wealth distribution. And what you're finding that the richer, higher income consumers face more income risk potentially can contribute to generating heavy tail of the wealth distribution.
You've shown that like the risk is actually associated with bad shocks. Are they also becoming more frequent recently? Like consistent with the increase in income risk? Like, is the income risk is more about the like left tail, the rising
Gotcha. Yeah.
So yeah.
Okay.
So I remember estimating like income processes with Shettle and Gianluca, and we didn't have this great administrative data that you had, and but we were finding kind of increases in the variance of shocks over time. And then I remember Fatih Gulbinan had a series of papers. He was arguing this rise in risk was sort of a myth, and once you looked at high quality administrative data, you didn't see it. So I'm a little bit out of date on that, but it seems like it's come back in your data. So I'd be curious to hear.
Sure.
I have a comment about your wealth inequality of the top 1% hold only about 11%. I'm just wondering, you start from a data that covers the whole US economy from the tax return and somehow, so you should have all the top 1% of the income distribution and somehow you still feel short of the wealth distribution. I wonder whether it's because once you match with CPS, you somehow lose the top high income people or something else going on in your model. So is it the paper about the top 1% of the CPS sample or is it about the whole economy? That's my question.
I have a clarification or a question. If I understood well, you seem to suggest that if you just consider the wage income, the results would be very similar in the sense that you would observe this increase in permanent risk in the tail. But then this would seem to suggest that most of the risk is actually the wage or income and not the capital gain and the business income, which for the top 1% is a sizable part of the income and has been increasing over time. So I'm just wondering, like, how do you think about this and how do you square these two up, these two information up? Thanks a lot. Very, very interesting paper.
Yeah, wonderful paper. I was also curious if you guys were exploiting some differences in occupation risk, and I was curious if there's trends or differences in the occupation risk too that would help us understand sort of the drivers of this aggregate change, as Vrinda pointed out.
Can you talk a little bit about tax deferred savings?
And then for the risk versus choice and the zip code stuff, I guess there could be you choose to move to a low income zip and then your income ends up being lower. I was wondering if you could look at maybe you move after, rather than T-5 to T, do T to T+5 on the move. So it is after the income loss.
Great. Okay. All right. So first, thanks for a great discussion. And if we have time, I'll maybe say a few things about that. But to go to the questions. So the first question was about the wealth distribution and can the convexity, or as I interpret it, can the convexity and permanent income risk help us match the wealth distribution better? So in that experiment where I showed convexity mattered for saving rates at the top, something we also show in the paper, and I had the button, was what does this mean for wealth concentration? So if you remove the convexity, that would lower our top 1% wealth share by about 2.5 percentage points. So it does matter. It's not going to, and I think this relates to Feng's question. Our model is not going to get all of the wealth concentration we see in the data. Our model number is 11.5%. The number in the SCF for the 1970s is like 18.6%. So we are still short. And if you want to match that number, you need to add in some other things like return heterogeneity and things that are in the literature. But if you remove the convexity, we'd go from 11.5 to about 9. And then, in the paper, we have a long discussion at that point. The second question was from Serdar, and that was about when we look at the shocks. It seems when this didn't make it into the paper, but we did examine kind of the symmetry of the shocks in the tax data, and it appears to be pretty symmetric. If I'm remembering what we saw down there correctly, it has more to do about the probability of having a 30% decline has been pretty stable over time, but now conditional on having that large decline, if you have a 30% loss or larger, it is now on average a larger shock than it used to be. So that's really where the action's happening, and it is pretty symmetric. So that makes us feel okay with rolling with normal distributions. Jonathan, I think your question was about how does this all relate to kind of the micro moderation debate. So, our AER paper, really kind of tried to tackle this head on. And so what Fatih showed was that the variance of 1-year income changes has been declining over time. We showed that as well in our AER paper, which depended upon W-2 data. But what we also showed in that paper is that as you start to look at longer horizons, like a 5-year horizon, you start to see an increase in the profile. What we show in this paper is that if you look at a 5-year horizon of these, 1040 changes using household income going further back in time, it is flat to slightly declining, which would kind of line up with Fatih. But then when you look at the 10-year change, which is more informative about permanent risk, that's what's really taking off. So I think what Fatih was picking up is this 1-year change, which is dominated by transitory risk. And that was what our AER paper kind of landed on, is that transitory risk is down since 1980. This paper starting in 1970, so a little bit different time period, but permanent risk is up. And then in this paper, we can really go into the top tail and see what's going on with them. Serdar, I saw your hand.
Yeah, long term, it could also be beta, right? Like if you are looking at 10 years, that could also explain the beta differences.
You're thinking about like a HIP?
Yeah, right? Again,
Yeah. So I mean, the cool thing with Coleman is, the method we have here is that HIP works. We can do HIP. We haven't done it, and we can go there if we want. Okay, so I think the next question was, I wrote down wage and income decomposition, but I don't remember about that one.
So there was a question about the CPS sample versus the population, and we basically did most of this stuff. We use the CPS to get some extra color to use occupation variation. But if you do this in a 2% random sample, you get the same pictures. Yeah. So yes, we don't think that's a very limiting factor. It's just more that the CPS gives us extra context, which is kind of nice.
Yeah. And then Kunal, I think you asked about the role of occupation. So something I kind of hoped was that we could find a smoking gun by looking at the change in the occupation structure over time. I kind of had this prior that like the 1970s, if you wanted to get the top 1%, it was going to become a doctor or a lawyer, and now you need to work in finance. It turns out that is not true. Like even looking in the ACS, the occupation as well as industry composition of that top 1% even the top 5%, it's been actually pretty stable. Something we also show in the paper is that we can do all of this ranking within occupation, and you get effectively the same number. So I'd hoped there would be something there. I don't think there's a ton. And then to the question on moving, we can definitely vary the timing. Something that I found reassuring is that, another thing we can do is like, what is it, we can also look at people that are moving to higher income neighborhoods. And so if you get a large positive shock, you become more likely to move to a higher income neighborhood as well. So it kind of moves the way you want. Something that didn't make it into the slides or the paper, but should, is we've done everything I showed today was a permanent shock. You can do this all again with our filtered estimates of transitory risk. The magnitudes are quite a bit lower. And so we tried to think of things like, it's going to take I would think something permanent to make you take on the penalty of pulling money out of your 401k, moving you and your kids to a worse neighborhood. So a transitory shock probably shouldn't do that. But we see that in the data, and that can make it into the next round.
If I could jump in on something that kind of ties two of the questions together, there's sort of the wealth how does this relate to wealth inequality and the occupation variation? I mean, what we found in the AER paper is there is some heterogeneity across occupations in terms of who's most affected. And it's like, kind of human capital intensive type jobs where this risk is going up. And you also see kind of more educated people also face a lot more risk. And kind of one way to sort of square a lot of this is that what we're finding is almost a smoother version of the idea that's in the Castaneda et al. Paper, where they had this awesome income state, right? And obviously if you do a 5-point process, that's like stylized, right? But the world looks kind of like a smoother version of that, where if you think about the higher up you go into a building, the more the wind moves the building around. And I think it just becomes more fragile at the top. So even if you're thinking about, I don't know, surgeons, right? Like someone with fairly stable income, if you compare someone who's at the 75th percentile, that person is doing lots of different types of surgeries. Someone who's at the top 1% is doing a very specialized kind of operation. And if things change, they might be hammered, right? That's why it kind of, the losses from, if people fall, they fall really far. This is all kind of consistent with a model that looks like that. So like imagine you had an assignment type model, like Gabek-Slandier, where sort of your rank in the cross-sectional distribution is sort of moving around at the same rate. So kind of the rank correlation is the same. But now that distribution is more spread out. Well, then naturally you're going to have basically income inequality is going to go up. That's one of the things we talked about. But then also your upside goes up and your downside goes up. And it just really looks kind of like that's the world that we live in now. And those models naturally have the strongest nonlinearity at the very top. And so why are people saving so much? Well, we often will kind of put wealth directly in the utility function, especially if you want to get young people to save. Because, if you're 30 in a model, death is still pretty far off. It's not going to do a lot. But this force, when most of your wealth is in human capital, is actually going to get everybody to save a lot more at the top, right? And so this is something that kind of helps explain why the human capital rich younger households save a lot more, because you kind of know you're not necessarily going to have 40 years of smooth sailing ahead of you. Like the people who are getting these $10 million paydays from AI firms right now, do they think they're going to get that every year for the rest of their life? I'm not sure, right? And since I'm not sure, I'm probably going to save a lot more than someone kind of at the median.
All right, let's we'll take a 10-minute break and we'll be back at 4:40.
Good job. All right. Thanks, boys. Yeah.
Probably just gonna power through.
Much better. That's the most exactly.
You presented this paper. And then I don't. So I can check.
matches my intuition, but I've seen remarkably little
I know.
for showing. And I do have questions.
I know.
Do they have to do anything?
In your mind, we have we'll have seminars, so I'm like, but this someone also seminars. I'm considered wise. We invited you, Jonathan. So we have campaign for whole year, including flights and everything, and I think we still dare to invite more, but then we are running out of money and we use our reserve fund, so. I think we should have caps about flights, because without having caps on flights, can be anything, so I can really plan in August, especially now. Yeah, I thought. I'm going to how long in August? How much? 1,000. Okay, no, 1,000, okay, if from, yeah. So one speaker without flight is $500 because restaurant prices is amazing, and hotel we have very cheap 140, but and my colleagues don't want to put caps on flight, and I'm like, it's my son. Yeah, like I tried to do on the first year when I went there, like that, and speakers understood. Yeah. But then my colleagues did not want to ask their editor, so I was like, I thought what I look like. I'm the only one. Exactly, I'm like, my guess you have to pay. And I think we all agree now that something that.
Even just, I mean, this is like, you can get leaker, you don't want any time that, especially in down history. You get the extent of genetic connection, construct migration matrix out of a guy in the steppe in 3,000 BC, but then, where yeah, well, I'll send you that.
Alright, so guys.
Just one announcement before work starts, we're going to the Lexington, if you missed us in the lobby and you've signed up and paid, you're welcome to come. There's one of you that I'm missing, and I forget who that is, so please, if you want to come, please come see me very quickly. That's it, it's gonna rain, if I were you, I would grab an umbrella before everyone else does from the Royal Sonesta. Sorry?
Yes.
Yeah, good luck, but, okay, Michael.
Great, so thanks so much. We got our last talk of the day. Marco is going to present ecological imperialism, and please take it away.
Thank you. Thank you very much for including the paper in the program. This is joint work with Alessandra Nicolò, who's about to start her PhD at Berkeley, and with Charles Taylor, who's here as well. And so the motivation is that since 1500, millions of Europeans settled overseas, though with very different degrees. In some parts of the world, individuals of European descent became dominant demographically, in others they remained a tiny fraction. As of 2000, there are about 580 million individuals whose 1,500 ancestors were Europeans living outside of Europe, as compared to about 690 million Europeans in Europe. And this figure was produced using some of David's data and shows you some examples of the aggregate numbers that I gave you. Portugal stands out as a clear striking case. So what this figure is telling you is that in Portugal, as of 2000, for every individual with an ancestor living in Portugal in 1500, there are 10 individuals of Portuguese 1500 ancestry living outside of Portugal. Other examples here on the figure, like Ireland, Spain, the UK, make similar points, though less extreme. And so the question is, what explains where Europeans settled outside of Europe? And I
one of the historically anecdotal point that is made is that of climate similarity. And this is a quote from Sir Ferdinando Gorges in 1622. He was one of the proprietors of the Plymouth colony in New England. And he was stressing how, in trying to convince people to move to New England, how New England was more suitable to the nature of our people, who neither find content in the colder climates nor health in the hotter. And in an influential book, Alfred Crosby argued that one of the reasons that explains why Europeans succeeded demographically where they did was the ecological compatibility between the conditions in Europe and those in these overseas territories. And so in a nutshell, the idea is that durable European settler societies emerged in overseas places where Europeans wanted to go, where they could survive and reproduce over generations, and where their crops, livestock, and the farming system, what Crosby defines the portmanteau biota, could take root. And there are many anecdotal examples that I guess come to mind for the US. One is that of the Swedes in Minnesota and the upper Midwest. I guess it'd be hard for you to tell me which is Sweden and which is Minnesota in this picture. Both are characterized by boreal forests, glacial lakes, and marsh edges, similar soil types. And Charles and I, together with Margaret Obolensky, we have a paper that for the US context documents systematic climate matching in migration after 1850, but there are many other examples from around the world that you can think of, the Scots in New Zealand, the Italians in the Pampas in Argentina, and so on and so forth. And so the paper really tries to test the hypothesis that was formulated by Crosby, and we measure ecological distance between settlers' origin and the overseas destination over temperature, precipitation, and agronomic conditions. We use genealogical records on about 300,000 individuals who were born in Europe between 1500 and 1850 and who died overseas. And then we ask three questions. The first one is whether ecological distance indeed predicts where the Europeans settled. And to answer this question, we aggregate these genealogical records to the origin, destination, birth cohort period, where origin and destinations are going to be 1 degree cells. And we estimate bilateral gravity regressions relating settler flows to the ecological distance. And the design allows us to absorb shocks that are specific to the country of origin of the settlers and the subnational region equivalent to the US state, to give you an idea, of destination. The second question is whether ecological distance affects the demographic viability of the settlers. Here we estimate individual level regressions, where the thought experiment is basically we compare the longevity and the fertility of individuals born in the same country in the same period who died in different parts of the destination region. And then we fast forward to today, and we ask whether there's a relationship between the ecological distance defined over in this like temperature, precipitation, agronomic suitability of the settlers of a territory and long-run development today. These are going to be cross-sectional regressions, so you should interpret them as such. We control for country fixed effects. So effectively, we are comparing parts of the same country settled by different farther versus closer ecologically settlers, and ask whether in terms of long-run development we see differences. To give you a preview of the results, we find that both temperature and agronomic distance reduce settlement. So increasing temperature distance by 5 degrees Celsius, which is in the order of the difference between Buenos Aires and London, reduces migration by about 40%. And here, when I talk about migration throughout the talk, you should think about this permanent settlement. Okay, so sometimes I'll refer to migration. And increasing agronomic distance by 1 standard deviation, I will tell you about how we construct this measure later, reduces migration by also roughly 40%. We can decompose the migration deterrence effect of the temperature distance, and this is driven by colder destinations. Okay, so it's really that the Europeans avoid
avoided the colder parts of the countries that they settled relative to where they were coming from. Then we find that temperature distance reduces both longevity and fertility of the settlers, whereas agronomic distance does not have any effect. So in this case, and I think there's an interesting asymmetry, what seems to drive the effect is moving to hotter destinations. Okay? So exposed, there's this effect on the settlers. And then we find a negative relationship between the ecological distance of the settlers and today's development. This holds for agricultural production, both for temperature distance and agronomic distance. For temperature distance, this relationship extends to a broader proxy for development, which is nightline luminosity. So, kind of taken together, we think these results are consistent with Crosby's hypothesis. Ecology shaped the reach and the success of the settlers, and temperature. Our interpretation of these results is that it works through physiology and has a broader impact on both settlements and long-run development, whereas agronomic distance works much more directly through the production system, and so affects agriculture but less the bodies. So we think this is the first systematic individual level evidence in support of Crosby's hypothesis, and in providing this evidence we contribute to, I think, a gigantic literature on the colonial origins and long-run development, and we show relative to this literature that ecology shaped where the Europeans settled and how persistent and these settlements were. And we trace correlations of the ecological match of these settlements to long-run development. Today, finally, there's a literature that has linked agroclimatic skills to migration, and more recently, Charles and I are writing a few papers on climate matching in migration across context. Raquel? Yes.
I didn't get the long-run development.
Well, we find a negative relationship between.
Theory. Like in a statement about why it would be true.
Sorry, the why.
Could it be that where you're more demographically successful as European migrants? Why would that be?
Oh, sorry. So there's a literature like History and Levine, for example, right? That shows that the places with larger European populations are today, like the European settlers are today richer. So there's one part which, if you want, we kind of provide a micro foundation for where these European settlements were.
You're not going to have a mechanism for long-run development.
We are not. We are going to, this is actually something that Charles and I are planning to, as kind of potentially a separate agenda. I think this is very interesting. In this paper, we are going to focus mostly on Crosby's idea, which is that the places where the ecological distance was lower, the production system of Europeans could be more easily replicated, and that contributes to long-run development. But I think there's and I think some of our results suggested there may be also another mechanism which runs through institutions. So if you take Acemoglu, Johnson, Robinson, colonial settlers mortality, you can apply the same logic with our data. So I think that's something we don't directly get into in this paper, but that's something we're thinking about for the future. Okay, so in one slide, let me give you a little more details about Crosby's hypothesis. So this is a quote from the book, and Crosby's writing, the prospective settlement had to be placed where the land and climate were similar to those in some part of Europe, and sufficiently removed from the old world to limit exposure to predators and pathogens adapted to European species. And so European success depended on whether a place was advantageous to European organism. And one important idea in Crosby's book is this notion of portmanteau-biota, the European crops, livestock, weeds, and pathogens. And so in temperate settings, the grains and the animals could flourish, displacing native species, and the natives were themselves more exposed to the European pathogens that could travel fast, whereas in tropical environments, the crops failed and the settlers themselves faced diseases. And this idea of disease and environment and ecology was something that was important to people back in the days. This is a picture, two pictures on a questionnaire that was commissioned by the kingdoms, by Spain, across the Latin American and Central American territories, where basically there were several questions about the climate, the ecology. So here there were about 50 of these questions, and here are just 3 examples. One of these questions would ask to state the climate and quality of the province and whether it was cold or hot, dry or damp. Another question would ask whether the town was situated in a helpful or unhelpful place. And the third one asked to describe the animals, including those that were introduced from Spain, and how well they breed and multiply. So to answer this question, we use genealogical records. These come from FamilyLinks, which is a population scale family tree with about 13 million linked individuals. And these data allow us to measure birth and death dates, locations, gender, and kinship ties. After a series of cleaning steps, which I'm happy to discuss maybe later if there are questions, we are left with about 300,000 individuals who are born in Europe between 1500 and 1850 and who died in overseas territories. And it's interesting that these records span both the standard colonial powers that you can think of, Britain, Spain, Portugal, but also major emigration countries like Ireland, Norway, Sweden, and so on. This is a map that shows you the origin, the subnational origins within Europe of these settlers. And the point that I would like you to take away is that there's substantial variation across European countries, but also within countries. And this is going to be ultimately the variation that we are exploiting in the regressions. And these are just plotting, and these data I think are fascinating. Here I'm just plotting some maps. I don't know if yeah, you don't see the word, but you can imagine that there is a word behind it. For different sending countries, the Spanish and Portuguese settlers mostly moved to Central and Latin America, whereas for Great Britain, for example, there's a much wider reach. And this is how the data look like in terms of what the distribution of the European settlers in our data look like between 1500 and 1850. The US is, of course, overrepresented, if you will, but the geography is pretty wide and it overlaps with what we know about European settlement. Now, one question that you may have is how representative these data are relative to kind of the underground, the ground truth of the actual number, because of course these are user submitted records. And so we try to validate them in a couple of ways. Here we are correlating the European population stock in 1900 taken from Easterly and Levin at the country level with our records aggregated at the country level as well. And you can see that there's a pretty strong correlation with a coefficient of about 0.67. And this holds when you drop the 4 big neo-Europes, which are Canada, the US, New Zealand, and Australia. Another way to validate the data is to compare our records to those compiled recently by a working paper by Arroyo Abad and Espin Sanchez. This paper put together what I think is the most comprehensive list of migrants from Spain to the Southern and Central America. between like the end of the 15th century and the 16th century. And the top panel is our data. The bottom is what we took from their paper. So we don't have their data, but we took a screenshot. And you can see that the number of migrants in our data kind of tracks theirs. You will see that the peak in their data is kind of happens about 25, 30 years after what we see in our data, which makes sense because in our data we observe year of birth, whereas for them is year of migration. And then the map shows you the distribution of the migrants within Spain, and the two sources seem to be similar in terms of like the geography you see there. Now, the next ingredient in the analysis is going to be different proxies for ecological distance. And we're going to use three main variables. The first is temperature. And for all these three variables, we're going to basically calculate the distance. So it's going to be, for temperature and precipitation, is going to be the absolute difference in the temperature and the precipitation in the origin cell versus the destination cell. And we think temperature is kind of you can think about it as a sufficient statistic. It matters for crop phenology, for frost, livestock, of course, tropical disease, and so on. Precipitation might instead matter because of the rain-fed crops for pasture and livestock. Whereas agronomic distance captures, which we calculate over three main tables, grain, olive, and grass. This really captures the notion of the portmanteau biota, this transmission of the farming system, European farming system. This is a map with our climate data, with temperature. In the baseline, the way in which we measure this is over the 1960 to 2000 period. We take the average. The results are similar if you use different time periods, including if you use historical reconstructions, which are much noisier. And we aggregate this to the 1 by 1 degree grid. So let me give you an example of what this means in practice. So take three cities, Seville, London, and Buenos Aires. The temperature distance between Seville and Buenos Aires is about 1.5 degrees Celsius. That between London and Buenos Aires is about 6.5. This is the map for Argentina. And I'm plotting the distance from Seville. And on the right-hand side of the screen, you see instead the settlers from Spain in our data. And if you eyeball this, it looks like indeed there's the settlements seem to track the places where the temperature distance is lower. To give you another example, at the bottom here, instead I'm showing you the temperature distance from London and then the settlers from Great Britain. You see that the temperature distance in the case of Seville and that of London varies substantially, and this is going to be one of the factors we exploit. And then if you zoom in on another context, for example, in Colombia, again, you can do something similar. You can calculate the temperature distance from each cell in Colombia to Madrid. And on the right-hand side of the slide, you see again the settlements, and they track very nicely, I think, the temperature distance. They concentrate in Bogota, whereas they are almost absent in Cartagena. And you can do, again, last map, almost, with now London again as a distance. This is a map with Australia, and again, the temperature distance and the settlers, and you see this association yet again. This is just instead a map of the agronomic distance, which is going to be our additional measure, and it's calculated as an origin-weighted Euclidean distance across grain, olive, and grass, and then is standardized, so that higher values mean a larger distance in terms of agronomic conditions. Okay, so then we aggregate these genealogical records to the origin-destination period level, where for us the period is going to be the birth cohort over 50 years. And we estimate a standard gravity model. We estimate it with PPML because, of course, these are like the migration matrix is extremely sparse. And the outcome is going to be the number of settlers born in origin cell O in a given period who died in destination D. The key regressor of interests are going to be the distance over temperature and precipitation, which are this climate vector, and the agronomic distance. We are separately controlling for log of geographic distance. The functional form doesn't matter. And then we add a vector of destination level controls that such as absolute latitude, temperature, beans, precipitation, malaria ecology, and so on. And the inclusion of these origin country by period and destination subnational region by period fixed effects is these fixed effects are absorbing time varying push and pull shocks that you may worry are correlated with both migration and distances. And so the experiment you should have in mind is you are comparing the number of settlers from Madrid versus Seville settling within different parts of Argentina. We cluster standard errors at the country of origin by the 2-degree cell of destination, and Crosby's hypothesis is that beta and gamma should be negative, namely that ecological distance should reduce permanent settlement. And this table shows you the results, and these are consistent with Crosby's hypothesis. Here I'm starting with a very parsimonious specification that only includes the ecological distances and geographic distance, and all the three ecological distances have negative and statistically significant coefficients. You can add period fixed effects, country of origin fixed effects, and country of destination fixed effects, and the results remain similar. Then we interact period fixed effects with the country of origin fixed effects and period fixed effects with the destination region fixed effects. And finally, we include also the destination level controls. The coefficients on temperature and agronomic distance remain negative and statistically significant. And as I said at the very beginning, the magnitudes associated with these numbers are, for example, if you take the temperature distance, increasing temperature distance by 5 degrees reduces settlers by 40%. This is incidentally pretty much the same number you get by increasing the agronomic distance by 1 standard deviation. Just for reference, the standard deviation of the temperature distance, which is not here, is about 6.5 degrees. Instead, we find less robust effects of precipitation distance, and this is something that in other works with Charles we also found. And these are just the graphical analog. I will go quickly because in the interest of time, but this is just take the preferred specification and look at the beam scatter behind the estimates for temperature distance and agronomic distance in the two panels. And here, I'm instead decomposing the effects of temperature distance separately now by temperature difference, right? And so what this figure shows you is that what really deters migration is the colder, and so here the hot means it's hotter relative to the origin, cold is colder relative to the origin. Migration goes down when temperature is colder. And in the paper, we discuss a number of robustness checks. In the interest of time, I think we are fairly confident these results are fairly robust. In the interest of time, let me move to the demographic viability part. So here we focus on two indicators of demographic success. One is age at death, which is observed for almost all the settlers. The other one is completed fertility. This is available we only observe the positive numbers, so we don't know whether the zeros are real zeros or people who did not report. We estimate a very similar regression as before, except that now this is individual level, and the outcome is one of these two, like the number of children or the age at death. And identification here comes from comparing settlers in the same region and era who come from different origins within the same European country. Right? And again, so it's Madrid versus Seville born settlers who died in the same region of Argentina. There are three caveats that you should keep in mind when interpreting the results. The first is that there may be selection into climate matching, so we can't rule out the possibility that the wealthier and healthier migrants, to begin with, move to places with from the same country, move to places within the same destination that are a better match. The second issue is what I mentioned about childlessness versus unrecorded children. And then there's a third consideration that is, if it by construction, here we are removing the return migrants, right? So if those who have the most to lose demographically from staying in a very different climate, and if these are those who go back, then we are estimating a lower bound. So with these considerations in mind, here I'm showing you the results for, again, a relatively parsimonious regression. Temperature distance has a negative and statistically significant coefficient. For agronomic distance, we find instead positive, and if anything, like statistically imprecise. When we control for more variables and fixed effects, the agronomic distance coefficient remains unstable. The coefficient on temperature distance attenuates substantially. It remains statistically significant at the 10% level. In terms of magnitude, if you increase temperature distance by 5 degrees Celsius, that reduces age at death by about 164 days of life. Whereas, as I said, agronomic distance has no meaningful effect on age at death. How am I doing in time?
7 minutes.
Perfect. And here the outcome is the number of children. The results are similar, so there's a negative and statistically significant coefficient on temperature distance, no robust association with agronomic distance. And then we can do again the decomposition that we did earlier for migration, now for age at death, and the picture is almost kind of reversed. So now you see that there's a penalty for mismatched individuals in the hotter direction, and a similar, though somewhat less stark pattern for the number of children. So kind of taking stock before moving to the long run analysis, the settlement and demographic outcomes have this asymmetric picture. The cold temperature distance reduces settlement ex ante, but has limited effects on those who arrive, whereas for hot, there's weak deterrence, but large demographic cost exposed. And the picture that emerges is you see both destination selection effects and outcomes conditional on arrival. The two margins, temperature and agronomic distance, likely acted on different margins. So agronomic distance shaped where Europeans settled and not necessarily how they fared, whereas temperature distance seemed to have affected both settlement and the demographic success. So in the remaining few minutes, I'm going to now ask whether ecological distance affects development, and kind of partly answering Raquel's question earlier. We have one mechanism in mind here, though I think there are others that we would like to explore in the future. And here, the mechanism that we want to try to shed light on is Crosby's idea that where climate matched, the settlers could transplant their portmanteau biota, and so that's where the neo-Europes became temperate replicas of Europe. So the idea is that when ecological distance increases, that makes it harder to transplant European farming, which might be associated with lower agricultural output today. We test this idea with two gridded data sets, one directly measuring agricultural GDP, in 2010, and the other instead, we are interested in broader development using nighttime luminosity. So what we do is that for each 1 degree destination cell, we calculate a weighted average of the ecological distance of the European settlers with weights equal to the share of migrants from a given origin relative to all the migrants in that destination. Okay? And so you should think of this as capturing the composition and not really the scale of the European settlers. And then we estimate cross-sectional regressions relating long-term outcomes to this. This is so exactly. So this is here we're taking the full 1500 to 1850.
So the argument is that the Europeans were more advanced in the 1500s as well as the places that. Yeah.
I guess yes, and the idea is that the European technologies in those 300 years were more advanced than those of the places where they settled. And then we relate these present day outcomes to these average distances. We control for country fixed effects and the same vector of historical and geographic variables I mentioned earlier. And so the obvious caveat is that we don't have exogenous variation in settlers' ecological distance. These are cross-sectional regressions, which we still think are interesting to look at. So here I'm showing you the bin scatter equivalent of the regressions. The outcome is the log of agricultural GDP, and the two panels report the relationship with temperature distance residualized and with agronomic distance. And in both cases, there's a negative relationship between the two, namely in places where the Europeans had a higher ecological temperature and agronomic distance, the agricultural GDP is lower. Oh, sorry, I'm going back. You can, yes, Raquel?
No, I mean, you can take it later. My feeling is that it's a rather different argument to say that, there was no cows in the United States and there was no cows in Latin America. And they bring over cows, and cows are very productive to have. It's not necessarily an advanced technology. They're bringing over animals that are.
Yes, fair enough.
I just want to.
I think it's both. I think it's both. I think it's both. It's true that it's animals, but I think it's also techniques. It's both. Right. Yeah. Yes, absolutely. I agree 100%. And this is exactly the point that Crosby makes, is that the cows are thriving in some environments and not in others, and the Europeans succeed where the cows thrive and not where they don't thrive. Yes. And we can talk about the mechanisms as well. Like we don't have any evidence on the mechanisms. Here, what you see, which I think is also an interesting contrast, is that we can look at the relationship between luminosity and temperature and agronomic distance, and the temperature distance relationship still remains negative, whereas for agronomic distance this is flat, which suggests that agronomic distance likely operates mostly through agriculture. And I think I'm out of time, right? Yeah. So to conclude, this is the first test of Crosby's hypothesis. We find that temperature and agronomic distance affect settlers' geography, that temperature distance shortened life and reduced fertility, and we see a negative relationship between ecological distance of the settlers and development today. Thank you very much.
David Wyeth from Discuss.
Okay, thank you. So first, thanks to the organizers for having me discuss. Just need the clicker. Oh, right, thanks. For having me discuss. This is a really interesting paper, really creative, really exciting data, and it's on stuff that I love and I'm super interested in. So I'm very, very happy to discuss it. And secondly, I want to thank the authors, because this is really kind of the Bureau at its best. I was reading this on Sunday, writing my remarks, and I had a bunch of questions, and I emailed them, and they got back to me Monday, despite some like big sports thing. And I tried to incorporate. And so I incorporated that, and I think it's just really a great model of sort of intellectual progress. Okay, so what are the hypotheses being addressed here? So where did Europeans migrate? Where were they demographically successful in the sense that their populations expanded? And what does that have to do with sort of long-run success of those places where they migrated? And so we have these three hypotheses floating around. The first two are kind of straight from Crosby, that ecological compatibility determined where migrants went. Migrants wanted to go where they were compatible. that compatibility shaped demographic success. And then the third, which I think of as sort of Crosby and sort of the authors themselves, the thing Raquel was asking about, which is that ecological compatibility of the early migrants 115 or more years ago affects the level of economic development today. There are, of course, a bunch of competing hypotheses in this space, and I've kind of just, listed them here. There's a kind of AJR, Engerman, and Sokoloff focus on the availability of native populations that could be exploited or valuable minerals or commodities as a driver of European migration. There's the Easterly Levine story about sort of some crops being more prone to slavery and some not. And then also AJR's focus on the health environment, which is sort of what this paper is about, although AJR are more sort of just about like tropics bad rather than kind of mismatch bad. And that's all fine. This paper is not really about sorting that out. It's really kind of about establishing in a t-statistic sense that when I hold those other things constant, the Crosby thing is still important. Some later paper could then sort of sort out quantitatively which of these were more important. As Marco said, it's totally, totally cool data. So they had this genealogical data where you can track almost 300,000 individuals who were born in Europe and they die in one of these ex-colonies from these genealogical records. We know their birth location, their death location, the age of death, number of children. There's this really interesting sample selection issue that I'm going to come back to a couple of times, which is that the data greatly overrepresent migration. They greatly overrepresent people who migrate early. And so we're going to see that with sort of like English people who migrated to like here, relative to, say, Irish people who also migrated to here. And we saw that a little in the picture Marco showed about Spain. And here I just kind of gave, an example, which I won't even go through. That got me puzzled for a while. And then, I kind of had my duh moment that, of course, the early arriving people, they have more descendants. And you get into this data set by having one of your descendants put you in the data set. So people who came a long time ago, they have a lot of descendants, and so they're just more likely to get into the data set. Okay, and then there's excellent fine-scale geographic data on climates and crops and stuff like that. And I'm not going to take you through much of the results at all, but sort of here are the hypotheses and how they're tested. So to test sort of whether compatibility determined where migrants went, they're going to regress counts of migrants in a grid square on measures of the ecological, they're going to regress counts of migrants from a grid square to a grid square on measures of ecological mismatch between those two grid squares. And they're going to find that higher mismatch reduces the number of migrants. To test the demographic success theory, they're going to regress the age of death or the number of children on the mismatch now at the individual level. So you came from somewhere in Spain, you moved to somewhere in Argentina, there's some degree of mismatch. That's going to affect how long you live and how many children you have. And so higher mismatch lowers demographic success. And then to test this sort of long run theory, they're going to regress luminosity and agricultural GDP on grid cell average degree of mismatch among the European migrants. And they find that higher mismatch lowers those outcomes. Marco showed you these two pictures. They're really cool. This is sort of this finding about temperature asymmetry. So if we look at migration flows, being hotter than what you're used to actually doesn't dissuade you from migrating, but being colder does. And then if we look at mortality, it goes the other way. The only thing I would say about this is just in the way the paper is pitched, you sort of say like, we find that temperature distance matters. And then later as a nuance, you say, well, actually it's asymmetric. And I think I would just not say the first thing, because kind of the second thing is really what the data is saying. Okay, so I'm going to talk some about some inference worries, and then I'm going to talk about some theoretical issues. There is the standard inference worry about non-random assignment, and the authors are very good about flailing themselves on this. So, there's demographic mismatch. It would be ideal if the identifying variation was somehow random, but it's not. So should we worry that folks who went to places where they had a mismatch were systematically different? I thought about this a lot. I can't come up with like kind of terrible biases that this introduces. So I'm just going to kind of give you a pass on that. But thank you for mentioning it. I have some other worries. So this is a fun one. So the climate measures they use are all annual averages of temperature and precipitation. Averages are nice, but we should care about second moments as well. And in the case of the kind of Europeans coming, especially to the Americas, that's a big issue. So here's kind of London versus Boston. So this is daily highs and lows in London by month, and this is the same thing in Boston. And the dashed lines are perceived temperatures, and then there's snow on bottom. So London and Boston have relatively similar averages, but they're way different, and it's way better there than here. It's kind of a hellscape over here. And so that's the thing that one has to think about. The next one I spent a lot more time thinking about, and this is where the authors really helped me a lot. So this is specific to table 1, where they're looking at migration flows. So again, the migration flows, they're estimating the observations are source cell times grid times destination cells times period. So there are 15 million of those observations, but only 300,000 European settlers. So almost all of those are zero. Only 0.4% are non-zero. Okay, that's fine. This Poisson pseudo maximum likelihood estimation that they use in trade a lot is good with zeros. So that's not a problem per se. But it's still going to be an issue, sort of which of these pairs of sources and destinations are driving the estimation. And I love this picture. You might think it has to do with Spaniards in Australia. And so there they are, the 5 of them in the whole continent. I don't know who this person was and how they died in the middle of Australia. They're going to get washed out by fixed effects anyway. But so that they're not doing much. Okay. But here's the issue. Here's kind of the econometric part. So in table 1, the dependent variable is the counts of migrants in an observation, whereas I said an observation is a source cell, source grid cell times destination grid cell times period. Okay, so that's like the number of people born in Dublin in those years, 1800 to 1850, who died in New York City. The Poisson pseudo maximum likelihood estimation minimizes absolute errors. So that is, it minimizes the sum across the whole sample of the difference between the actual count in a grid cell, the actual count in an observation, and the fitted count in an observation. Not percentage errors, which is what you would get if you were doing like log linear OLS, but of course you can't do log linear OLS because there are all these zeros there. And the PPML coefficients are elasticities. So it says that, this thing, a temperature gap of so much, has such and such percentage effect on the fitted value. Okay, so they're elasticities. And what that means, those two things that I just said put together, is that observations with high counts are the ones that are going to drive the estimated coefficients. And so this is what we had some back and forth about this. I'm worried that like a few large observations, and I'll show you some observations in a second, might be driving the whole thing. And so I wrote to them, and they got back to me with all sorts of super interesting data. So this is the distribution just among the positive cells. That's really what we care about. So there are 58,000 observations where there's a positive count of migrants. And here you can see the distribution. And, up through P90, there's only 8 migrants. And then kind of when we get to the top, there are hundreds. You can look at it that way. You can look at it this way, where you sort of see the fraction of migrants who are in the top 10 through top 1,000 cells. That's in some ways less indicative because, as I said, what really matters here is the big cells and kind of this PPML procedure trying to avoid big errors. Thank you. So they sent me the actual cells, and I burned a whole lot of yesterday looking at this because it was just so fascinating. I had my Google Maps, and I was making boxes on the screen. So I don't know how well you can see things, but this is the top 32 cells, origin, destination, period cells. And lo and behold, almost all of them are people from Great Britain going to the United States. Here you see the largest ones are people going from London to right where we are here in the Boston, Providence, New Bedford area. And you can see, these are all London because they have longitudes that are really near zero. And then you can find some Dutch people going to New York. Later on, there's some Dutch people going to the Hudson Valley, and then France finally makes it number 32 with people going to Quebec. As I observe here, inevitably the largest counts are going to be to cities and from cities. And so what's being estimated here is something like that. Now, partially they've done it already and partially in response to my queries, Marco and the others ran a bunch of robustness checks where they dropped various countries, they dropped various pairs. I think that's an okay approach. I'm always a little worried about dropping stuff. I think another way to approach this is just to kind of bite the bullet and figure out how much of your estimation is coming from the top 1,000 grid cells. I suspect it's all coming from the top 1,000 grid cells, in which case you're writing a paper about the top 1,000 grid cells, and that's fine. You're just not writing a paper about, I'm sorry, top 1,000 grid cell pairs, not about the whole world, and that is fine. Last general inference worry is about survivorship bias. So long-run demographic success, like sort of how many descendants you have, as I mentioned before, kind of raises the probability of your being in the data set. And so kind of here's my example, like, an English person migrates to Boston, they produce a lot of descendants as they did, they're going to appear in the genealogical record. An English person migrates to Barbados, they die, or their descendants do, they don't appear in the genealogical record. That's interesting on the subject of demographic success. Well, we don't learn anything about demographic success because they're not in the data set, and we're incorrectly inferring about where the English people went because they didn't demographically succeed. Okay, let me talk something about this agricultural match theory, which is sort of this Crosby thing at the heart of this. So it says the ability to cultivate European crops was an important determinant of migration, demographic success, and so on. There's one big crop that's missing here. Can people say it with me? Maize. Maize was, and that's, by the way, that's Rhode Island Johnny cakes, which are made of maize. Maize in this part of the world was the most important crop. Here's the Native Americans in a very nice picture teaching the Pilgrims how to grow it. You see things like the girdled trees and actually planting between the trees that they had cut down, which were the techniques that they used. I learned about all this from an article by Alfred Crosby on the subject of maize. And so he talks about the demographic success of European settlers, and he stresses the role of empty land and of maize. And here you can just see sort of some of the facts that I pulled from there and other places. Maize was far superior than to European crops for the particular climate, in part because the Indians had tailored it to the local conditions, whereas, over centuries, where the Europeans didn't have time for doing that. It was also, the New England farmers, the ones who we think are so successful from AJR and so on, had low capital, but they had a lot of land, and maize just works really well for that style of agriculture. And here you see in the 1850 census, which is much later, maize dominated wheat as a crop that people were growing. Okay, I think I have like 3 other things to say, so I'll talk super quick. The paper talks about demographic success, which I think is a super fascinating and interesting idea. Putterman and I kind of touch on it, but we don't go anywhere with it, and you have such great tools to do it. In this paper, it's just measured by looking at the migrants themselves and their birth and death. But I think what we really mean by demographic success is some kind of long-run thing about how a population thrives. And this is how I think I would define it, right? This is sort of like measuring an internal rate of return. If we know the population today, and adjusting for the fact that people are partially European and so on, and we know the periods of migration, then we can kind of calculate some I, which is the growth rate of that population. I think you have the tools to do that. You showed us some Portuguese data. Since we're really only looking at migration from a few European countries, I would love to see this. I think you can do it. Super briefly, I did this for the French Canadians. French Canadians are awesome because they all migrated early and then there was no migration. There's their demographic success, 2.4% per year. These must be among the most demographically successful populations in the world, but note really big climate mismatch between Montreal, which is just cold as hell in the winter, and Rouen, which is the biggest city in Normandy, which is the biggest source of the French Canadians, which has this wonderful maritime climate. So I think the demographic success thing is a little different. I'm going to skip that. Last thing on persistence to today, because I'm out of time. I don't like the luminosity measure. This is Raquel's point. Luminosity has two things in it. It has income per capita and it has population density. You have country fixed effects, so what you're picking up is population density. So whether you want to call that development success, I don't know, but it means something different than what you think it means, to the extent it means anything at all. The other problem with the agricultural match theory is that if we look at sort of agricultural GDP today as a function of whether the European crops matched what people grew, that just kind of strains credibility because farmers are like optimizing people and like they're going to grow what's best to grow. Techniques have changed like a huge amount in the last 150 years. So whether the European crop mix was appropriate then or not, like people have had many, many decades to optimize. And what do we grow in the United States of America? Here are the top 20 crops by value. So that's maize, that's not European. Soybeans are not European. Cotton is not European. I don't know what tomatoes are doing there. I like them. And so on. So I think like this agricultural GDP measure is just not picking up this thing. And here's the same for Brazil. So again, you know, soy, cotton, sugar, and so on. So I think it's no longer about the European crops. Thank you.
Is there anyone the question or two? And
Or talk slower.
Hi, Marta Frate again. So super fascinating paper and data. I had a question also on the survivorship bias, but in a slightly different way. And I was just curious to know if you had thought about that and what were your thoughts. That is, to me, the fact that these people have, descendants that now know that they existed 200, 300, 400 years back in time, I'm thinking they must have been pretty successful people. That they have, somehow we know that the descendants know what they were doing all the time ago. I don't know, that would be my hypothesis, but I wonder if you know something about were those people coming from a certain part of the income distribution? My guess would be from the top. Does that matter for your estimates and just any thoughts on that?
all right, let's go, Marco.
How much time? Like 2 minutes, something?
Yes, 2 minutes.
Okay. So thank you very much, David, for the discussion. This was extremely helpful. So I'm trying to address some of the or react to some of the comments on the second moments. Yes, we've thought about it as well, and it's interesting in the paper. This and the others that we have with charts, you can control for seasonality, max temperature, minimum. It doesn't matter too much. We don't think that temperature is the only one. Or average temperature is not the only one, but we think is a nice sufficient statistic that probably people use to make inference. The second point on the pairs, yes, like that's also something that's a good point. As David said, the results are robust. You can exclude one origin country at a time. You can exclude the US. When I saw the list, indeed, the first thing I thought was let's drop the US, and the results are, if anything, stronger. But you're right that like first of all, it's about the pair, and second of all, like we would like to know more about the share of the variation. I think the point on the demographic model is something that actually we're working on, and we didn't have time to include it here. And one big discussion we had with Charles and Alessandra was what the second part of the paper should be, whether the long run development or instead we started with the long run development and then we pivoted towards the demographic model, but we pivoted too late, so we couldn't make it. So I'm glad that you find it interesting. Point taken on luminosity. I think agricultural GDP, and this maybe also speaks to Raquel's point, is not necessarily, of course, the crops have changed and the techniques may have changed, but I think our intuition is that there's some notion of technology adoption that over time, the places with a better ecological match are if the technology frontier remains that of Europe, then it may be easier for you. The technologies that may be developed are better when there's a better climate match. But this is something that we haven't tested. And on Marta's point, we thought about it on this selection. Unfortunately, these genealogical records don't have things like income or anything else. I think there's one dimension, which is if these are the successful people, then probably, and if the non-successful people don't show up because of climate mismatch, then kind of we are recovering a lower bound for the total effect. I still think it may be interesting. It would be interesting to do. For the US, in the modern data, we have a different paper where we use mortality records and we can include household fixed effects. So we compare immigrant brothers who end up in different climates, and we still find very similar results. But in this context, we don't. Yeah. So thank you very much for sticking to the very end.